Remember the night before your board examination or your annual examination? You wonder how much you can study in that one night. And many of the time, it surprises you and instigates you that if you would have done that performance for the whole year, you would have made fortune with your education career. There are some students who do not have missed the concept, do not know the concept, but still have that passion, that one night passion for this coming time till January JEE. I welcome you all to this brand new JEE Crash Course series, the one-shot series that we are starting right now. I am starting with physical chemistry, and this series will be containing hand-curated notes so that it will be concise, not those 10-11 hours of lectures and not only one or single chapter. Like I will combine mole and redox for you because JEE generally make it a packet and ask you such questions. So sit back, relax and gear up for the chapter that we will be discussing right now. The link will be provided to you in the description below. You just have to switch on, log in to our new PW JEE channel or log into the PW app. So students, let's dive into the physical chemistry backbone, mole concept and redox reaction. Here, first we'll be discussing some mole concept basics, followed by stoichiometry and the related problems, which will definitely help you in dealing with the other part of physical chemistry as well. Concentration terms of solution, which will also help you in class 12th solution in colligative properties chapter, and later redox reaction, oxidation number calculation and its applications. So now moving ahead with mole concept. The first thing that we have to remember is Dalton's atomic theory. Sir, we know this since class 9th. No, again. What is it? Dalton said every matter consists of indivisible atoms. Atoms are the smallest unit, is what Dalton said. Although we know this theory is disregarded as of now. Why? Because we know after the discovery of fundamental particles, electrons, protons and neutrons, it is invalid. Dalton also said atoms of same element have all the same properties. Atoms of different element have different masses and different properties. Atoms may reorganize themselves and give birth to compounds. We all know after discovery of isotopes, isobar, allotropes, these Dalton's theory is disregarded. Also, Dalton has nothing to do with the chemical bonding side of inorganic chemistry. But sir, if it has got nothing to do with science of now, why you're telling us NCERT theory is loved by JEE? This question 2024 JEE Mains is regarding you have to select incorrect statement regarding Dalton's law. So you should learn whatever is there in NCERT. The first statement says compounds are formed when atoms of different element combined in any ratio. We have seen it has to combine in a fixed ratio. So it is incorrect and hence your answer. So answer is A. Let's say obviously because mains is single correct, so rest of the option will right, but we are practicing, so we'll see. All atoms of a given element have identical properties. Yes. Matter consists of indivisible atoms. Yes. Chemical reactions involve reorganization. We very well know this. So moving ahead. Coming to the analytical side of the main side of the introduction of mole concept comes from the measurement of atomic masses. Atom we all know is a very small particle. In fact, in nature, atom does not exist in atomic form. It exists as a molecule. So how you can weigh such a small species? Chemistry legends, chemistry ideology people have formulated a proposal. The proposal is based on your day-to-day life. You go to a market, how do you buy products? You go to a vegetable shop with respect to a known mass, a 1 kg bar or maybe a 2 kg bar or maybe a 5 kg bar, you can measure any unknown mass. Vegetables, fruits, rice, grains, dals, etc. Same logic you apply for atoms also. You cannot weigh an atom, but atom combine with another atoms. So with respect to a known mass of an atom, you calculate any unknown mass. So the reference has to be chosen. What reference you choose? You take a 1 kg bar, not a 1.6789 kg bar. So the simplest reference was thought of is the simplest atom. Who is the simplest atom? Hydrogen. So IUPAC, in fact, the whole chemistry lot bunch they decided to formulate the atomic mass, and they have given it a name of relative atomic mass. Relative with respect to a known mass. I will calculate any unknown mass. Mass of one atom of any element is called atomic mass. So here numerator is mass of one atom of any substance, which will be your atomic mass. So relative atomic mass is nothing but atomic mass upon mass of hydrogen. But sir, here hydrogen is not written. You have written some other thing over here. What is it? Actually, the problem was hydrogen do not react with all other atoms. So how can I measure other atom with respect to hydrogen? I have to choose some atom which reacts with. There were many atoms like oxygen, but oxygen, combustion of everything takes place. Combustion is reaction with oxygen. But problem with oxygen and problem with some other atoms was they react with every atom. But in nature, every atom exists in many of their isotopic forms. So what happened was, if I'm measuring, let's say, calcium with respect to oxygen, sometimes in India, the percentage of air oxygen is different. In South Africa, the percentage composition of oxygen is different. So the relative atomic masses experimentally that we were getting, that mass of any atom with respect to oxygen was always different in other places and as per their occurrence in nature, the isotopic occurrence in nature. Carbon also had this isotopic problem. We have C12, C13, C14, but percentage occurrence of C12 is more than 99%. The chance of making an error in those experimental calculation for calculating relative atomic mass was less than 1%. So we chose carbon-12 isotope. But mathematically, we want a simplest denominator. Hence, this 1/12 was introduced. So now, my friends, what is relative atomic mass? You are measuring any atom atomic mass with respect to 1/12th part of mass of C12 isotope. Now, this denominator, even after speaking this denominator so many times, I wish to drink water. So what chemistry guys did was, they started representing this denominator as initially 1 Dalton to pay respect to Sir Dalton. Later on, this denominator was termed as 1 atomic mass unit, AMU. And these days it is termed as 1U, which is unified mass. So what is this denominator 1U? This 1U, my friends, is nothing but mass of one hydrogen atom, which is approximately equal to 1.66 into 10 raised to the power minus 24 gram. Although it is written, I have written it with my hand, but I'm writing it again because it's a very important number. 1.66, 1.67. So this denominator, this 1U, is approximately equal to mass of hydrogen. Moving ahead, if I calculate relative atomic mass of every individual, that value, sir, will be an experimental value. How will I calculate that experimental value? In order to explain you that, let me come back to this photo, this picture. I'm measuring every atom with respect to hydrogen, and with respect to hydrogen mathematically and theoretically with respect to this denominator, 1/12 mass of C12 isotope with respect to carbon. Putting it over here will give me a value. Like I'm telling you, for hydrogen, if I've calculated relative atomic mass, it approximately came out to be for hydrogen 1.008. So atomic mass will be equal to relative atomic mass. This is this many times hydrogen is heavier than this denominator, and this denominator is a U for us. So this is the actual atomic mass of hydrogen, approximately 1 point, because we have to be precise when speaking scientifically. We have to be precise. Sir, if I read such a value for so many elements, it will be a blunder for me. Therefore, I am giving you a common platform for that. What is the common platform? We know an atom. An atom has a nucleus and a revolving electron. Mass of proton and mass of electron, if you take the ratio, it is somewhere around 1837. That is, proton is much heavier than electron. So if I'm measuring this atom, electron has nothing to do with it. It is negligible. So I just have to weigh the nucleus. Nucleus contains protons and neutrons. Summation of protons and neutrons I will refer as nucleons. So basically, if you just want to weigh an atom, just know and sum its protons and neutrons. Keeping this basic in mind, it will be easier for you to remember the atomic masses. Like we all know this. So let me do it faster for you. Number of protons for hydrogen is 1. For neutron it is 0. And because atom is neutral, so number of electrons has to be equal to number of protons. If it is ion, it is not. If it is an ion, this is not true. But for atom, number of electrons is always equal to number of protons. So for carbon, number of electrons will be 6. For nitrogen, it will be 7. For oxygen, it will be 8. For sodium, it will be 11. For magnesium, it will be 12. For potassium, it will be 19. For calcium, it will be 20. For argon, it will be 18. But what I'm asking you, their relative atomic mass, you do not have to do the experiment now. Because relative atomic mass is atomic mass upon 1 by 12 into mass of solid upon U. Do not do that also, because that is an experimental concept. After doing that experiment, what we have observed from Mother Nature is the value that came was a very difficult value. But if you approximate it to an integer, it is equal to their number of nucleons. So what is the relative atomic mass of hydrogen? 1. What is the relative atomic mass of carbon? Proton 6, neutron 6, 12. Although this value practically came out to be 11.96 or 12.0 something. But whatever experimental data that was, if you try to approximate it, thanks to the Mother Nature, that approximated integer is always the number of nucleons. So last one, for argon, 18 plus 22 is 40. For calcium, 20 is 40. Similarly, you can add number of nucleons and write relative atomic mass of any species. But again, this is their closest integer. If average has to be calculated for most of the atoms, this average is number of nucleons, because thanks to the Mother Nature, their isotopic occurrence must also have been in that fashion. Not always true. Let me give you an example for this. For chlorine, if you go to chlorine's house, knock knock, chlorine, 75% of the times who opens the gate? Chlorine 35. 75% of the times who opens the gate? Chlorine 35. Isotope. Remaining 25% of the times, which isotope opens the gate? The bigger brother, the heavier isotope, chlorine 37. If you try to calculate, the average comes out to be somewhere around 35.5 U. Why this? Relative atomic mass is equal to atomic mass upon U. So atomic mass will be equal to relative atomic mass into U. So this U is because of that denominator thing. And this 35.5 is actually the atomic mass of an atom, the relative atomic mass of an atom with respect to the percentage occurrence of its isotopes in nature. For most of the atoms, their percentage occurrence is such that this value is almost closest to the number of nucleons, but not for everybody. But whatever relative atomic masses, whatever atomic masses we know are average only. Although they are integers, you should remember this. Like for nitrogen, I am saying its relative atomic masses is 7 plus 7, 14. It is not exact 14. It is not exact 14. It must be 14 point something or 13.98. What will you write 13.98 to be as an integer? Approximately it is 14. So mathematically you're not doing any error. But you should always keep this thing in mind, that these all values are average. And how can you say that? By measuring, by knowing the atomic mass of chlorine and some other species like chlorine. Moving ahead. This is a question. Now remember, for the question what I said, whenever you do not have to write any theory, sit back, focus, give 100% attention to whatever concept we are dealing over here. Whenever a question comes, what you have to do, pause, now take your pen and copy, attempt that question, and then follow on, and this we'll be discussing this question together. We'll be doing this for each question, but I'm saying this just for this question. So attempt it. You must have attempted it. Let's do this together. First question says that you have to calculate mass in gram of one molecule of water. Water, we very well know it is H2O. Molecule is formed by how many atoms? 3 atoms. 2 atoms of hydrogen, atomic mass 1U, although this 1U is average atomic mass, plus 1 oxygen, atomic mass of oxygen is approximately 16U, average atomic mass is 16U. So molecular mass came out to be 18U, although this is exactly 18U. So I am asking you molecular mass of one molecule of oxygen in gram. Most of you, or maybe some of you, God's grace, if some of you have got 18 gram, my dear students, you are wrong, because one molecule is 18U. And if you have to say, if you have to calculate this mass in gram, you have to put this 1U in terms of gram. And remember, this 1U is equal to 1.66 into 10 raised to the power minus 24 gram. Now 18 into this thing will give you mass of one molecule of water in gram. Similarly, for limestone, what is limestone? Chemistry of limestone, what is limestone? It is calcium carbonate. Similarly, one molecule of calcium carbonate will weigh how much? 40U plus 12U plus 16 into 3 is 48U. So what is the total molecular mass? It is 100U for one molecule. So for one molecule it is 100U. So for 100 molecules it will be into 100. So your answer will be 10 raised to the power 4 into U. What is 1U in gram? 1.66 into 10 raised to the power minus 24 gram. This will be the mass of 100 molecules of limestone. Now, coming to the molar mass. What is this and why used? Thanks to Mr. Avogadro's. Mr. Avogadro said, like for a molecule, let's say again I'm taking water. One water molecule will weigh how much? Sir, 18U. How many 2 will weigh? 8 into 2. How many 3 will weigh? 8 to 3. How many 10 will weigh? Into 10. You do one thing. It's a very smaller mass, no? If you calculate one molecule of water, it is how much? Difficult to calculate, almost impossible to remember. Avogadro said, you see water. Can you see H2 over there? But you can do one thing. What mass term you can easily calculate, sir? Gram can be calculated very easily. Okay. So you keep on bringing water molecules. How many molecules I have to bring? Avogadro said N. So that the molecular mass becomes this 18 only, but in gram. So what is mass of one molecule of water? 18U. How many molecules you have taken? N. Why you are taking N molecules? Because you want to convert that mass into such a unit which can be at least scientifically calculated. So 18 grams. So what is molecular mass of water? 18U. But what is mass of this many molecules of water? 18 gram. Now let us calculate what is this many. So this N, this 18 and 18 got cancelled. So this N came out to be 1 gram upon 1U. Avogadro did this and calculated exactly This value came out to be 6.022 into 10 raised to the power 23 and was called as Avogadro's number, in short 1 mole. So what is 1 mole and what is its significance? That mass of one atom So again, what is this 1 Na? 1 Na is Avogadro's number. Value is equal to 6.022 into 10 raised to the power 23 and it is also termed as 1 mole. Similarly, if you do this for a molecule, if you do this for an atom, like for example, one calcium atom. What is the atomic mass of one calcium? Sir, it is 40U. Is it the exact mass? It's the average atomic mass of one calcium atom. How many calcium atoms you are taking? Let's say 1 mole. And this 1 mole will make the atomic mass of calcium to be 40 grams, which you can easily measure. So for example, if I have 18 grams of water over here, then I cannot see water molecule, but I can definitely say it has 6.022 into 10 raised to the power 23 water molecules. So Avogadro, this 1 mole gave you a context, gave you an idea that molecules or atoms which you cannot even see, you can calculate how many numbers of them are present, that too till 3 decimal places, is the magic of 1 mole. And the mass of 1 mole of any molecule is also termed as gram molecular mass. Similarly, mass of 1 mole of any atom is termed as gram atomic mass, and these masses are also known as molar masses. So sir, if this mole, 1 mole is so significant, like for example, 1 dozen is 12, doesn't make any much of a difference in life, but 1 mole unit makes such a good impact that calculating number of moles is similarly important. Now, is it a very difficult formula? You do not have to derive it. It's a common sense. If your mother asks you to bring, let's say, 24 eggs from market, 24 bananas from market, how many dozen of egg you have brought? 24 divided by 12. Number of atoms upon dozen number. Similarly, number of moles can be calculated. We are defining number of moles. Generally, it is represented as small n. So, if you are supplied with number of substances for atoms, for molecules, if the number of atoms or molecules are given in a question, how can you calculate its number of moles? Given number of atoms, given number of species, it may be atom, it may be molecule, upon, if you have to calculate dozen number, what number you have used, 24 upon 12, the dozen number, because you calculate number of dozens. But if you need to calculate number of moles, what you will do? Given number of species upon dozen number, instead of dozen number, Avogadro's number or molar number, which is Na. So we are formulating it as small n, which is number of moles, is equal to given number of species upon Avogadro's number. Similar analogy, if weight of the species are given, then how will you calculate number of moles? Given weight upon mass of 1 mole of substance, which is already defined, molar mass. Given weight upon molar mass. Sir, but why this given weight is in gram? Because we have recently seen what is the significance of this mole thing. Mole converts mass of any atom or any molecule, for any atom or for any molecule. If you take a bundle, what bundle? A packet. What packet? 1 mole of packet of those substances, that mass directly converts to gram. So because number of moles is a dimensionless quantity, so whatever weight you are supplying in the numerator, you have to put it in gram, because molar mass is always in gram. Similarly, if volume of the substance is supplied, then what will you do? Same. Number of moles is equal to given volume upon molar volume. But there's a catch. Here denominator is known, Na, 6.022 into 10 raised to power 23. Here if the species is given in the question, molar mass you know. But How will you calculate molar volume? It is not always defined because it's not fixed. Every substance will have different volume. So 1 mole of those substances will also have different volume. This denominator is not generalized, but we are generalizing it for one state of matter. That is, this formula I am using only for gases. That too not always. Gases has to be present at standard temperature and pressure. What is standard temperature? It is 0 degrees Celsius. In Kelvin, it is 273.15. But standard pressure, actually standard pressure is 1 bar. But NCERT and JEE and our questions, generally they take standard pressure as 1 atm and they define it. They give it in the questions. So whenever standard of 1 atm is taken or whenever standard of 1 bar is taken, the volume changes. Whenever standard temperature is 1 atm, the volume occupied by 1 mole of gas is 22.4. And whenever this standard pressure is 1 bar, volume occupied by 1 mole of gas is 22.7 liters. And remember, this volume is in liter, therefore number of moles is a dimensionless quantity, and in order to make number of moles dimensionless, the volume of gas in the numerator you have to put should also be in liters. Some people which are not familiar with states of matter ask, sir, you are directly supplying us with a theory to mug up. It is physical chemistry you said in the beginning. No. Let me give you an analogy how we have calculated this molar volume. It is very easy. Gases follow what? Gases follow gas law. What is it? Pressure of gas when multiplied with volume of gas, the product is always a constant, and this constant value for that particular gas is equal to number of moles of gas into universal gas constant, which is a proportionality constant, into temperature of the gas in Kelvin. We very well know this. If you do not know this, learn this. What is gas law? PV is equal to nRT. So what is standard temperature and pressure? Temperature is always 273.15 Kelvin. So put T as 273.15, T known. Value of R I have mentioned over here. We'll do this in states of matter also, but states of matter is not in JEE main syllabus. So you should learn these three values of R: 0.0821, 0.083, and when in joule, PV term when used in joule. In thermodynamics, I'll discuss, but as of now, you should learn this. When this PV factor is in joule, so value becomes 8.314. Using any of these value of R, sir, what value you'll use? As per supply of pressure and volume units. So if pressure is supplied, if pressure is 1 atm, so this P will become 1 atm. Volume, that I have to calculate for how many moles of gas? For 1 mole of gas. So you can calculate this V. This V, when P is 1 atm, R, what is R when pressure is 1 atm? This one. What is R when pressure is 1 bar? This one. So after putting this value, you can easily find 22.4 and 22.7. Moving ahead. Sir, you have given us formula of number of moles also in such a short time. Now let me summarize it for you. What is the summary? Whenever you are supplied with an equation, you are supplied with sometimes masses, sometimes numbers, sometimes volume, but we now know if one molecule reacts with another molecule, we cannot know its weight in grams easily. But if we take their packet, what packet? Their molar quantities, then their mass is always known. So whenever whatever quantity supplied to you, volume, number or weight, you directly find their number of moles and then you interconvert them. How can we do that? Let us browse through some problems on stoichiometry. Sir, moles we have understood. You are telling us how to apply that mole concept over here. But what is stoichiometry? Very easy. From class 9th only, you know balancing a reaction. How you balance a reaction? Sir, for example, this reaction is combustion of benzene. What is benzene? This inorganic and organically you should know. Sometimes advanced does that, mains generally gives you the reaction. But advanced generally hides the reaction and check your organic and inorganic ability, that whether you can frame the reaction or not. So for example, for the sake of simplicity, I'm telling you, combustion of benzene, the organic information behind it is, benzene is C6H6. Combustion is reaction with oxygen. Hydrocarbon always on combustion produces stable compounds. Carbon becomes more stable in form of CO2. Hydrogen becomes more stable in form of H2O. Reaction written. Now what do you do? Class 9th, balance it. So after balancing, you will get these coefficients 1, 5 by 15 by 2, 6 and 3. These coefficients are called stoichiometric coefficients. Why? Because in Latin, stoichio is a term for elements and metry means measurement. How you have got these coefficients? You have got these coefficients by balancing elements. Stoichio, elements, metry, measurement. What are these elements and measurement these coefficients are giving you? They are giving you an idea to read a reaction. How to read a reaction? This reaction is telling you that one molecule of benzene requires plus 15 by 2 as in 7.5 molecules of oxygen to produce what? To produce 6 molecules of CO2 and 3 molecules of water. But you will not speak or read the reaction as molecule. You may, but you should not. Instead, you should keep in mind and use their packet. You can also say 1 mole of benzene requires 7 by 2 moles of oxygen for complete combustion. If 7.5 moles of oxygen are not present, benzene will be left behind. And if 1 is to 7.5 moles are present, 6 moles of carbon dioxide will be produced and 3 moles of water will be produced. So these stoichiometry you should always apply. You can apply for number of molecules, always. You should apply for number of moles, always. So this is a combination of number of moles, common sense with stoichiometry. Let me frame a question for you. I have taken another hydrocarbon, C2H6. What is its name? Ethane, sir. 1 molecule of ethane requires how many molecules of oxygen? 7 by 2. To produce 2 CO2 and 3 H2O, 2 moles of CO2 and 3 moles of water. Now, if I am giving you 30 grams of ethane, my dear friends, how many of you can tell me what is the molecular mass of ethane, sir? Very easy. Carbon 12 into 2 plus 6 into 1. This is total is 24 and 6. So it is 30. So can you calculate number of moles? Yes, sir. 30 upon 30. So how many moles of ethane is given? Sir, 1 mole. Calculate moles. And now use stoichiometry. 1 mole of ethane requires how many moles of oxygen? Sir, although 30 gram is written, but I do not know how much this box weigh or what is its volume. I can always say that 1 molecule of ethane, or I can say 1 mole of ethane. So 1 mole and 30 gram is how many moles? 30 gram is 1 mole. So 1 mole of ethane requires how many moles of oxygen? 7 by 2 moles of oxygen. And how many moles of CO2 will be produced? 2 moles of CO2 will be produced and 3 moles of water will be produced. Now, if question is asking you, and question does do that in such cases, if question asks, do not tell me oxygen required. Tell me weight of oxygen required. So, number of moles is 7 by 2. So, weight of oxygen will be, you can calculate, this weight will be coming in gram upon molecular mass of oxygen is 16 into 2 is 32. Do the math, you will get weight. Sometime what question do is, they do not ask you moles. They ask 30 gram of ethane on combustion produces how many molecules of water? 3 moles of water are getting produced. So how many molecules of water? Upon 6 into 10 raised to the power 23. Do the math. Now, if both the reactants are supplied to you, for example, if same ethane is combining with oxygen, but in the question, both reactants are supplied to you, the amount. So again, we'll do that. So number of moles of ethane present over here is 15 upon 30. Number of moles of oxygen present over here is 56 upon 32. Let us solve it. This is 1 by 2 This is 4, 1 and 14, 4, 8, 32. So this is 7 by 2. So if both reactants are given, we have to first check that whether first reactant is sufficient for, like, this sufficiency part. You understand, like with a common example. Suppose I eat one bowl of dal, I can eat 7 by 2 as in 3.5 chapatis. So in order to eat 3.5 roti, I need one bowl of sabji or dal. If I'm given one bowl of dal or sabji, but I am not given 3.5 roti, then the excess of vegetable sabji will be left behind because I have lesser amount of roti or paranthas. You're getting? So whenever two reactants are given, you have to check whether they are sufficient in order to finish each other or not. Like over here, 1 mole will be requiring 7 by 2. So half will be requiring 1 will be requiring 7 by 2. Okay, I'm sorry, 14 by 8 over here. If you divide it by 2, 7 2 ja 14 and this is 7 4 ja 8. This is 7 by 4. So I can see with the stoichiometry, 1 is requiring 7 by 2 moles of oxygen. So half will be requiring 7 by 2 divided by 2 as in 7 by 4. So actually, my friends, this half molecule is sufficient to react with 7 by 4 molecules, or half mole will react with 7 by 4 mole of oxygen. So both will be completely finished. No excess reagent will be remaining. Therefore, you can use any of the stoichiometry. So 1 is generally easier to do. So I can say 1 will be decomposed and forms 2 mole of CO2. So 1 mole of ethane will be decomposed to form 3 moles of water because 1 mole is getting dissociated or reacted. But if I had 1 mole of ethane, I will be getting 2 and 3 moles. But how many moles of ethane are actually getting reacted, sir? It is half mole. So how many moles of oxygen are getting reacted, sir? 7 by 4 moles. So over here, make that 1 by 2 over there also. So 1 will be giving 2, so half will be giving half by 2. 1 will be giving 3, so half will be giving 3 by 2. So here 1 mole of CO2 produced and 1.5 mole of water is produced. And if again in the question, if over here volume is asked, so volume of CO2 gas upon 22.4, if it is STP as in for 1 ATM. And over here, if it is number of molecules are asked, then n upon 6 into 10 raised to the power 23. It is just the same conceptualization of number of moles logic. But that number of moles you have to couple with stoichiometry. Moving ahead. Now, sir, over there in the examples, both the reactants were sufficient. If there is reagent that is getting finished or somebody is left behind, the concept of limiting reagent comes. I am giving you a thumb rule. The thumb rule is product is always produced as per limiting reagent. This is also common sense. Let me tell you how. Again, taking the same example. 1 molecule of ethane reacts with 3.5 molecules of oxygen. Mole is a better version to say this. 1 mole of ethane reacts with 3.5 moles of oxygen to produce 2 moles of CO2 and 3 moles of water. Last time I'm saying this. So if I need to finish 3.5 roti, I need 1 bowl of sabji, rice, 1 bowl of dal, 1 bowl of vegetables to eat 3.5 chapati. Let us check what amount of roti and chapatis and dal are given. How to check, sir? Calculate number of moles. Number of moles over here are 30 by 30 as in 1 mole. Over here it is 64 upon 32, it is 2. Into divide is the most difficult thing, my friends. Do this very religiously. Now, so how many moles of C2H6 you have? 1. How many moles of oxygen you have? Sir, 2. Now, 1 requires how much? 3.5. So 1 will be requiring how much? 3.5. Are you given 3.5 moles of oxygen? No, sir. You are given 2.5 moles, 2 moles. So this is a limiting reagent. I have less number of roti. I have less number of oxygen. I have only 2 moles of oxygen. In order to finish the complete bowl of vegetable, I needed 3.5 chapatis, 3.5 rotis. But I have only 2 rotis, so some amount of vegetables will be left behind. So you tell me, how many people will eat food or how much of my stomach will be filled? Who will decide that? That extra vegetable is left behind in the plate. It's not consumed. So you tell me, who decides the formation of product? Sir, whatever it is consumed. The reagent which is consumed completely is the limiting reagent. Hence I said product is always formed in accordance with limiting reagent. Now what is this in accordance? In accordance as in you have to follow its stoichiometry. Now you will not say that 1 mole of ethane is creating 2 moles. Why? Because this 1 is not deciding the product formation. Instead of this 1 stoichiometry, I'll use this 3.5 stoichiometry. Why? Because this is deciding how much product is formed. So what I'll say is 7 by 2 moles of oxygen will produce 2 moles of CO2 and 7 by 2 will produce 3 moles of water. Now, I'm giving you a common idea so that you may not commit any mathematical error in examination. Whenever you are given a coefficient, calculate for 1. As in, 7 by 2 will create 2 moles of CO2. So 1 will create how much? This new denominator will go upside. So 2 into this 2 will go to the numerator and this 7 will come to the denominator. So 1 molecule of water will be giving you this much moles of CO2. Similarly, 7 by 2 is giving how many moles of water? 3. So 1 mole of oxygen will be giving you 2 comes to the numerator, 7 goes to the denominator. So this much moles of CO2 is produced and this much moles of water is produced. But by what? By 1 mole of oxygen. Is 1 mole of oxygen is getting reacted? No. So when you always calculate for 1 mole using the stoichiometry, and whatever moles are given, you multiply by that moles. How many moles are given over here? 2. So multiply by 2. Multiply by 2. If x moles are given, multiply with that x. Whatever answer you have got is the number of moles. Again, if weight is asked, number of moles is equal to weight upon molar mass, but that molar mass will be for CO2. If volume is asked, the number of moles is equal to volume of water upon 22.4, but it has to be gas and STP has to be given. So these are stoichiometric questions which you are definitely going to get in your JEE mains examination. Moving ahead. Now, this is Molar salt, a very famous molecule. What is Molar salt? Ferrous sulfate dot ammonium sulfate dot 6H2. I'll just write it another way. We can write ferrous sulfate like this, dot ammonium sulfate like this, dot 6H2. There are certain salts which are double salts. Remember, in the beginning I told you, you need to know how to calculate protons, electrons, neutrons, number of atoms. Like in this molecule, how many atoms are present? This is your first question. Sir, it is very easy. 1 Fe, 1 sulfur, 4 oxygen, then over here nitrogen 1 and this hydrogen 4, 5 into 2. Then sulfur 1 and oxygen 4 is again 5 in this sulfate. Then 6 into 3, 2 and 1, 3. You add them up. This will give you number of molecules. Now, number of protons equals number of electrons for neutral species. Is it a neutral species? I do not see any charge. Yes, it's a neutral species. Number of neutrons, how can you calculate number of neutron? If X is an atom and Z is its atomic number and A is its mass number. A is P plus N, remember, and Z is P, remember. So number of neutrons will be A minus Z. This math I'm leaving you for practice, pause, practice, moving ahead. Sir, you have given a very big question, and why given that question and not answer? My friends, the same question was asked in JEE Advance. Do the question, pause and try an attempt. Moving on to a similar question but from JEE Advance. You know what? In Advance, I've voluntarily picked out the year from there. You just have to understand this logic. The question asked in JEE Advance. Calculate the total number of electrons present in one molecule of CO2. Piece of cake. Carbon has got atomic number of 6, so protons will be equal to electrons because it's a neutral molecule. Similarly, oxygen, one oxygen atom has 8, but there are 2, so this is 16 and 6, which is 22. Piece of cake. Moving ahead. Although I have given you Mohr salt, this is what you find in JEE when you are very comfortable with your concept. Moving ahead, the next question says the average molar mass of chlorine is given. We have already done such a question. The average molar mass is 35.5. Ratio given. See, whatever theory we are doing, it is directly implied with some question. We have already done this question. Take this percentage to be X, so its percentage will be 100 minus X. Solve for that X. You have to calculate ratio of X upon 100 minus X. You can easily calculate. If at all you find whatever questions I am giving you as an homework, if you find any doubt with that, comment and we'll come back to you. Moving ahead, again, it's a question from 2023. It's a match the column, the basics which we have learnt on the basis of that. I guess the first option says 16 gram of methane. We have to pick one of the options. So for such questions in mains especially, look at the options. Option 1 says A goes with P. This says A goes with Q, A goes with Q, A goes with Q. Oh, you just have to check A for P and Q. So P says weighs this much gram and Q says the number of electrons. So let us check 16 gram of methane. Oh my god, 16 gram of methane will weigh 16 gram only. So A can never be P. So A can be, A obviously is Q by looking at all the options. So just for the sake of, we are not here for the sake of answers. I'm just giving you an approach and definitely we'll solve completely. 16 gram of methane as in how many moles of methane? Number of moles is equal to given weight upon molecular mass. So number of moles is simply 1. 1 mole of methane you have, how many electrons are present? So first we calculate number of molecules. So number of molecules will be equal to N upon Na because number of moles is equated by weight also. Number of moles is equated by numbers also. The number of methane molecules will be simply Na. So that means I have 6 into 10 raised to the power 23 molecules. How many electrons? 1 molecule of methane will have how many electrons? Carbon has 6 and oxygen has 1, but there are 4. So total 10 electrons 1 molecule will have. So how many electrons 1 mole will have? 6 into 10 raised to the power 23 into 10. That is somewhere around 60 into 10 raised to the power 23. Absolutely right. So A goes with Q. Now B. The option says B is either with R, S and S. So it is either R or S because A is definitely wrong because A doesn't go with P. Checking for B, 1 gram of hydrogen. Either R or S. So either R or S. It weighs how much? Its volume is how much? So first 1 gram of hydrogen. 1 gram of hydrogen as in, I'll just change the color. 1 gram of hydrogen as in number of moles of hydrogen will be 1 by 2 because given weight upon molar mass. 1 gram of hydrogen. Now you have to tell me how much it weighs. Oh my god, sir, 1 gram will weigh 1 gram only. So similarly, B can never be R. B can never be R. So option B is also wrong. So B is only S. B is S. Occupies this much. 11.2. Half mole will occupy how much volume? So 1 mole occupy 22.4. So half will occupy half of 22.4, that is 11.2. So B is definitely S. So it is either C, option C, or option D. Moving ahead. Option C says 1 mole of nitrogen. So C goes either with R or P. R and P both are weight. So 1 mole of nitrogen. What is the mass of 1 mole? The molar mass. Molar mass of nitrogen is obviously 28 grams. So C goes with P. C goes with P. This is wrong and this is right. Just for the sake of understanding the question, I am checking D also, although in question you do not have to check D in paper. D is going with R, as in 0.5 mole of SO2. R weighs how much? So 1 mole of SO2 will weigh what? Its molecular mass. Molecular mass is sulfur is 32 and oxygen is 16 into 2 is 32. So this equals 64 gram. So 1 molecule weighs 64 gram. So 1 mole will weigh 64 gram. So half will weigh half of 64. That is 32. So D goes with R. Perfect. Picture clear answers. Next question you can definitely attempt. I just read the question for you. It says 5 moles of AB2 weighs 125 into 10 raised to power minus 3 kg. We very well know, sir, atomic and molecular masses, we definitely like it in grams. So I can easily see 1 kg is 10 raised to the power 3 grams. So this minus 3 and kg will definitely give you grams. So that is no big deal. 5 moles is weighing this much. So 1 mole of AB2 will weigh, 5 moles are weighing 125. So 1 will weigh 125 upon 5, which is 5,2 and 5,525. So 1 mole of AB2 is weighing 25 grams. 10 moles of A2B2 weighs 300 into 10 raised to power minus 3 kg. This will also give you grams. What is left? Left is 10 moles is weighing 300. So 1 mole of A2B2 will weigh how much? 300 by 10, which is 30 grams. Now you are asked if molecular mass of A and molecular mass of B as dash kg per mole, calculate A and B. Let us assume molar mass, atomic mass of A is A, small a, and of B, small b. It's a easy question for you now. But when you look at a question, its appearance may be difficult, but when you try to sort it out, it's a piece of cake. So for equation 1, molecular mass will be A plus 2B because atomic mass of A is A, B is B because there are 2, so 2B. So this equals 25 because molecular mass, 1 mole, mass of 1 mole is your molecular mass. This is your equation 1. Similarly, 1 mole of A2B2 as in twice of A plus B is how much? Is 30. So what is A plus B? A plus B is 15. This is equation 2. I guess it's much easier now. Why? Just subtract these equations. 1 minus 2. A is definitely gone. 2B minus B is B. 25 minus 15 is 10. So B is 10. Look at the options. B10 somewhere? Yes, B10. You can take the answer. Obviously, B is 10. Put it in any equation. If B is 10, then A is how much? 15 minus 10. So, A is 5. Option C. Option C. I have deliberately written these answers also at some of the places so that if I'm moving aside, you should pause and try to attempt ASAP. I'm not asking you to make notes, but I'm asking you to please attempt with me so that when I'm solving, it will be much appropriate for you that you are in sync with whatever we are dealing with right now. Moving ahead. You should, again, I'm reading this question for you. The question says, combustion of glucose. Now we have seen this so many times. What does combustion mean? Combustion mean reaction with oxygen. So combustion of glucose produces CO2 and water. We very well know this. The amount of oxygen in gram required for the complete combustion of 900 gram of glucose. What is glucose? Formula is already written. It is C6H12O6. What does combustion mean? Reaction with oxygen. After reaction, what is produced? Sir, we now know CO2 is produced and water is produced. Let us balance the reaction because skeleton equation is unbalanced. In order to apply stoichiometry, first balance the reaction. This molecule has got 6 carbons, so this will be 6. So one molecule will give 6 molecules of, or 1 mole will give 6 moles of CO2. Hydrogen is 12, so here I'll be having 6 moles of hydrogen coming to oxygen. What about oxygen, sir? If you will check, if you will check oxygen over here, if you will check oxygen over here, the stoichiometry, these 6 oxygen are balanced from this side. Now this is 6 into 2, 12, so it will be a 6 over here. Again, after balancing, it's a piece of stoichiometry. 1 mole of this requires 6 mole of this. How many moles of this are present? Sir, moles is not given. Then what is given? Weight. Apply the formula. Number of moles is equal to given weight is 900 grams upon. What is molar mass of glucose? Already given to you in the question, 180. So how many moles you have? 5 moles. Sir, if I had 1 mole, 6 mole of oxygen will be required. So 1 will be requiring 6. So 5 will be requiring 6 into 5 as in 30 moles. Is the question asking moles of oxygen? No, it is asking amount of oxygen. And the amount is given in grams. So what will be the weight of oxygen? Let's say it's W upon 32. So this W will be 3 2 ja 6, 3 3 ja 9. So it will be 960 grams. Is it there in the option? The amount of oxygen required for the complete combustion. 1 is requiring 6. So 5 will require 30. 3 2 ja 6, 3 3 ja 9, 960 grams. Option B. This option will be changed. It will be 960 grams. I'm sorry. We will move to next question. Attempt. This is also a similar question, but on the basis of POC. So first pause attempt by the time I'm reading this question for you. So the question says, if a rocket run on a fuel, obviously we know hydrocarbons are fuel. So if a rocket runs on a fuel, the molecular formula of the fuel is given to be C15H30. And liquid oxygen, the weight of oxygen required and carbon dioxide released for every liter of the fuel. And for the fuel, density is given. What is density? Mass upon volume. So if I have 1 ml of the fuel, how much it will weigh? 0.756 grams, sir. So if 1 ml is weighing this much, 1000 ml will weigh how much? 1000 ml will weigh this into 1000. So this decimal will definitely be removed, and 1 liter of the fuel has a weight of 756 grams. So in a way, it is again the same question in this year of JEE. Same stoichiometry is asked over and over again. Again, you have to do what? Write the equation. What is the equation? This is your hydrocarbon. On combustion, produces CO2 and H2O. What is the first step? Balance the reaction. This is 1. How many carbon dioxide will be released? Sir, 15. Hydrogen is 30. So how much of water will be released? Sir, 15. Balance oxygen. Oxygen is 30 and 15. So over here, it will be 45 by 2. Just the mathematics now. I leave it to you, but let me be again very precise with this. So how many moles of fuel is getting combustion? Molar mass, carbon is 12 into 15 plus hydrogen is 30, it will give you 210. This calculation you have to do religiously, and for that also only I am telling you, sit back with a paper, pen and practice whenever I am giving this question. This lecture itself will be your practice session also. You will be learning concepts also, and we are doing practice also. After the lecture, you will get a detailed practice sheet also. Attempt it and you will be through for the paper. Coming back to this question. 1 mole is requiring how many moles of oxygen, sir? 45 upon 2 moles. So if 1 is requiring 45 by 2 moles, what does, let's say this value is N, how much this is requiring? 45 into 2 into N. This much moles of oxygen is required. Okay. How many moles of CO2 is produced? First do stoichiometry with moles. 1 mole will produce 15 moles of CO2. So N will produce 15 into N moles of carbon dioxide. Is the question asking you moles? No, sir. Question over here is asking you weight. So weight of oxygen will be upon 32 because molecular mass of oxygen. And over here, what is asked? Over here, you are again asked weight of CO2 upon what is molecular mass of CO2? 44. What is value of N? Already given. The last thing you have to do is into divide. That's a piece of cake for you. But if you practice, then only. Else, no. So I leave the practice thing to you. And I guess you will come up with option C. Moving ahead. Pause and I'm reading this question for you. The question says 1 gram of carbonate, the carbonate is M2CO3, on treatment with excess of HCl. Now, we should know this, metal carbonate is a basic salt, is the only inorganic behind it. Basic salt reacts with acid to form neutral salt, and because it's a carbonate, H2CO3, carbonic acid is released, but carbonic acid is an unstable acid. So it decomposes to form H2O and CO2 is the only inorganic you should know. So you are given weight of the salt, carbonate salt, and it reacts with HCl and this much mole of CO2 is produced. So first thing what you have to do is, word is the only problem. Decode this word in a reaction. Now, M2CO3 reacts with HCl, neutral salt will be MnCl. What is the valency? Carbonate is CO3, 2 minus, so M will be 1, M in +1 state. It will be a monovalent cation. Salt will be MCl and H2CO3, unstable acid, decomposes to form H2 and CO2. The question is saying, I have used 1 gram of this salt and this much moles of CO2 gas is released. What is it asking you? It is asking you the molar mass of the salt. It is an integer type question, came in JEE. Now, what is your first step? Sir, it is very clear now. We know this first. We'll balance the reaction. Balance then. How many metal is there? 2. So this will be 2. So this will be 1. What is the number of chlorine over here? 2. So this will be 2. I guess rest 1 and 1. This is balanced. Again, do the stoichiometry. 1 mole of this will produce 1 mole of CO2. This is actually principle of atom conservation also. Atoms cannot be created nor can be destroyed. So doing the stoichiometry or POAC, which is principle of atom conservation, is one and the same thing, because all the carbon over here is going where? It is going there. Hello. So 1 mole of this has 1 mole of CO2 produced. So let's say I do not know how many moles over here are present. So let's say number of mole is N. What is N? 1 upon, let's say its molar mass is A. Let us suppose its molar mass is A. So this is the number of moles. What is number of moles? 1 upon A. So 1 will produce 1. So 1 upon A will produce what? 1 upon A. So what is the number of CO2 that should be produced stoichiometrically? 1 upon A. Value of 1 upon A is given. How much? This many moles, that is 1 upon 100. Oh my God, what's the value of A? 100. Moving ahead, the question says, when 0.01 moles of, yes, so I repeat, when 0.01 moles of an organic compound containing 60% carbon, again it's an organic compound and it is burnt, obviously it will produce CO2 and H2O, but organic compound formula is not given, and we very well know organic compound contains carbon, but it can contain sulfur, halogens, nitrogen, oxygen, various other elements as well. Question is not saying what is its molecular formula, but it is giving you information about the percentage of carbon. There may be another elements. Again, applying stoichiometry coupled with the common sense of principle of atom conservation, POAC. Word is the only problem. I have formulated the word problem in form of whatever you know about the mathematical aspect of chemistry in this question. Organic compound, I know it contains carbon, it has hydrogen, it has many other things, ... Carbon, stoichiometrically, one molecule, let's say it has X carbon atoms. On combustion, reaction with oxygen, produces CO2 and number of other oxides. What are those? I do not know. But I can apply the principle of atom conservation. Why? Because all the carbon present in the organic compound after combustion forms what? CO2. Applying stoichiometry here only. How, sir? If 1 mole of this organic compound, I do not know its formula, but 1 mole will have X atoms of carbon. So if you balance just carbon, because all the carbon is going here as CO2, all the carbon is here. So in order to balance carbon, stoichiometric coefficient X will be here. So again the same thing. 1 mole produces X mole of CO2. What is the number of mole present? The question says 0.01 mole. So 0.01 mole of organic compound. 4.4 gram of CO2 is produced. It is saying 4.4 gram of CO2 is produced. Again, apply stoichiometry. If 1 mole would have been combusted, X would be released. What moles is getting combusted? This much mole. So how much? 1 will produce X mole. So this will produce X into this, which is 1 upon 100. This much moles of CO2 must be produced. Moles is not given, but weight is given. So what weight will be produced? Weight upon molecular mass of CO2 is 44. What is the weight that is getting produced? Sir, 4.4. 4.4 upon 44, this is 1 by 10. So X upon 100 is given out to be 1 by 10. So you have the value of X, which is 10. Now let's see what the question has asked. The question is not asking you about X, it is asking you the molecular mass, the molar mass of the compound. I do not know the molecular, how? Just wait for a second. Percentage composition. What is the percentage? Let's say, You know how to calculate percentage. If in a class there are 100 students, out of them 60% are boys, do the math. 60 upon 100 will be the percentage. Percentage of carbon is given, which is 60%. Use this. How, sir? I do not know the molecular mass of this organic compound. Let's say it's A. It contains how many atoms of carbon? X. One atom of carbon has what mass? 12x. Upon organic compound mass is A. What marks you have got upon total marks into 100 is the percentage, and this percentage is given out to be 60%. Bingo. X I have calculated, it's 10, so this 10 and this 0 will be cancelled. This 6 and this is 2, so A is simply 200 grams. Moving ahead. Now, this is not a question, so I'm not getting aside. And moving on with the basic concepts, which says, what are significant figures and scientific notations? Sometimes for integer type questions, because mains also ask integer type questions, you should know this. Significant figures gives you the precision with which any data is supplied to you. For example, if I have this data, the rule says all non-zero digit are significant. Obviously, if this much weight is supplied to you, what is the precision with which the data is provided to you? If it has all the non-zero digit, for example, 356.8 gram has 4 significant figures because all non-zero digit are significant. 0 before a non-zero digit has no significance. So this has got only 2 significant figures. These are the rules. 0 in between 2 non-zero digit is always significant. So this data has 3 significant figures. This 509 has got significance. This 0, because you can also write it as 5.09 into 10 raised to the power minus 1. So 10 raised to the power has nothing, because scientific notation. I'm just skipping something because you should always know this. Scientific notation is used for data that is very small, very large or very small. For example, the mole number 6.022 into 10 raised to the power, whatever you have, a larger value or a smaller value. We do not give significance to this data. This is a scientific rules that one used to know. So how many significant figures it has? 4. So keeping in mind that this 10 raised to the power has no significance, I can definitely say 0 preceding to a non-zero has no significance. Now, if a 0 comes after a non-zero digit, after a decimal, it is showing you that I have calculated a figure to which till 2 decimal places, I know it is not a 1, it is not a 2, it is a 0. So 0 after decimal gives the precision with which I'm making a calculation. So this 0 has also got significance, and obviously this is a non-zero digit, so this has 3 significant figures. The last thing, exact number of objects. There are 60 students in my class. One person can write 60 as like this. Other person can write 60.0, it is being more precise. Another person can write 60.00. So in order to avoid such a situation, what chemistry guys, what scientific notation guys, what precision writing guys said, what scientists said, that exact numbers will have infinite number of significant figures. You keep on doing this. I'm saying the exact quantity, like 6 eggs, 40 tables. How many significant figures it has? Infinite. Moving ahead. After significant figures, you should couple up that concept with the concept of rounding off. If I am supplied with some data, because in JEE mains also, advanced also, you have to report the answer with the significant figures precision. It is very important to report answers in such cases. Suppose you are adding 3 numbers. Addition, I trust you know, although doing it properly is a altogether different game which requires lots and lots of your practice. But coming to the rule side of it, if you add a number, you first do the addition part. what is the answer that you'll report? You will report your answer is only that many significant figures in which the data supplied has got the minimum one. For example, the first data has got how many significant figures? 4. This one has got 3. This one has got 2. So what surety you will have that the answer will be definitely this? I cannot say about the later digit, but for this many digit, I am very confident about. The minimum confidence that you can give is till 2 significant figures. So your answer should be containing that many significant figures, which should be the lowest of the given data. The lowest of the given data has 2 significant figures, so you can only report in 2 significant figures. What is the answer that you got? This much. But I can only report in 2 significant figures, that is this 6 I have to take, but I have to stop after 1 decimal because 2 significant figures 2, I have to stop till 5. Now, rounding off concept, which you very well know, comes. If the number next to 5 is a number like it is 1, it is less than 5, answer will be this 5 will be as it is. So if the number next to me is less than 5, I will remain as I am. This you know. I'm subtracting, it has got 4, it has got 4, it has got 2, so I will again answer in 2 significant figures, so I have to answer 2.8. Now this 8 will be increased, decreased, or what? Rounding off. If the next digit is larger than 5, you have to increase by 1, so answer will be 2.9. Here it is 6.5. Moving ahead. Multiplication, same logic, do the maths first. It has got 3 significant figures. It has got 4. It has got 2. I will report my answer in 2 because that's the lowest. So I can report answer only till here. 2 is done. Rounding off required. If it is less than 5, it is as it is. More than 5, increase by 1. If it is 5, even remains even. But if it had been odd, increase it by 1 to make it even. Like division, significant figures, 3 and 3, 6, 2. So I'll report answer in 2. So I have to stop till here. If it is 5, odd increases by 1 and becomes even. So these are the rules for rounding off. Moving ahead. Some basic definitions. You pause. I also take a water break. Moving forward with some basic definitions. Obviously, it will be helping you in atomic structure as well. Some definitions like what are isotones? Isotones are species which have same number of neutrons like potassium and calcium. Protons present are 19 and 20. What is number of neutron? Number of neutron is mass number A minus atomic number Z because it's similar. So proton number of neutrons are similar for two species, they are termed isotones. What are ions? Remember I said this. Atoms have same number of electrons, but ions, if I form a cation, what I have to do? I have to lose electron and forms a positive ion called cation. Example, sodium. Sodium has 11 as its atomic number. Number of proton never changes. Number of protons stays right there inside the nucleus. What get transacted? Only electrons. They may be lost, they may be gained. If lost, forms a cation. So Na plus has lost 1 electron and forms sodium ion. So number of electrons in Na plus will be 10. Similarly, that's an ammonium ion. Lots of atoms may also form a cation. The cation, ammonium cation is NH4 plus. What are anions? When you gain an electron, you becomes negatively charged and you are termed as anion. Number of protons remains the same. For example, chlorine has atomic number 17. Gain 1 electron, number of electron in chloride ion will be 18. 17 plus 1 because it has gained. Similarly, you can have some complex anions also like dichromate, Cr2O7. Overall 2 chromium, 7 oxygen forms Cr2O7 and it gains total 2 negative charge. There are some important cations and anions which we'll be discussing later. What are isosters? Isosters are basically species which have same number of atoms. Very often you may find they may have same number of electrons as well. For example, CO2 and N2O. N2O, mind you, it's nitrous oxide, laughing gas. Number of atoms are 3 only. Yes, isosters, but you will calculate number of electrons. They are also same. Last is isodiaphers. What are isodiaphers? Isodiaphers are species which have same difference of neutron minus proton. Neutron minus proton, if you calculate for fluorine and sodium, you will find both have 1 neutron minus proton difference. So, moving ahead after these definitions to the basic law of chemical combinations. Although JEE is not much interested with them, but yes, few questions have been found, so I am discussing over here. We'll make it a bit quicker. First law of chemical combination is law of mass conservation. We very well know this. Mass cannot be created nor can be destroyed. For example, if a salt is getting thermally decomposed, calcium carbonate 10 gram is getting thermally decomposed, mass cannot be created nor can be destroyed. Reorganizing and forming calcium oxide solid and CO2 gas, if it is x gram, it is 4.4 gram, calculate x, 10 will be equal to x plus 4.4, you will find x. Law of chemical combination, although we know why it is not as much, because all these chemical combination laws has got some limitations. Like law of chemical combination, it is not at all valid for nuclear reaction. Whenever nucleus decay, lot of energy is produced, and through Einstein we know E is equal to mc square. Sometimes mass equals energy, and whenever energy is associated, this mass conservation never applies. So moving ahead, law of definite or constant proportion. Water obtained from any source, doesn't matter how it is made. If it is made, weight of constituent elements will always be definite or fixed. Although this also, like for water, weight of hydrogen and weight of oxygen, oxygen upon hydrogen ratio will always remain same, fixed, which is 8:1. Although it has got some limitation which we already know. For example, if there is an heavy water is deuterium water, D2O, then this ratio will become different. It will not be fixed. Hence, I already told you, law of chemical combination, not generally asked, but you should know them sometimes. A few questions. Like the Dalton one, therefore you should know them. Next is law of multiple proportion. 2 atoms can form millions of compounds. Number of compounds, easy to say, right? Million is a huge number. For example, hydrogen and oxygen are combining to form water also, hydrogen peroxide also. If you calculate weight of these constituent atoms, like in water, 2 gram hydrogen is reacting with 16 gram oxygen. In peroxide, 2 gram hydrogen is reacting with 32 gram oxygen. If you fix the mass of one atom, let's say hydrogen of mass is fixed. So with this fixed mass of hydrogen, what is the weight of oxygen that is getting reacted? For water, 16 gram is reacting. For peroxide, 32 gram is reacting. So if you calculate the ratio of weight of oxygen that is combining with the fixed weight of other element, this ratio will also be a simple number. This ratio will also be a whole number. Like over here, the ratio is 1:2, or whole number, it is 2. So it's always a simple ratio, is the law of multiple proportion. Although when elements undergo catenation, like for carbon, catenation is a property because of which so many compounds of carbon exist. So again, there is some limitation. For catenation cases, does not hold true. Law of reciprocal proportion, although I have given you an example, but moving ahead, because not much of question is asked, but still I have included this in slide. Those who want to read them, the PDF will be given, you can read them, not generally asked. Gay-Lussac's law of gaseous volume, my dear friends, one of the very important law of chemical combination. See, I told you, you can always apply stoichiometry for what? For number of molecules. For moles of molecule, you can never apply that stoichiometry for mass or volume. For mass, you can never do that, because that box, how much it weighs, I do not know. The stoichiometric coefficients can only be used for molecules and moles. But Gay-Lussac gives you an advantage, because he knew something which we know right now. gas follows ideal gas equation. So if pressure and temperature of a particular reacting gaseous mixture is similar, PV equal to nRT, pressure and temperature are similar, so volume becomes proportional to moles for them. So Gay-Lussac's law says that the stoichiometry that you use for moles, you can also do that stoichiometry for volume also, but not always. Only when participating species are gases and those gases are at similar temperature and pressure. Like if hydrogen gas is reacting with nitrogen gas and producing ammonia, I can always read this reaction as 3 moles of hydrogen reacts with 1 mole of nitrogen to form 2 moles of ammonia. But because all these participating species are gases, and if it is mentioned in the question that the pressure and temperature of the gas are same, then you can also say 3 liters of hydrogen or 3 ml of hydrogen or 3 volume of hydrogen reacts with 1 volume of nitrogen to produce 2 volume of ammonia. This is Gay-Lussac's law, which you will find very useful while JEE questions. Moving ahead. Gay-Lussac's law is also a law for gases. It says equal volume of gases at similar temperature and pressure should contain equal number of molecules. This is also a direct application of PV equal to nRT. That's why I told you PV equal to nRT initially only. Let me give you the mathematics. PV is equal to nRT. We know this, sir, only for gases. So if you have same temperature and pressure, temperature, both are constant, R is also a constant. So volume become proportional to moles. Gay-Lussac's also have seen this. It just have given one more essence that we know number of moles is equal to number of molecules upon Na. Na is a constant, so this can also go to this proportionality. So I can also say volume is proportional to number of molecules. This will also help you in many of the questions. Moving ahead. Now this is a question, direct application of Gay-Lussac's law, Avogadro's law. The question says, although you can pause, attempt, but I'm just reading it out for you. 10 ml of gaseous hydrocarbon on combustion gives 40 ml of CO2 and 50 ml of water vapors. Gaseous hydrocarbon is carbon and hydrogen. On combustion, again reaction with oxygen. Just look at this, my friends. How many times a similar pattern has been asked? Concept gets repeated. It produces CO2 and water. The question is saying you are getting 40 ml of CO2, you are getting 50 ml of water, and when you are getting this, when you are getting combustion of 10 ml of hydrocarbon. Now you have to tell me number of carbon and hydrogen present in this hydrocarbon. Carbon is X, hydrogen is Y. You just have to calculate X and Y. How to calculate? Stoichiometry. Sir, first balance the reaction. If it is 1, this carbon will be X over here. If it is 1, this hydrogen will be, because that's Y over there, so it will be Y by 2. And this oxygen will come out to be the stoichiometry. From here 2x, from here Y by 2. So the coefficient I'm taking as X, because X into 2 will make it 2x. And that is Y by 2. But here I have to write Y by 4. Why? Because when this Y by 4 will be multiplied by 2, it will become Y by 2. So the stoichiometric coefficient of 1 mole of this will react with X plus Y by 4 mole of this to produce X mole of this and Y by 2 moles of this. I am told you. When participating species are gas, you can use this stoichiometry for volume also. But sir, here pressure and temperature are not given to be same. My dear friends, a reaction must be taking place in a container or maybe in a room. The room will have the same temperature and pressure for all the participating species. So sometimes that temperature and pressure being same has to be kept through your basic common sense, because sometimes the question hides it. So using that Gay-Lussac's approach and using directly the stoichiometry with volume, I can say 1 ml will create X ml of CO2. So 10 ml will create 10x ml of CO2. The value of CO2 produced is given, it is 40 ml. So X is directly 4. Bingo. 1 ml will produce Y by 2 ml of water. So 10 ml will produce how much? 10 into Y by 2 ml of water vapors, which is given out to be 50. 0 gone. Y is 10. X is 4. Y is 10. 10 plus 4 is 14. Moving ahead. I'm reading this question for you. 56 liter of nitrogen gas is mixed with excess of hydrogen, and it is found that 20 liter of ammonia gas is produced. You have to tell me unused nitrogen. Nitrogen must be in excess. In that case, the question is telling you 2022 question. Write the reaction. So now it is getting very easy for us. Beta, trust me. You just have to build that confidence with labor. JEE is actually a piece of cake. Balance the reaction. 2, 1, I'm sorry, H2, and then 3. Read the stoichiometry. Sir, 1 mole will react with 3 by 2 mole and produce 2 mole of ammonia. Question is saying, I'm giving you 56 liters of nitrogen. It is in excess. It is found that 20 liter of ammonia is produced. You have to tell me unused nitrogen. Sir, 1 will require 3. This is remained unused because it is given in excess, but this excess value is also limited for this. That's why it will remain unused. Look at the beauty of the question. The English word is the only problem. Although the question is telling you we have excess of hydrogen, but that excess of hydrogen is also limited for the volume of nitrogen given. How do I know this? English, because it is saying unused nitrogen gas. There will be some unused nitrogen gas. So word is the only problem. That's why I'm making this thing a point. Theory is not a big case, not a big thing to study. Attempting question. So whatever question I'm giving you, pause, attempt, and then proceed so that you may sync with whatever the delivery of the solution you're getting. Okay. Now, because hydrogen is getting finished, so I'm using this 3 as the limiting reagent coefficient, and product is always formed according to limiting reagent. So 3 will be creating 2 moles of nitrogen, but for gases, volume stoichiometry can also be used. So I can say 3 liter will be creating 2 liter of ammonia. So 1 will be creating 2 by 3 liters of ammonia. How much hydrogen gas is getting reacted? Let's say X. So how much ammonia will be produced? 2x by 3 liters. And this volume, question has given that how much is produced? 20 liters is produced. So what is X? Sir, 30 liters. So how much hydrogen is used? 30 liters. 3 will be requiring what liters of nitrogen? 1. So 3 requiring 1. So 1 requiring 1 by 3. So 30 will be requiring into 30. So how many liters of nitrogen will be used? 10 liters. What the question is asking? Unreacted, sir, 10 liter is used. 56 was given. So unreacted is 56 minus 10. Moving ahead. The question says, the next question says, consider. So again, this 2024 question has given you a balanced reaction. It says PbCl2 reacts with ammonium phosphate. I'm sorry, this ammonium phosphate is PO4 3 minus, so it will be 3 over here, to form lead phosphate and ammonium chloride. You are given PbCl2 and you are given ammonium phosphate, and you are supposed to tell me how many millimoles of this product is formed. So again, because the question is 90% of the question is done, because they have already supplied you with the balanced reaction and they supplied you with the data. 72 millimoles of this, 50 millimoles of this, and how many millimoles will be produced? Again, simple stoichiometry. See, same questions. Again, do that stoichiometry. What is that, sir? Sir, 3 will be requiring 2. So 1 will be requiring 2 by 3. Because 2 are given, we have to check whether they are sufficient for each other or not. So 72 will be requiring how much? 3 2 ja 6, 3 4 ja 12. So this is 48 millimoles is required. But how much it is given? 50. So it is excess. And because it is excess, so who will decide the product formation? This is your limiting reagent. So I will use this stoichiometry. I do not use 2 because excess will not decide how much of the people are fed. Remember, 1 vegetable, 3.5 chapatis, whatever is limited will decide how much I ate, how much is produced. I'm just asked about this, so I'll just focus on this stoichiometry, as in 3 will be producing 1. So 1 will be producing 1 by 3. How many moles are getting reacted? 72 millimoles. So how many will be produced into this? 1 by 3 into 72. So again 3 2 ja 6, 3. So 24 millimoles. Piece of cake. Moving ahead. The next question says, in a given reaction, X and Y, again, it's a balanced reaction. That's why I didn't stop. Moving ahead. It is saying 1 mole each of X and Y is getting reacted. So 1 mole of this and 1 mole of this. And 0.05 mole of Z. 0.05 mole. Sir, 1 will require 3 times of this. It is given 0.05. So 1 will be not reacting. They are excess. This is limiting reagent. Product is always formed in accordance with limiting reagent. So I will say 3 moles will be forming 1 mole of product. You are given the atomic masses of X, Y, Z, and you are asked what is the yield of this product. Simple. If 3 would have reacted 3 moles of Z, 1 would be produced. If 1 mole of Z would have been reacted, 1 by 3 moles will be produced. How much of Z is actually getting reacted? 0.05. So how much will be produced into the moles that are getting reacted? This thing. Answer. This is the moles of the product formed. What is the answer? Acha, you have to tell me the product in grams. That pause thing also helps in sipping water. So this will give you the weight in gram. Moles is not asked. So how much weight is produced? I do not know. But whose weight is it? Of the product. So whose molecular mass you have to use? Of the product. What is the molecular mass of the product? Molecular mass of this. Atomic mass add. X is 10. Y is 20. Z is thrice of Z. So 3 times of 30 is 90. This is 120. So W will be equal to 120 by 3 into 5 upon 100. This is 4 times. This is 1. This is 2. So answer is 2 grams. 2 grams. Moving ahead. Next question says you have to consider this reaction, again a balanced reaction, a question of 2022. You are supposed to tell the questionnaire, the examiner, what is the amount of HNO3 required to produce this KNO3. Again, Balanced reaction is given. Your job is to just write the clean reaction. And your job is, now in such questions, your job is into divide. So pause, practice and perform. HNO3 molecular mass you have to calculate 63. KNO3 molecular mass you have to calculate 101. Do the math. It is, question is asking how much of this will be reacting. I do not know, X gram. How much of that will be produced? Question has given you. Question has given you 110 gram of the product is produced. Do the back stoichiometry, back unitary method, as in 3 moles of this will be produced when 4 mole of HNO3 would have been reacted. So 1 mole of this will be produced, that will be produced when 4/3 mole of this would have been reacted. How many moles of this is getting reacted? Let's say N. What will be the value of N? I will write that N over here. N will be equal to given weight upon molecular mass, which is 101. This is the moles that are getting produced, N. So if this is the moles that will be produced, how many moles would be required, sir? 1, 4/3. So N into N. So this is the number of moles that will be getting reacted. Are you asked number of moles? No, you are asked weight. We have assumed that weight to be X. So what X has been created, sir? X upon molecular mass of HNO3 is 63. So X will be equal to 63 into 4/3 into N, which is 110 upon 101. Do the math. And I guess you will find your answer to be into divide you have to perform. Moving ahead. The next question says CNG. Again, attempt the question. It says CNG is an important transportation fuel. So when this CNG fuel is getting combusted, and the question has already given you that this CNG is methane. We very well know CNG is a compressed natural gas and it is basically methane. So it's a chemistry in every life question as well. Methane on combustion, simply methane on combustion produces energy. And why does it produces energy? Because combustion of fuels releases energy. Combustion is an exothermic process and it will produce, chemically it will produce CO2 and H2O. The question saying that 100 gram of methane reacts with 208 gram of oxygen. That means both the reactants are given. Again, what you have to do, just write the balanced reaction and you have to calculate amount of carbon dioxide produced. So again, this is the part that is most difficult. Why? Word problem. Words are the only problem. Methane requiring oxygen, producing CO2 and heat. Balanced reaction, from 10th standard you can write this. So 1 will be requiring 2 moles. How many moles are present over here? 100 upon 16. How many moles are present over here? 208 upon 16 into 2 is 32. First, I have to check whether they are sufficient or not. Do the math. 100 by 16 is somewhere around 6 point something. So 1 is requiring 2 moles. So 6 point something will definitely be requiring 12 point something. I guess this is much lesser. If you will calculate it, it is somewhere around 6 point something. I can very well see, you can also calculate. So 1 is requiring 2, so 6 will be requiring 12. It is not given out to be 12 moles. It is much lesser, sir. So this is your limiting reagent. And who will decide the product? This stoichiometry. I cannot say 1 produce 1. I have to use 2 because this is the limiting reagent. So 2 moles will be producing 1 mole of CO2. So 1 mole of oxygen will be producing half mole of CO2. So if this value is N, so these N moles will be producing N by 2 moles of CO2. Answer. Is the question asking you moles? No. Weight X upon 44. Do the math, you'll find the answer. Moving ahead. The next question says, production of iron in a blast furnace follows the reaction. Again, a balanced reaction is given to you. This following reaction is again given out to be a balanced reaction. So just skipping the same scenario, the balanced reaction given, the maths you just have to do, calculate its molar mass because atomic masses are also there. If you calculate moles, then you just have to remember one thing, number of moles is equal to weight in gram. Here weight are given in kg. How will you convert in gram? In 2000. So number of moles will be equal to this weight in gram upon its molecular mass. This weight in gram upon molecular mass, this moles comes out to be 20, these moles comes out to be 90. Do the stoichiometry. Only the mathematical part is difficult and time consuming, which will only be enhanced if you practice. So 1 will be requiring 4 moles. So 20 will be requiring 80 moles. How many moles are given over here? 90. So this 90 makes it an excess reagent. So this becomes limiting reagent and it will decide how much product is produced. What product you are asked? Iron. 1 will be producing 3 moles of iron. So 20 will be producing 20 into 3, that is 60 moles. Is mole asked? No sir. Weight asked. Let that weight is X upon atomic mass of Fe given out to be 56. So this will be your answer. Moving ahead. Now, this question says that a reaction is given to you and 3.9 gram of benzene on titration. I beg your pardon. It's nitration, not titration. What is nitration? Concentrated sulfuric acid and concentrated HNO3, when in organic we'll discuss this, they produces an electrophile which attacks electron-rich benzene ring. So this electron-rich benzene ring is substituted, one hydrogen is replaced and NO2 is added. This is the organic chemistry behind it, but when applied mole concept, it's a piece of cake for you. But there's one thing. This question is asking you the percentage yield. So this is also a type of question. What is percentage yield? Again, the percentage thing. How much product you have formed upon how much investment has been taken into account. So numerator upon denominator into 100 will give you the percentage. For example, I'm simplifying this reaction like this because mathematics you have to do with your hard work. I've done some of that for you so that we can enhance the class. We can speed up the class. Benzene getting nitrated forming nitrobenzene. The weight given is 3.9 and 4.92. You are asked the percentage yield. Okay. Calculate number of moles. How to do that? Given weight upon molecular mass. Molecular mass of benzene is 78. This comes out to be 0.05. Although this is the most time consuming job, but my friends, that is your hard work that you have to do. I'm giving you the concept. And I have to do this because I need to save time. What moles are getting produced? Amount of product produced is given. So amount upon molecular mass of this is 123. So 0.04 moles of this is getting produced. If you apply stoichiometry, if you just apply stoichiometry, I can say by principle, because byproducts I do not know, but principle of atom conservation mixed with stoichiometry can be used. All carbon present over here is going over here. So if 1 mole of this will be reacting, 1 mole of this will be getting produced if efficiency is 100%. Until now we have not just seen any efficiency questions. If efficiency would have been 100%, 1 will be creating 1. So N will be creating N. What is moles that are getting reacted? This is my value of N. So if 1 is producing 1, so N will produce N. So N should have been produced. But how much is actually getting produced will give you percentage. The question is giving you that this much weight is produced. So this is produced. This is the actual product produced. This is the actual product formed, I'm marking it as, let's say, B. But if 1 would have formed 1, if 100% would have been the efficiency, so N would have formed N. So what will be the percentage, my friends? How much it is produced? B. How much it should have been produced? N into 100. So this B is 0.04. So this is 4 by 5 upon 100. Solve it, you will get your answer. Moving ahead, the next question says NaClO3 is used even in spacecraft to do what? To produce oxygen. And how you are planning to produce this oxygen gas? The reaction says when this NaClO3, this 3 is not written, this solid is reacted with iron Fe. A reaction takes place and oxygen gas is produced along with production of NaCl and FeO solid. Again, what you have to do, it's a balanced reaction. Something I have curated for you to be fast. NaClO3 reacts with Fe forming this, this and this. But you are asked what amount of this fuel is required to produce enough oxygen, and the moles of oxygen is not given to you. They have beautifully used that oxygen is a gas. And for gas, we follow PV equal to nRT. So they have given you in the question that how much oxygen you have to produce, that much oxygen you have to produce, which is sufficient for a person. And how much oxygen is sufficient for a person? This much liter at 1 atm and this Kelvin. Sir, at least number of moles are given only. How? We know PV is equal to nRT. So here this number of moles which has been hidden in the word problem. How will we calculate number of moles produced? Sir, it is nothing but pressure, which is 1 atm. Volume, which is 492 upon R. In question it is 0.0821. But sometimes when integer type questions are asked, they wish to direct you to do proper mathematics. So they have specially asked you to take 0.082, not 1. So this will be the value of R into the temperature in Kelvin, which is 300 Kelvin. So this will be the value of number of moles N. A very tedious and a very sophisticated task to do in the paper of JEE. Sometimes such questions are asked so as to check whether what is your level of hard work that you put in your home. So do that. Put in your home as in practice doing calculations. So this will be the number of moles produced. Because it's a balanced reaction, so 1 mole of this will be producing 1 mole of this. So how many moles of oxygen you have to produce? N moles. So 1 will be requiring 1, so N will be requiring N moles of this. You know the value of N. But is the question asking you moles? No, it is asking you weight. So what will be this? This N will be equal to weight, which is X, upon the molecular mass of NaClO3. What will be its molecular mass? 23 plus 35.5 plus 16 into 3 is 48. So this summation will give you molar mass. N, you know, molar mass, I have helped you. You sum it up and find the value of X, and it will definitely come out to be 2130. Moving ahead. The next question says a 10 milligram of a tablet. A tablet is an effervescent tablet containing. So basically an effervescent tablet are all those biological tablets which you consume when you get acidity in your stomach. Actually, effervescence is a property of any substance to release CO2 gas, because whenever CO2 gas is released, it releases with that effervescence sound is produced by CO2 gas. So the question is telling you that you have a mixture of sodium bicarbonate and oxalic acid in a tablet. The tablet is weighing 10 milligram. It produces CO2. Now you have to tell me what amount of sodium bicarbonate is, what percentage of sodium bicarbonate is present in that mixture. Now this type of question is also new for us. Why? Because percentage composition of the reaction mixture is asked in these types of question. Again, what is the most important thing? Design this word problem in a chemistry way, which I have done it for you. Look at it. Sodium bicarbonates whose molecular mass is already given, it reacts with oxalic acid. This tablet is 10 milligrams. They produce, now this reaction is not given over here. So this is a common sense of inorganic and organic. Why organic? Because carbon is also there. Why inorganic? Because these reactions you will also see in some of the inorganic side of chemistry as well. So this information I'm giving you, you can also predict that it's an oxalate, C2O4 2 minus is an oxalate ion. So sodium oxalate will be formed, followed by water and CO2. After writing the reaction, first you have to know the reaction. After writing the reaction, you have to balance it. Now the CO2 produced, I will focus my stoichiometry over here and in sodium bicarbonate. So let us say 2 moles of sodium bicarbonate will produce 2 moles of CO2. So 1 will produce 1. So whatever moles, n moles will be here, those n moles will be produced. Now, first job is moles of CO2 produced you have to calculate. How to calculate, sir? Question has given these many details about CO2 question. Again, like the previous one, question has hidden the number of moles. Question has actually given you volume, temperature, pressure. Sir, we will do PV equal to an RT. No, you can do that, but value of R is not given. And the question has helped you also. The question has supplied that molar volume of CO2 and this particular, because whatever volume, molar volume value we know for our standard STP. That was 22.4 or 22.7. For this particular temperature and pressure, the question is supplying you with this data that molar volume is 25 liters. So why to do PV equal to an RT? Do the calculation for number of moles using the formula volume occupied by CO2 in this particular case upon molar volume in this particular state, which is given out to be 25 molar volume. So this number of moles can be easily calculated. What is 0.25? Acha. Because this volume is in liters, so I have to supply this volume also in liters. This is given in ml, so 0.25. What is 1 milliliter? 1 milliliter is equal to 10 raised to the power minus 3 liters upon 25. So what moles you have come up with? It is directly cancelled, 25, 25. So this is 10 raised to the power minus 5 moles. Now, 2 moles of CO2 will be produced when 2 moles of sodium bicarbonate would have been reacted. So 1 will be produced when 1 would have been reacted. So n will be produced when n would have been reacted. So now I know number of moles of sodium bicarbonate reacted that will be present. Therefore, they are getting reacted. So I know moles of sodium bicarbonate getting reacted. But moles is not asked. What is asked? Weight. In this 10 gram of mixture, let us assume weight of green only. Weight of sodium bicarbonate is x gram. Then of this oxalic acid will be 10 minus x. Okay, it is milligram. So this is x milligram. So this will be 10 minus x. I am not focused in this because I am focusing my stoichiometry only into this. I know what moles of this is present. What moles of this is present? N moles, which is 10 raised to the power minus 5 moles. So I know its number of moles. So number of moles is given weight. What is your weight? X. But you have to supply that weight in gram because it's milligram. 1 milligram is equal to 10 raised to the power minus 3 grams. So this weight is in gram now. What is its molecular mass? 84. What is the number of moles that is present? That has been produced in form of CO2, which is 10 raised to the power -5, because these n moles will be present, hence they are getting produced. The stoichiometry thing. You can easily calculate x from here. I guess it's 84 10 to the power -5 -3, so it is 10 to the power -2, that is 0.84. So this is the milligrams of sodium carbonate present. What are you asked in this question? You are asked what is the percentage of sodium carbonate. So how can you calculate the percentage? Sir, weight of sodium carbonate, which is x, upon total weight of the tablet, which is 10 into 100. So what will be your answer? 10x. Do you know the value of x? Yes, sir, 0.84. So what is 10x? 8.4. Moving ahead. The next question says a sample of magnesium carbonate and calcium carbonate. You are given with two salts. So because we are supplied with two salts, again it is a question of composition mixture. Like I have calcium carbonate and magnesium carbonate whose total weight is given to be 2.21. Let us assume it's the same question for the tablet one which we have done. Let us assume calcium carbonate is x gram. So the magnesium carbonate will be 2.21 minus x. And in the tablet question, you had to calculate the percentage composition, but over here, percentage is not. The options are simply telling you, you just have to calculate their weights. So calculate x and obviously 2.21 minus x will be easily calculated. Molar mass of these are given now. Again, the most important thing is the curation of the chemistry behind this word problem. Again, helping you with it. This reaction you know since class 10th. Calcium carbonate, it's a solid. On heating, it forms what? Calcium oxide, CO2 gas released. Magnesium carbonate, every carbonate salt on thermal decomposition forms their stable oxide and oxygen gas is released. The English is telling you when you heat such a sample, after ignition, the constant weight is found to be 1.152. Now, why weight becomes constant and has decreased? Sir, if you have heated a solid, gas has gone out. Whatever residue is remained is the solid. So, actually weight of this calcium oxide produced and weight of this magnesium oxide produced independently, the summation of the weight is given. So what you have to do now? Sir, after all this, do stoichiometry. So doing stoichiometry, my friends, why getting angry? Again, it's a balanced reaction. So 1 mole of this will form 1 mole of this. What is mass of 1 mole? The molecular mass. So that is 100 gram of calcium carbonate will form. I've calculated this molecular mass, which you must do while practicing. 100 gram of this will give you 56 gram of calcium oxide. So 1 gram will give you 56 upon 100. How much mass we have assumed? Let's say it is x gram. So how much mass of calcium oxide will be produced? This much gram of calcium oxide will be produced. Doing the same stoichiometry, it is also balanced reaction. 1 gives 1, so 84 gram. Sorry, gives 40 gram. So 1 gram will give 40 upon 84. What is the mass? 2.21 minus x will give this much grams of magnesium oxide. Let's say this weight is A and this weight is B. The total weight you know. Why? It is ignited to a constant weight of 1.152. So, this A plus B is given out to be 1.152. This is, okay. 1 gram will give this much of gram. How much gram of calcium carbonate you have assumed? You have assumed x grams of. So if this is x, so this will be an x. So it's a variable in x. It's a variable in x. One variable. Now, the most difficult part is Actually, the most practicing part is the calculations involved. If you calculate it, you'll get X, and subtracted by 2.21, you'll get the mass of magnesium carbonate. These questions are asked a lot of times. Sometimes the calculations requires too much of practice. Sometimes they may be easy. Moving ahead, the next question says, for equimolar mixture. Now, number of moles of NaOH and sodium carbonate are equal over here. So that means again a composition mixture is supplied to you, NaOH and sodium carbonate. Let's curate this NaOH and sodium carbonate. Molecular masses you calculate, this is 40, this is 106. In question it is given this is X gram and this is Y gram, and total weight is 4 gram. It is not reacting. The moles of both the components are equal, not weight, moles. So just go through the word problem properly. Because moles of NaOH and sodium carbonate are equal, so this is given and X and Y are given. Whatever is given, I have curated in a photo. Now, do the simple stoichiometric mathematics. What will be the first equation? It is given that weight of these two, X plus Y, equals 4. 4 gram is the mass of mixture. And because these moles are equal, again use formula for moles. For NaOH, what will be number of moles? Sir, X upon molecular mass, which is 40. For sodium carbonate, sir, Y upon 106. Two equations, two unknowns. What value you have to calculate? You have to calculate X and nearest integer whenever. JEE mains, at least one should always work hard and pray also, because the value question, the integer type question that usually comes, sometimes approximation are easy to do, sometimes you have to be very precise. Almost with the appearance of the question, it is quite evident to you, like in the previous question, the calculation has to be done. But in such questions, calculation, even if you skip, because you have to report the answer in nearest integer. Like, I have to calculate X, so I'll remove Y from equation 2. So this is, this can be divided easily. Now, this is 20, this is 53. So X upon 20 equals, replacing Y is equal to 4 minus X upon 53. Cross multiply, this is 53X. Then 80 minus 20x, so x will be coming out to be 80 upon 53, 73. If it would have been 73, 73 is 1. 73, what is 10% of 73? Approximately 7.3. So it is 10% higher, so it is approximately 1.1. What will integer you will pick? Round off, 1.1 will be reported as 1. So 1 will be your answer. Again, the next question says 0.05 centimeter thick coating of a metal. Who is the metal? Silver. So again, the same logic of mole and stoichiometry is applied so many times, but with bit of common senses. That is the advantage of being an analytical JEE student. So let me again curate this word problem in a picture. Once you curate the word problem in a picture, the question seems very easy to you. So for that you need confidence, and for confidence you need practice. Like for example, I have curated this complete word problem again. This is a plate with area 0.05 meter square. Mind you, units you have to be very watchful while writing them down. I am doing what? I am taking this silver plate of thickness 0.05 centimeter and placing this in a plate of area 0.05 meter square. A plate and a thickness of 0.05 centimeter square of 0.05 centimeter is placed on that plate. So it becomes a volume. Area into thickness becomes a volume. This silver coated plate contains how many silver atom is your answer, is your question. Again, do the basic. What basic, sir? Basic of mole concept. But in order to calculate number of silver atoms, first I have to find what is its weight. Now you tell me, what is this volume that you have just formed? Sir, volume is equal to area, which is 0.05 meter square, into the thickness. The thickness of the silver plate is 0.05 centimeter. Now, unit dimension, you have to be very watchful. The density is given out to be 7. This plate has a density of 7.9 gram per centimeter cube per cc. So obviously we'll jol down to centimeter. This is centimeter, no issues. This is meter square. You tell me, what is 1 meter has how many centimeters? Sir, 100. So it will be 0.05 into, instead of meter, I'll write 10 raised to the power 2 centimeter, and because meter has a square, so it will be a square, into 0.05 centimeter. So what volume you got? Sir, this is 0.05 into 0.05 into 10 raised to the power 4. So this is 10 raised to the power minus 2, this is gone. So this is 25 centimeter cube cc. Volume you got. If I had, what does density tell you? If I had 1 cc of volume, its mass would be 7.9 gram of silver. If I had, density is mass per unit volume. So if I had 1 cc of this plate, of this volume, what mass of silver I would be having? 7.9. So 1 cc had this, so 25 will have how much? So 25 will have 7.9 into 25 gram of silver. Now, this is your weight of silver. Bingo. This is the only common sense that you have to apply. Now, since you have got weight, now it should be a piece of cake for you. How? Sir, we very well know number of moles can be equated as weight upon molar mass. What is molar mass of silver? It is given in the question, 108. It is also equal to number of silver atoms upon Na, which is 6 into 10 raised to the power 23. Yes, it is 6.022, but because it's an integer type, so I am approximating it to be 6. But you have to be very religious with multiplications. So this will give you the value of N. What will be the value N? This W divided by 108 into this. Now the answer that you have to report, that 10 raised to the power 23 has to be kept aside. So this 10 raised to the power 23 has to be kept aside. So this 6 into this W upon 108 will give you the answer. Mathematics, the multiplication, you have to practice very religiously. Moving ahead. Now there are, this is a direct outcome, a direct question of atomic structure, the basics. So there are certain factual questions which I suggest you should make a fact copy and write those facts, like the candela is luminous intensity, the fundamental unit candela. In physics also you must have seen this. So you are given the luminous intensity in some direction, that source emits a monochromatic radiation of frequency of A into 10 to the power 12. Now we very well know the lights that the visible range lights, they have a frequency range of somewhere around 400 or 450 to 750. So it will be lying somewhere between them, 450 to 700, 750. So obviously this A will be either 540, because it should be in the range, na? The range is from 450 to till 700, so a midway, but obviously it's a factual question. So your answer is B. Your A value will be 740 into 10 to the power 12 hertz, and the radiant intensity in that direction. What is radiant intensity? Its unit is the power by which lines of lights travel. So its unit is watt per steradian. It's 1 upon B. The value of B will be 683. But these factual questions, you should make a fact copy. Now, I have also given you some more problems. These problems will be using the same logic. If you find I told you, I will give you practice also. You do not have to go anywhere else. So these will be your homework questions. If you find any doubt in these questions, you can very well comment and we will be discussing them. Moving forward, sometimes, now moving forward to the next topic, which is calculation of molecular formula. Sometimes question supplies you with data of elements and you have to calculate its molecular formula. But for that, some hidden facts are also there in the question. So in order to understand that, let us first discuss what are types of densities. What is a density? We have already discussed. From 10th standard, you know, density is mass per unit volume. So like density of water is 1 gram per ml or 1 kg per liter. It's a universal solvent. Its density you should remember. So what is specific gravity? Density of any substance with respect to water. So density has a unit of mass per unit volume. But specific gravity is dimensionless because it is density of any substance with respect to water. Density of any substance with respect to water, hence dimensionless. For gases also, a density is defined just like relative atomic mass, mass of any atom with respect to hydrogen, simplest atom. So for gases, density of any gas with respect to the simplest gas, hydrogen. We very well know what is PV equal to nRT. How can you formulate density for a gas? We know PV is equal to nRT, number of moles is weight upon molar mass, already derived. Weight of gas upon volume of gas is density of gas. It comes out to be pressure into molar mass upon RT. Use this in the vapor density. What is vapor density again? Density of any gas with respect to density of hydrogen. So density we have formulated, it is PM upon RT. So PM upon RT for any gas, red one. PM upon RT for hydrogen gas, the pressure and temperature for both the gases, if you are taking their relative value, they have to be present in same area. So the pressure and temperature will be same, but molar mass of the gases will be different. So this is M, I do not know. This can be any gas upon what is molar mass of hydrogen? 2. So what is vapor density of any gas? It is molar mass upon 2. So sometimes molar mass is hidden and vapor density is supplied. So vapor density is molecular mass of that particular gas upon 2. This is also a dimensionless quantity. Now, what is, sir, if I have to calculate molecular mass, what I'll be supplied? Percentage composition of the constituents. Sir, what is percentage composition? Suppose, just giving you an example, suppose I have ethanol. Ethanol. The famous commercial drink, which is C2H5OH. We very well know this. So how many elements it contains? A carbon, hydrogen and oxygen. Carbon, oxygen and hydrogen. What are their percentage composition? Sir, weight of, if you calculate percentage composition of carbon, weight of carbon upon total weight of compound into 100 will give you percentage. So weight of carbon, weight of oxygen, percentage of carbon, oxygen, hydrogen I have calculated, just to show you that what actually is percentage composition. Obviously, if a molecule is formed by only 3 elements, you can calculate the percentage for 2 subtracted by 100 because all 3 of them will be giving you 100% of the molecule. Remember this 100% thing also. Why? Because how a question is designed, in order to find their molecular formula, first you have to determine through this percentage composition, first you have to determine their empirical formula. Again, sir, what is empirical formula? Empirical formula is the simplest formula of any compound. What is it, sir? Giving an example. For example, carbon dioxide, you know, what is its molecular formula? CO2. What is the ratio of constituent elements? 1:2. Is it a simple ratio? Yes, sir. 1:2 cannot be further divided into any integer. So its empirical formula is also CO2. Similarly, what is methane molecular formula? CH4. Ratio 1:4 for the molecule. So empirically is also it is 1:4 because it cannot be further divided. Benzene is C6H. Its molecular formula, one molecule of benzene contains 6 carbon and 6 hydrogen. But 6:6 ratio is not simple. So what will be its empirical formula? 1:1. So its empirical formula will be CH. Similarly, heptene is C6H12. The ratio is constituent elements has a ratio of 6:12. Simple? No, sir. 1:2. So it will be its empirical formula. By seeing this empirical formula, you can very well see that molecular formula is always equal to some integer times of empirical formula. This integer, some references, some books, they write n. I do not like n because n I use for number of moles. Small n I use for number of moles. So I used to write n dash. So how can you calculate this n dash, sir? Molecular formula mass upon empirical formula that I will tell you how to calculate. Upon that empirical formula mass will give you this integral value. Now, going to the application side of it. JEE asks such questions a lot. How the questions are asked? For example, the question is still telling you organic compound contains oxygen, carbon, hydrogen and nitrogen. For this compound is containing 4 elements. 4 elements. Their percentage must be given in the question. Like for carbon, percentage given is 20. For hydrogen, it is 6.7. For nitrogen, it is 46.7. And oxygen. Question has hidden the percentage composition of oxygen, but it has told you it has got 4 elements. So 3 I know. So what will be the percentage of the other one, of the fourth one? So 100 minus summation of these 3. 100 minus summation of these 3. Now, if I would be writing this, would be time consuming. So we will be investing our time in doing the questions rather than unnecessarily writing the clumsy theory. But this PDF will be there with you, so you have to work on it. Now this is the percent. So what will we do with the percentage composition? My friend, if you have a molecule, if you have 1 kg of that molecule, a room full of that molecule, or this much of that molecule, its molecular formula will remain the same. So in your mind, you take 100 gram of that substance. So what will be 20% of 100 gram of that substance? So 20. What will be 6.7% 6.7% of 100 gram? 6.7. So these percentage you can also take as the weight given of the substance. And if you have got the weight of atoms, what are its moles? Weight upon atomic masses. So next we do the mole calculation. So carbon 20 by 12, hydrogen 6.7 upon 1, nitrogen this upon atomic mass of nitrogen is 14, oxygen this upon atomic mass of oxygen is 16. Now, the most difficult part is again into divide. You have to be very religious while calculating. Why? Because 1.89 can be approximated to 2, 1.16 can be approximated to 1, and if it is a midway value, you cannot approximate. So you have to be very religious with into divide, because if the answer is C1 or by mistake, by slight of the calculation error, if you have got 1 point something, 1.8, 1.5, 1.56, you will approximate to 2. So you have to be very religious with the calculation part while attempting question for empirical and molecular formula determinations. So this will give you the moles. Now, the next step is to find the simplest ratio. How to do that? The moles, when you calculate it, you pick up the most smallest value. So, which is the smallest value? 1.67 and 1.66, they are approximate. This 1.66 is the smallest. So, you pick that smallest ratio, you pick that smallest mole and divide it by all of them. So 1.67 divided by 1.66 is approximately 1. 1.66 divided by 1 is definitely 1. 6.7 divided by 1.6 is, it is approximately 4. 3.33 divided by 1.6 is, it is 2. So here you have got your integer. So the simplest ratio will give you the simplest formula. Remember, what is it? Empirical formula. So the empirical formula comes out to be carbon 1, hydrogen 4, nitrogen 2 and oxygen 1. Bingo. Can you calculate the empirical formula because empirical mass, because empirical formula you have just now formulated? Yes, sir. Use their atomic masses. Empirical mass, empirical formula mass came out to be 60. Remember that N dash? N dash is molecular mass upon empirical formula mass. Molecular mass must be supplied in the question, like the question is saying its molecular weight is 60. So 60 upon this 60 will give you N dash as 1. So for this question, empirical formula equals molecular formula. Sometimes as I was telling you, simple ratio will give you the integer, because if a value of 1.89 is coming, you can definitely write it as 2. If a value of 2.1 is coming, you can definitely write it as 2. But if 1.5, you cannot write 1 also, you cannot write 2 also. JEE mains, although do not play with such questions, but you should know that, because advanced loves it and mains has a tendency of accepting advanced question in the papers to come. So the next question which I have served you, a metal oxide contains 70% metal and molar mass of metal is, atomic mass of metal is 656. The molar mass of the compound, the metal oxide is also given, it is 160. You have to calculate its molecular formula. Same thing. What is the thing? First write elements, then their percentage of metal is 70, so oxygen will be 100 minus 70, that is 30. Mole ratio, given mass upon atomic masses, solve it, religiously solve it, 1.25, 1.875, a clumsy calculation. Which is the smallest value? This is the smallest value. Divide that smallest value by both of them. So 1.25 upon 1.25 will become 1. But 1.875 divided by 1.25, it is 1 point approx. If you approx also, it is 1.5. So 1.5, sir, it is not an integer. So sometimes, very few times, sometimes simple ratio will not give you the answer. So what will we do? In such cases, you have to make a one more column, which is whole number ratio. Just a common sense of finding an integer. As of now, the ratio is 1 is to 1.5. Convert this 1.5 into a fraction, it is 15 by 10 as in 3 by 2. Sir, if I have a ratio of 1 is to 3 by 2, how can I make it an integer? Multiply with the denominator. What is the denominator of 3 by 2? 2. So multiply this by 2 and this also by 2. So what ratio you will end up with? Sir, it will be 2 and 3 by 2 into 2 will be 3. Is it the simplest formula 2 is to 3? Yes. So sometimes when simple ratio does not give you an integer, you again have to do this practice. You have to change it to a fraction. The denominator you have to multiply to both of them and it will give you a simplest ratio. So the empirical formula now came out to be M2O3. MO2O3. It is M2O3. So empirical formula mass is 56 into 2 is 112. 112 plus 16 into 3 is 48. So this is 160. Molecular mass is also 160. Empirical formula mass is also 160. So again, N dash becomes 1. So again, whatever is your empirical formula will be your molecular formula. Moving ahead. Now, again, what I have discussed, object-oriented thing. Now, this is a question. Now, you formulate that table by yourself because an organic compound is given to you which has a percentage of carbon, hydrogen and the remainder is oxygen. Molecular weight is given, formulate its molecular formula. So I am again creating what? So I am again creating a photo for you. Carbon, hydrogen, oxygen. Carbon is given to be 42.1, hydrogen is 6.4, remainder is oxygen as in 100 minus this plus this. So you will get percentage. Next thing is calculating the mole ratio. So how can you calculate mole ratio? 42.1 upon atomic mass of carbon is 12. 6.4 upon hydrogen is 1. 51.5 upon oxygen is 16. Now, the difficult thing. This is somewhere around, you have to calculate. This is somewhere around 3.5. This is somewhere around 3.2. This is, I can definitely say this is exactly 6.4. So the next thing is simple ratio, which is the smallest value. Sir, 3.5, 3.22 approximately. Obviously, 3.22 is the smallest value. So 3.22 upon 3.22 is 1. 3.5 upon 3.22 is also approximately 1. And 3.22, double of it is 6.4 something. So this is definitely 2. So because you have got an integer, so what will be your empirical formula? So carbon is 1, Hydrogen is 2 and oxygen is also 1. This is your empirical formula. So empirical formula mass will be 12 plus 2 plus 16, that is 18. So this is 30. So how can you calculate N dash? Molar mass. What is the molar mass supplied to you? Molecular weight is 342. So this is 342 upon 30. It is also clearly visible. It is less than 3.5. It is somewhere around, okay, not less than 3. It is 10 times, I guess 11 point something. 11 point something. So N dash has to be an integer. So it has to be 11. Going to the options, I guess there is through molecular mass also you can see it's glucose. There's an option correction. This is C11H22O11. So there's an option correction. C11H22O11 will give you the answer. Moving ahead, again formulation of molecular formula, but type of question changes. Like over here, the question says a metal chloride contains chlorine and what is its percentage? 55% by weight. So my friends, if chlorine is 55%, you tell me what will be the percentage of metal? 45%. Sir, draw that table. Why not creating that table? Because molar mass of metal is not supplied. Instead, it is given 100 ml of vapors of this compound at STP weighs this much gram. So molecular mass of the compound is given in that sense. How can you say that? Sir, we know at STP, remember STP, 100 ml, no sir, 22400, or else for STP there is always a doubt. It is 22.4 or 22.7. Over here they have not mentioned it is standard is 1 atm or 1 bar, although the standard technically is 1 bar, but sometimes it is not mentioned in the question. Also, it will create very small difference. 22.4, 22.7 will create very small difference. So just for the sake of simplicity, generally NCERT and JEE loves 22.4. So we have a practice of taking 22.4 until unless mentioned. So 100 ml weighs 0.7. So 1 ml will weigh how much? 0.57 upon 100 grams, sir. So 1 mole has a volume of 22400 ml. So it will be 0.757 upon 100 into 22400. If you'll solve it, it will come somewhere around 128. Difficult part, have to do. Practice calculations. If you have taken 22.7 to 700, it will be somewhere around 129 point something. So 128, 129 doesn't make a difference. Sir, why you're not formulating that table? You do not know the molar mass. In order to formulate that table, you have to know the atomic masses of constituent elements. Here you do not know them. So you have to think out of the box. That's why I've used only those questions, not repetitions. So molecular mass of the compound I have got. I know chlorine has what percentage in this contribution? 55%. So what is 55% of 128? What is 50%? Half of this. If it would have been 120, so 60, so somewhere around 64, 55%, so somewhere around more than 64, 70%, 70, what is the atomic mass of, see, the question is giving you a direction also. They are telling you atomic mass of chlorine is 35.5. Double is somewhere around 70, 71. So how many chlorine it will be present approximately? So 2 chlorine atoms. So 2 chlorine atoms, option, sir, 2 chlorine atoms. So sometimes you have to apply common sense instead of going just by book written theory. A common example for that. Moving ahead, the next question says, you have an organic compound. The organic compound which you have, so the percentage of carbon 24 is given in this organic compound. Percentage of hydrogen you have to find out, but in the form of dash into 10 raised to the power minus 1. The organic compound has carbon, hydrogen, and how many other elements it has, not given in the question. So again, that formulation of the table will not work. You have to go by some common sense. So going by stoichiometry. Stoichiometry also, it is not difficult. It is not possible. Why? Because you cannot write the balance reaction. Why? Because other elements are not known. So principle of atom conservation can be applied. All the carbon present over here will go as CO2. All the hydrogen present in the organic compound will go as water. It may have other elements. That why dot 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 dot. Percentage of carbon is only mentioned, that is 24. And I have to calculate percentage of hydrogen. I have not written a balanced equation also because there is no need of writing the stoichiometry because I do not know the molecular formula. So again, going by basic. What is the basic, sir? Common sense says whatever carbon present has come over here, POAC, whatever principle of atom conservation says, carbon present over here is released as CO2. So can I find the weight of carbon? Easily. 0.22 gram of CO2 is released by this compound. Sir, if 12 gram of carbon would have been present over here and released as CO2, how much CO2 will be formed? Sir, 44 gram. If 12 gram was the weight of carbon, 44 gram of CO2 would have been evolved. Do the unitary method. So if 1 gram of CO2 is evolved, how much carbon you will be having? 12 upon 44. Right? How much actually the weight is getting released, sir? Into 0.22, because 1 gram is not getting released. 0.22 gram is getting released. So this will be your weight of carbon. Bingo. Now you have whatever carbon was present over here is released as CO2, and in this 0.22 gram of CO2, what is the weight of carbon that you have? Similarly, I can do this for hydrogen with another pen. Similarly, I can do this for hydrogen as well. How? Sir, if 18 gram water would have been released, how much hydrogen would be there? Sir, 2 gram hydrogen. So 1 gram will give you how much of hydrogen? 2 upon 18. How much amount of water is actually getting released? 0.126. So this is your weight of hydrogen. I have weight of hydrogen that was present. So if I want to calculate the percentage of this hydrogen in this compound, this weight upon total weight. So I just need the total weight of the molecule, the molecular mass. How can I get the molecular mass? This percentage is given. Let me tell you how. What percentage is given to you? Sir, for carbon, I know percentage is 20%, so it will be weight of carbon upon weight of organic compound into 100. So this weight is an unknown for us, marking it as green. So this weight of organic compound, which will actually be the molar mass of organic compound. So this is also the molar mass. So the molar mass of organic compound will come out to be weight of carbon into 100 upon 24. Can I supply this weight of carbon from here? Yes, this is 12 upon 44. 12 upon, I can simplify, this is 12 upon 200 because 1, 2. So this is 12 upon 200. So this is 12 upon 200 into 100 upon 24. So this is 6. So this is 1 by 4. 1 by 4 is what? Sir, 1 by 4 is the molar mass of the compound. So if 1 by 4 is the molar mass of the compound, now it's just a case of finding percentage for you. So percentage is what? Weight of hydrogen upon weight of organic compound, which is 1 by 4 into 100. Now do the math. So it is 400 into weight of hydrogen. What is weight of hydrogen? We have got, this is 0.126 upon 9. So this is 0.126 upon 9. I guess this can also get easily. Mains does this. See, it is not a difficult calculation. 4 upon 9. Acha, you have to report answer in what format? 10 raised to the power minus 1. So 10 you consider by yourself. 10 into 10 is power minus 1. So what I'm doing over here is, if I need a 10 raised to the power minus 1 here, I am supplying a extra 10 over here. Why? Because this 0.126, this 20 and this one will make it 126. So 126 into 4 upon 9. 9, I guess it is directly getting cancelled. 9 1 ja 9, 9 4 ja 36. So 14 into 4 is 4 4 ja 16, 4 ja 4, plus 1 is 5. So answer is, see, beautifully. If you see, calculation is also not very difficult, but you have to practice in order to formulate a good playing field so that calculations you do very easily. Moving ahead. The next question says you have 116 gram of a substance which on dissolution, which on dissociation yields 7.5 gram of hydrogen. Further, it gives you 60 gram of oxygen and 48.5 gram of carbon. Now, sometimes numerical values calculations can save you. Sometimes they can be very naughty with you. Like, for example, over here, the percentage of these elements are not given. In fact, now you have to calculate their percentage, because 116 gram is the weight of the total compound. And out of those 116 gram of compound, hydrogen, oxygen and carbon weight are given. So first thing you have to do, remember percentage, the very first thing I told you, my weight upon total weight will give the percentage. So here, first you have to calculate the percentage. Now, this is a time consuming and a calculative question. So you practice. I am just for the sake of speeding up, I'm using, so this 48.5 when divided by 116, it is somewhere around 0.42%. This 7.5 when getting divided by 116, it is around 0. This will be into 100, so it will be 42%, because this into 100 will give you percentage. Na? So, I see, calculations will sometime obviously take your time. So, this is something like 42%. This is something like 6.5%. And 60 divided by 116 is something like 52%, something. Now, if I have their percentage, what I should do next? Now it is, again, maybe calculation you have to do. So it will be 42 by 12. It will be 6.5 upon atomic masses, 1. And this is 52 upon 16. Yes, my friends, still some calculation. So this is 12 2 ja 10, 12 4 ja 48. This is somewhere around 3 point something. 16 4 ja 16 3 ja 48. This is also somewhere around 3 point something, and this is exactly 6.5. So obviously 3 point something, 3 point something, one will be a bit smaller. So this is the smallest quantity, 3 point something. So if you divide 3 point something by 3 point something, you'll get 1 over here, 1 over here, and definitely 2 over here. So the first column was more calculative, remaining is easy. So empirical formula, what you got is C1, H2 and O1. This is your empirical formula. C1, H2, O1. So with C1, H2, O1, the question is asking, it has some printing error. Hydrogen, oxygen, atomic masses are given. And now you have to tell me how many of these formula agrees. So it must be an integer type question. Out of this A, B, C, D, how many of the compound agrees with this empirical formula? So let us make their molecular formula. This is acetic acid with molecular formula C2H4O2. This is formaldehyde with formula CH2O. This is C2H6O2. And this is C2H4O1. So whose empirical formula is same as that we have calculated. This empirical formula is 1:2:1. Yes, it will go. This is the molecular formula, empirical, both are same, so this will also go. 1:3. No. This will not go. This is 1:2. That is 1. So I cannot simplify. So it is the simplest form, not this one. So this is all. So how many compounds are in conformation with the given empirical formula? 2. So your integer type answer will be 2. Moving ahead to concentration terms, the colligative solution and colligative properties chapter also will help you with this. So the first thing is what are the concentration terms of any solution? So what are these concentration terms of any solution and why are they used? In day-to-day life, how are we characterized? Because we are billions of human beings in number. So in order to characterize them, we have name, surname, father's name, mother's name, address, because name and surname of many individuals may be same. So we have defined these characteristics for ourselves. Similarly, because there are so many solutions, we have defined certain definitions for these solutions to be known, to be characterized as. Now, these are simple definitions and these questions related to these definitions are very famous, very common in JEE and very easy to solve as well. I guess the most simplest part of this mole concept chapter. So let us go with it. First of all, what's a solution? We very well know solution is a mixture of solute and solvent. Solvent is that component of solution which is generally in larger amount, or sometimes solvent is also that constituent of a mixture of a solution which decides the physical state of a solution, and solute is obviously the other person. Solute may be 1, 2, 3, many. Solvent is the one which is in the larger amount which defines this physical state of a solution. For example, in a glass, if I have taken water, that will be solvent. If I am pouring lemon into it, solute, a liquid solute. Some salt into it, a solid solute, some sugar into it. So the lemonade may have number of solutes, but the solvent will be the one which is deciding the state of the solution. Let me give you a few examples for that. For example, if you are given sodium chloride aqueous solution, we very well know, sir, who will be the solvent, sir? Water will be the solvent, which is liquid, and NaCl solid will be the solute. So what type of solution it will be? Solid in liquid solution. Ethanol, 10% ethanol, because ethanol is 10%, 10% is lesser. So who will be the remaining 90%? 90% will be aqueous, as in water. So H2O liquid, because it is in larger amount, will act as a solvent, and solute will be ethanol, C2H5OH. Now, if you're changing the concentration, 90% ethanol, as in 90% of ethanol is present out of that 100% solution. So that means here, because solvent, which is ethanol, is in larger amount and also deciding the physical state, because it is also in liquid state, solution is also in liquid state. So here H2O will act as a solute. So you have to keep this thing in mind. Now, a very famous example, copper sulfate pentahydrate. Copper sulfate pentahydrate is a mixture, is a solid solution, because physical state of the solution is solid. So solvent is that component which is solid. Out of water and copper sulfate, who is solid? So CuSO4 solid will act as a solvent in which H2O liquid has been crystallized into it. So solution, the physical state of the solution is defined by that component is known as a solvent. Moving ahead. Now, going to the very basic side of it, the first concentration term is percentage composition. We already know this. Percentage composition are of three types: mass by mass percent, volume by volume percent, and mass by volume percent. What is mass by mass percent, sir? Weight of solute upon weight of solution into 100. For the case of mathematical simplicity, what I am defining over here is, whenever I will be talking about the solute of a solution, I will be mentioning it as 2. Whenever I will be defining the solvent of a solution, I'll be mentioning it as 1. You have to remember, solvent will be mentioned as 1. Solute, mathematically, we'll be mentioning it as 2. So, mass by mass of solute is mass of solute upon mass of solution, as in W2 upon W solution into 100. That percentage will give you the mass percent of solute present in solution. Similarly, volume of solute upon volume of solution. Now, this is important. Mass by volume also sometimes it's given. Mass of solute upon volume of solution into 100. Now, because percentage is a dimensionless quantity, here if you put kg, it will be kg. Here, if it is liter, denominator will also be in liter. But for mass and volume, you do not wish to go by your thought, your wish. No, it is defined. You have to put mass in grams and volume in ml. In numerator, you have to put mass of solute. In denominator, you have to put mass of solution. Moving ahead. After mass percent, when solution is very dilute. So for dilute solution, solute are present in very, very lesser amount. So for such dilute solution, generally instead of percentage, which is per 100 parts per million, 1 million is 10 lakh, 10 lakh is 10 raised to the power 6. So same percentage composition, mass by volume or mass by volume, can also be defined by not 10 raised to by 100 but 10 raised to the power 6, because 10 raised to the power 6 represents parts per million. For example, if I have 15 ppm W by W of chlorine solution, that means 15 ppm, as in if I have 10 raised to the power 6 molecules of solution, then out of those 10 raised to the power 6 molecules of 10 raised to the power 6 is 10 lakh molecules of solution. Then out of those 10 lakh molecules of solution, only 15 will be solute, very less. So for such dilute solution, we use ppm. Moving ahead. Mole fraction of solute is fraction, sir. Moles of solute upon moles of solution. Mole fraction of solvent will be moles of solvent upon moles of solution. What is moles of solution? Solution is nothing but summation of solute and solvent. So N1 plus N2 is moles of solution, and whoever mole fraction you have to find out, put it in the numerator. Now, a very basic common sense, add them up. So numerator will also be N1 plus N2. Denominator is also N1 plus N2. A very important statement which student always misses while doing numerical problems. Theory is no problem. If you add up for a binary solution, as in only one solute and one solvent, so if you add up mole fraction of those solute and solvent, what will the summation come out to be? It will always be unity. So if the question supplies you with mole fraction of one component, subtracted by 1, mole fraction of other component will be seen. Moving ahead. What is strength of a solution? Strength of a solution is, again, these are definitions. You have to remember them. Just speak them aloud, you'll learn them. We'll do problems also. So how can you define strength of a solution? It is weight of solute upon volume of solution. But now it is defined as weight of solute is in gram, but volume of solution has to be taken in liters. So actually what is strength? Gram of solute present per liter of solution. Obviously unit will be gram per liter. Moving ahead. Molarity. Giving a touch to strength of solution. Strength has weight of solute in numerator. Molarity has number of moles of solute in the numerator upon volume of solution in liters. Let us give it a mathematical form. Remember, solute is 2. Number of moles is small n. So number of moles of solute upon volume of solution in liters. This will be your formula for molarity. Very important. Or sometimes moles of solute will not be given, weight of solute will be given. So, sir, moles is equal to weight upon molar mass. So number of moles will be equal to weight of solute upon molar mass of solute. Molar mass of solute should always be in gram. So whatever unit the question must have supplied you with weight of solute, you have to convert it in gram, because molar mass is always in gram. Sometimes volume of solution is not given to you in liters, it is given to you in ml. No problem. You have to convert into liter. How will you convert liter? For example, you have 500 ml. 500 ml upon 1000. So that 1000 will come to the numerator. So these two formulas are the basic formulas with which you can land up questions from JEE. Next is molality. Similar analogy like molarity. Molarity is capital M. Molality is small m. Numerator remains the same. Number of moles of solute, but denominator is weight of solvent in kg. So number of moles of solute upon weight of solvent in kg. What will be the unit of molarity? Moles per liter, commonly known as molar. What is unit of molality? Moles per kg, commonly known as molal. But mind you, molarity has volume of solution, but molality has weight of solvent in their denominator. It's the basic difference. Now, is it just to learn? Practically speaking, if someone asks you between molarity and molality, capital M and small m, which is better? Both are same? No. Because molality only has weight, mass, content in its formula, no volume. Actually, volume changes with temperature. So if I am putting a sticker on a solution and that sticker is of molarity, I again have to do that work if season changes. Like if I'm putting a sticker in winters, on summer I have to again redo the stuff. Why? Because volume changes with temperature. You must have seen the lakes around you, the liquid water solidifies when winter comes. So actually volume changes with temperature, therefore molarity also changes with temperature, but molality does not, because temperature change has almost very negligible. So we can definitely say, for the case of simplicity, we can say molality remains constant and is independent of change of temperature, whereas molarity is inversely proportional to temperature. Why temperature? Because temperature increases, volume increases. Volume is there in the denominator for molarity. So temperature increase, volume increase, molarity, capital M, decreases. Moving ahead, although whatever I'm saying right now, you will find so many questions on this. Next is a relationship between mass percent, W by W, density of solution, that value you always check what unit it comes with. Generally, it comes in gram per ml. Gram per ml, we are defining it as D. Molar mass of solute and molarity. This is the relation for case of mains examination. I want you to learn it because direct question comes. So molarity is equal to percentage into that density into 10 upon M2. M2 is molar mass of solute. Let me make a derivation also for you, but I definitely recommend you should learn these formulas by heart. Okay. Let us derive it. What is molarity? Sir, we very well know number of moles of solute upon volume of solution. Number of moles of solute is weight of solute upon molar mass of solute into volume of solution. If this volume is in ml, what can you do to make the definition right? Sir, already told us in the previous slide, 1000. Now, I need density. Can you see density over here? Yes, sir. What is density of solution? Sir, we know mass of anything is equal to volume of that thing into density of that thing. Sir, volume of solution is there. So volume of solution will be equal to its mass upon density. Okay. Using that, so I can say molarity is equal to weight of solute into 1000 upon molar mass of solute into this volume of solution. This volume of solution I'm writing as mass equals volume into density. So volume equals mass of solution upon density, which will come up. Density of solution we are defining as small d in gram per ml. So this mass is in gram. We very well know weight of solute for number of moles is always in gram. Hello? Okay. Remember percentage, weight of solute upon weight of solution. Let me encircle this for you. Weight of solute upon weight of solution into 100 is the definition of what? Percentage. Whatever percentage, 10%, 20%, 30% given in the question, do not change. Put that 10 only because I'm taking this 100 also into account. So this will be replaced by percent, remaining as it is. So molarity equals, this is percent, into this 10 has been left behind into density of solution upon molar mass of solute. Bingo. Moving ahead. Now, a similar question, just let me tell you, although these questions are all there in NCERT, people fear that they are from so and so books. No, NCERT exercises has each and every questions. Some questions I have taken from solution chapter, from solution NCERT. Therefore, JEE loves these questions. So it is very scoring and you just have to remember these definitions. So, concentration of nitric acid in moles per liter, as in you have to calculate its molarity in a sample which has density. So density, this is given, so this is small d. Just let us check the unit. Gram per ml. Yes, sir, it will do. Mass percent of nitric acid is 69%. So this direct percentage, 69 value you will use. Answer. Molarity is equal to percentage into 10 into density in gram per ml upon molar mass of solute. Sir, everything is given. Percentage 69. Sir, 10 is 10. Sir, density of solution is 1.41. What is molar mass of nitric acid? HNO3. I guess it is 63. Just check. Do the math. Moving forward. So coming to this relationship after sipping a chai break, this is a beautiful relationship given in NCERT. NCERT exercise has given you this question. In fact, NCERT a solved example also has given this question. And these questions are picked by advance. And now these days, mains have started loving them. So another relationship between density, mind you, density of solution and its unit is gram per ml. Relationship between density, molarity, molality and molecular weight or molar mass of solute. Remember them for your examination in order to be fast and effective. What is the formula? Small d is equal to capital M whole into 1 upon small m plus m2 upon 1000. You should learn this like this, although I am giving you a derivation also. Now, as you can clearly see, you know what is the basic definition of molarity, sir? It is number of moles of solute upon volume of solution. If this volume is in ml, what shall I do? I shall multiply 1000 in the numerator, again rewriting this. I can also say molarity is also equal to number of moles of solute into this 1000 upon, instead of volume, mass equals volume into density. So volume equals mass of solution upon density. So that density will come to the numerator. Remember, this density D is in gram per ml. So weight should be in gram. Yes, sir, it is in gram. And volume we have recently converted to ml. So this is what I have for molarity. What is the basic formula of molality? So we very well know molality. We very well know what is basic formula of molality. Molality is nothing but number of moles of solute upon weight of solvent. If taken in gram, then I again need 1000 in the numerator. Molality of a solution is can also be written as N2, or okay, if I write number of moles of solute, I should write weight of solute upon molar mass of solute into weight of solvent into 1000. This can also be the form of molality. Sir, why you are writing those formula which we already know? My dear friends, I am writing this because just by looking at these formulas, you can formulate the relationship. How, sir? Let me help you with it. Can you find the term N2 into 1000 in molality? Yes. Do you find the same term in molarity? Yes. So if it is equation 1, use this in equation 1. So by 1 you can say molarity is equal to, instead of this N2 upon 1000, I am writing molality into W1. This D will remaining. This D is still remaining upon W solution. Now, what is weight of solution, sir? Solution is solute plus solvent. So I can write solute plus solvent. Sir, we are looking at the formula, I guess, right now. Then this D is needed. Take this D to the left hand side. So, or I can say D is equal to D. We have got this D. Now, everything on the right side. So, sir, capital M we are already seeing. Okay, whole into we are already seeing. This will go to the numerator. W1 plus W2 upon this small m into W1, sir. Yes, the plus format has also come. So, it's a clear derivation. Moving ahead. Again, I can say density is equal to molarity whole into. Now, M upon W1, so the first part will become 1 upon molality. Easy, sir. Plus, there is a trouble with the second part. Let's see. W2 upon M into W1. What is this, sir? That's why look at the form of molality in the second line. Can you do W2 upon W1? Sir, but there is no small m. My dear friend, small m will come from this side. So W2 upon MW1 is what? Is M2 upon 1000. Replace. So D will be equal to capital M whole into 1 upon small m plus, for this W2 upon small m into W1, we can replace it by M2 upon 1000. Very easy. I'm not saying you should learn this derivation, but know the basic. Moving ahead, and why we are studying this, the famous example, let us attempt it now. Now, one method you already know, derivation you have done, density of solution is given. Okay, sir. Small d, gram per ml. Molarity is given. Okay. Solute is NaCl, so you know M2. You can calculate molality. But what happens sometimes is you can apply the formula and definitely get the answer. But sometimes what JEE also have started doing, they play with the numerical in such a way that that calculation part becomes very difficult. So you can try from the formula part also. It will be difficult to calculate. So I am giving you again a common sense. If I had a bucket full of a solution, you taste the solution. Whatever taste it has, now you pick out a spoon of that solution and now taste it. Whether the taste changes? No, sir. What does that show you? Concentration is independent of the volume taken. If you take a volume of spoon of that solution or a bucket of that solution, the concentration, the taste remains the same. Sir, why you are telling us this? Because you can kill some variables by taking their volume and then performing the calculations only for that amount of volume. Let me tell you what I'm saying. What I'm saying is, you are given with molarity of solution. We know molarity of the solution is equal to number of moles of solute upon volume of solution in liter. Take that volume to be 1 liter. Why? You are killing one of the variable, volume of solution gone, but now every calculation will be for 1 liter of solution. So for 1 liter of solution, you know number of moles of solute. What is number of moles of solute? 3. If number of moles of solute is 3, then what should be the weight of solute? So number of moles is weight upon molecular mass. Who is the solute? NaCl. What is molecular mass of NaCl? 58.5. It is equal to 3. So what shall be the weight of solutes, sir? Multiply. So it will be 63, 180, 155.5 gram. Just check. So you know weight of solute also. Sir, now you need to find molality. Okay. Sir, what is molality? Molality is equal to number of moles of solute. This we already know. 3 upon weight of solvent if taken in gram, then 1000 will be in the numerator. Sir, one thing we already know. For 1 liter of solution, this value is 3. So I just have to calculate this one variable. What is weight of solvent when volume of solution is 1 liter? Sir, density of solution is given. This 1 to 5 is density only. So if you have 1 liter of solution, 1 liter of solution has mass of 1.25 gram. So 100 ml of solution, 1 ml will have, 1 ml has 1.25, so 1000 ml will have 1250 gram. This is weight of solution. Sir, weight of solution I know, weight of solute I know. Subtract. So therefore, what will be weight of solvent? Sir, total weight of solution minus weight of solute, as in 1250 minus 155.5. You're getting what I'm 155.5. Yeah, because this is if this would be 60 into 3 is 60 into 3 is 180. Okay. 180 minus 4.5. So 180 minus 4.5 is 175.5. I'm sorry. See, I do calculations like this. I make it round off to somewhere, some zero, and then everybody has their own way of doing mathematics faster. So this will be W1. Put W1, N2, you will get your answer. I have already supplied you with the answer, but with 2 place of decimal, the JEE have started asking integer type questions, so you have to be very religious with your calculations. Moving ahead. Again, a relationship between molality and mole fractions. You should learn them. What is it? X2 into 1000 upon X1M1. I am deriving it for you. How will you derive it, sir? You know what is molality. Molality is equal to number of moles of solute upon weight of solvent. If taken in gram, then 1000 will be coming in the numerator. Sir, I need mole fractions because I need relationship with mole fractions. So I will not disturb moles. This moles I like. Denominator, I have weight. I need moles. How can you convert weight into moles? Sir, number of mole is equal to weight upon molecular mass. So, molality can be written as N2 into 1000 whole upon, instead of this W1, weight is equal to moles into molecular mass. Simple. Sir, why you have created this difference? Have you written, impropriate way? No. There's a magic of maths. Remember what is the definition of mole fraction? Yes. Mole fraction of anything upon total moles. And magic of maths says if you multiply similar thing to the numerator and denominator, mathematically it is indifferent. It is same. So if I am dividing this, what is the beautiful formula that is created? What is this? You tell me. Sir, this is x2, n2 upon n1 plus n2. Sir, this is x1, formula derived. How? x2 into 1000 upon x1 m1. x2 into 1000 upon x1 m1. These all questions were directly asked initially by advanced, then by JEE mains. Moving ahead. Again, same approach you have to follow. How will you derive relationship between capital M, molarity and mole fractions? Sir, same thing. Molarity is equal to number of moles of solute upon volume of solution. If taken in ml, then 1000 will be there in the numerator. Sir, we very well know volume of solution can be written as mass is equal to volume into density. So, volume equals mass upon density. Density will go in the numerator. This density is gram per ml. Volume, that's why I have changed to ml. This will be in gram. Now, sir, moles I like because I want mole fraction relationship. Sir, weight I do not like. Again, what will be this weight of solution? This weight of solution is nothing but weight of solvent plus weight of solute. Sir, you said na, we do not want weight, we want mole term. So, converting Molarity is equal to N2 into 1000 into D whole upon. I'm deliberately making this gap. W1 can be written as weight equals moles into molar mass of that one which is solvent plus moles of solute into molar mass of that two that which is solute. Sir, we are seeing the formula. Where? Do the mathematical magic. N1 plus N2, N1 plus N2, mathematically it will be cancelled. So we are doing nothing wrong mathematically, but the beauty says this is x2, this is x1, this is x2. Formula x2 into 1000 into D upon x1 m1 plus x2 m2. Learn these formulas. Moving ahead, another concentration term is normality, and that's why I have combined mole concept and redox. Actually, we will see in the later slides, whenever we have to do stoichiometry, we have to know the reactants and products, and then only we can balance it and do the mathematics behind it, the unitary method stoichiometry. If we do not know the reaction, what can we do? Instead of number of moles, there is a law which is law of equivalence which says you can calculate number of gram equivalent of that particular components. Sir, what is number of gram equivalent? That's why a definition of number of gram equivalent and normality has been designed for you. Its advantages we will see in the later slides, but for time being let us define that. Just like molarity, another concentration term which you should know, and it's a definition so you should remember. It's normality represented as capital N. Just like molarity, which is number of moles of solute upon volume of solution, it is not number of moles. Instead of number of moles, it is number of gram equivalent of solute upon volume of solution in liter. So what is this number of gram equivalent? Obviously related to number of moles. So number of gram equivalent of solute is nothing but weight of solute upon equivalent weight. Like number of moles is weight upon molecular weight, it is weight upon equivalent weight. So what is equivalent weight? Equivalent weight of solute is nothing but its molecular weight but divided by its valency factor. So now what is valency factor? Valency factor for every substance is defined for their specific cases. For time being, we are taking valency factor to be VF and giving all these conclusions to the formula of normality. So normality becomes number of gram equivalent, which is weight upon equivalent weight. So weight of solute, W2, upon equivalent weight, which is molecular weight of solute upon its valency factor. So molecular weight of solute upon valency factor will go to the numerator, VF, valency factor. Generally, references take valency factor as N, but small n, we take number of moles. So no, I'm writing valency factor as VF upon volume of solution in liter. So this will be your basic formula for normality. I'm again giving you some conclusions. What are those? Number of gram equivalent is equal to number of moles into valency factor. You can very well see that. Number of moles into valency factor. Hello? Okay. Also, I can say normality is equal to number of moles of solute upon volume of solution is molarity. So normality is also equal to molarity into valency factor. So these are some conclusions of the definition of normalities. Now, sir, you haven't talked about valency factor. I told you valency factor is calculated for specific cases. Like for acids, what is valency factor? For acids, valency factor is number of H plus that they furnish during a particular reaction. I may have more number of H plus, but during a chemical reaction, whatever number I am furnishing will be my valency factor. So for acids, valency factor is number of replaceable H plus ions. For HCl, it is 1. For H2SO4, it is 2. For H3PO4, phosphoric acid, it is 3. Sir, but for H3PO3, for H3BO3, it is not. Hydrogen, we can see 3, but you have written some different number for phosphorus and boric acid. It is some inorganic knowledge. I told you, let me give you that knowledge also. If hydrogen has to be removed in form of H plus, it has to be connected with an electronegative oxygen. Only electronegative oxygen has that capacity to snatch electron of hydrogen and throw it out in form of H plus. If hydrogen is not connected with an electronegative species, my dear friends, that hydrogen is not acidic. It is reducing hydrogen but not acidic, and therefore is not replaced in a solution as H+. Therefore, H3PO4 phosphoric acid, all hydrogens are connected with electronegative O, so acidic hydrogens are 3. Number of H+ which an acid furnishes is also termed as its basicity. But orthophosphorus acid, you can very well see through chemical bonding, we'll be discussing this in chemical bonding also. The tetrahedral structure of phosphorus has one hydrogen attached with phosphorus. So this green hydrogen is reducing hydrogen, not acidic. So how many hydrogens are acidic? 2, sir. I'm sorry, this will be 2. Got it? Similarly, boric acid has 3 hydrogens. Sir, all these hydrogens are connected with oxygen, so it should give 3H+. No. Why? Because boron is a second period element. Second period element, because they are so small, they always want to complete their octet. Boron has 3 electrons in outermost shell, bonded by 3 bonds. 3 plus 3 is 6, not 8. So actually, it's a Lewis acid. It is very hungry for electrons. And therefore, when boric acid is added to water, it forces the lone pair of electron on oxygen to give electron to this acid, because it has huge positivity, huge hunger for electrons. So this electron, when moves to boron, this snatches electron of hydrogen. So actually, H3BO3 is giving 1 H+. That 1 H+ even does not belong to H3BO3. These H are not released in form of H+. H3BO3 is forcing water to release this 1 H+ and forming this negative part. Hello? So that's why its acidity is 1. For bases, what are the valency factors? For bases, thanks to Mother Nature, it is whatever they have, they give. NaOH have 1, gives 1. So number of OH minus ion given is 1, and number of OH minus ion given by bases are also known as their acidity and their valency factor. This gives 1. Calcium hydroxide 2 gives 2. Aluminum hydroxide 3 gives 3. Very good. Moving ahead. What is valency factor for salts? Salts are of 2 types. One, salts undergo redox transformation. We'll be discussing later. During redox transformation, they give and take electrons. For those salts, we'll be calculating valency factor in a different way. But for general salts, just showing displacement reaction, not undergoing electron transformations. For those salts, for basic salts, not basic salts, for normal salts, which are not during a particular reaction, which are not performing any redox transformation, for those salts, valency factor are calculated as their charge. Charge on what? Salt is a neutral species, sir. Whatever cation charge will be there, the similar will be an ion charge. You calculate charge on either ion. For example, over here, what is charge on ion? 1 plus 1 minus 1. So 1. Over here, 2. Over here, 3. But one molecule of this aluminium sulfate, aluminium has plus 3, but one molecule has how many aluminium? 2. So total charge is 6. Sulfate also has 6, minus 6. Sulfate has minus 2, 3 sulfate. So for normal salts, it's the charge on either ion. Last, valency factor for a redox doing salt, sir. We have to calculate their oxidation number, and my friends, in order to calculate their oxidation number, we will be discussing in the later slides for redox. Moving ahead, this we'll be doing in the later slides. Last valency factor. Now, since we have done so many, okay, I'll replace this. Since we have done so many derivation, let us practice some questions. Okay, so now whatever derivations we have done, let us apply those derivations and try to find this answer. This is a 2024 question. The question says, molality of an aqueous solution of urea is given. So molality given out to be 4.44 molar, as in moles per kg. Mole fraction of urea in solution. Mole fraction of urea in aqueous solution, as in mole fraction of solute. That is what is asked, my friends. X2 is equal to question mark. Let's say X2 I'm taking as A. That derivation. Remember, molality is equal to X2 into 1000 upon X1 M1. Remember? Sir, X2 we know. What is it? Sir, that we have to find A into 1000. upon what is x1? Sir, x1 is not given. Remember, mole fraction of solute and mole fraction of solvent. If you sum it, it is always equal to unity. So what will be x1? x1 is 1 minus x2 into what is M1? Molar mass of 1 as in solvent. Who is the solvent? Sir, aqueous solution as in water. So molar mass of water is 18. It's an equation in single variable A. Yes. Into divide will be definitely a thing which will be creating a huge difference between your JEE rank and a better seat into a better NIT or an IIT. So into divide is just in your hand. Solve it, you will get the answer, but you have to frame the answer in 10 raised to power minus 3 format. So into divide is definitely a thing which you should practice. Moreover, I'm giving you some more questions on concentration terms, but I'm just giving you those questions. Answer will be written over. You try, attempt. If you find any difficulty, comment in the description. We'll come back to it, because solution chapter also we'll find this question. Hence, in order to maximize and optimize time, I'm giving you these all questions because we said that we'll be giving you practice question also. You do not have to go anywhere else. Although the theory which I have discussed is more than sufficient to attempt these questions. Actually, it will build your confidence. Moving ahead. Moving to the last part of whatever we were discussing, redox reaction. What is a redox reaction? From 9th standard, you know, whenever oxidation reduction takes place simultaneously, such reactions are called redox reactions. What is oxidation, sir? This is the actual definition. The theoretical part I have already, those who want to read it, they can always read it. I am just summarizing it because it's a piece. It's a very norm. Those who do not know it, I have given you this PDF. Those who do not know it, still whatever I am explaining is more than sufficient. I'm not leaving anything. This theory will be more than sufficient for advanced paper as well. Now, what is oxidation? Oxidation is basically loss of electrons. Whenever I lose electron, I get oxidized. Opposite, whenever I will gain electron, this will be whenever I gain of electrons, I get reduced. Now, for instance, I'm an atom and I'm losing electron. I'm an atom, that is I'm neutral. If I'm losing electrons, protons, they're in the nucleus. I'm losing electrons, what charge I will get? Positive. So the increase of oxidation state, as in the situation, the state in which I am in, if it is getting increased as in look at the number line for oxidation number. If I am at -2, if I'm getting at 0, which talk just as you talk in the number line. If I am at -2, I am moving 2 steps forward to reach 0. So if any element has an oxidation state of -2 and it increases to 0, we say there is an increase in oxidation state. So from 0 to 5, obviously it is an increase in oxidation state. So whenever I lose electron, oxidation state increases. Whenever I gain electron, oxidation state decreases. Gain of electrons and decrease of oxidation state is reduction. This is actual definition. This is actual definition of oxidation and reduction. And whenever these things take place simultaneously, they have to take simultaneously, because if I'm gaining electron, somebody has to lose electron. Whenever these two things take place simultaneously, such a reaction is called redox reaction. Obviously, you must have seen in class 9th and 10th, addition of oxygen or any electronegative element with respect to myself is also oxidation. But you just see over here. Over here, what is the oxidation state of Fe? Sir, +2. What is oxidation state of Fe over here? +3. Oxidation state increasing. So if you go by this basic, every definition is just the same. Again, removal of hydrogen or any electropositive atom is also oxidation. For example, over here, for NaI, NaI is turning to I2. NaI is turning to I2. How? An electropositive atom, sodium, is getting removed. Leave it. What is oxidation state of iodine over here? -1. What is oxidation state of iodine over here? 0. From -1 to 0, oxidation state is getting increased. So whenever you have to check whether somebody is getting oxidized or not, check their oxidation state. Increase of oxidation state is oxidation, decrease of oxidation state is reduction. When your oxidation state decreases, when you gain electrons. Or addition of hydrogen and removal of oxygen, exact opposite, will give you what is reduction. Moving ahead. Now, sir, oxidation state you are telling us. How can we find oxidation state? See, oxidation state basically is calculated by some basic set of rules. First, let me give you those basic set of rules. Then I'll come back to it. Because these rules you must be knowing. What are the basic rules to assign oxidation state to any atom? Rule number 1. Fluorine, if fluorine is forming a compound, fluorine being the most electronegative atom, always has an oxidation state of -1. Before that, let's talk about oxidation state for just a while. What is oxidation state? When I am an atom and forming a compound, there will be some partial charge which I'll be getting. With the tussle of electron, I'm attracting from somebody is attracting from me, from whom I will attract, from whom I'm more electronegative. Who will take away electrons from me? Those who are more electronegative than me. So it's a relative thing. So whatever partial charge stays with an atom is its oxidation state in that particular compound. So fluorine being most electronegative always forms compound in oxidation state of -1. In free state, what is free state? The state in which elements exist in nature. For example, in nature, sodium, magnesium, all these metals exist as solid. In nature, oxygen as an molecule exists as O2 gas, fluorine as F2 gas. So whenever an element is existing in its native state, its oxidation is assigned to be 0. Metal in their compounds, whenever alkali metals, alkaline earth metals and aluminium, whenever they are in their free state, in metallic state, 0. But whenever they are forming their compounds, alkali metal, that is group 1, always in +1 state. Alkaline earth metals, group 2, always in +2 state. Aluminium, always in +3 state. These are certain set of rules which has been observed by Mother Nature and set for you, given in NCERTs. Now, oxygen in free state, O2, 0. Oxygen when form compound, it generally forms compound as an oxide. So for oxygen, the oxidation state is -2 generally. Why generally, sir? In case of peroxides, what is peroxide, sir? H2O2, Na2O2. What are their oxidation state? You can simply say it. 2 getting cancelled, so oxygen will be in -1 state. Sodium always in +1 state, 2 getting cancelled, +1, -1. So in case of peroxide, the oxidation state of oxygen is -1. In case of ozonide, what is an ozonide? Very rarely seen, like KO3. Potassium always in +1 oxidation state, so O3 will be in -1. O3, 3 units of oxygen will take -1 charge. So there are 3 oxygen atoms collectively taking -1 charge. So for one atom, what amount of charge it is getting? -1/3. Hello? Now, last. As I have told you, fluorine is the most electronegative. So if oxygen is forming a compound with fluorine has the ability to be in -1 state. Oxygen has to be in plus state in front of fluorine. So over here, oxygen is in +2 state. Over here, oxygen is in +1 state. Moving ahead. 5th rule says hydrogen in free state as H2, 0. And hydrogen generally, when it forms compound, it generally exists in +1 state. Just like, although it is not an alkali metal, but since it is group 1, so generally it exists in +1 oxidation state. But there are also exceptions like metal hydrides. If that hydrogen is there forming a compound with alkali metals, alkaline earth metals, hydride, aluminium, the rule above which we have studied applies. They will be in positive oxidation state and hydrogen will be forced to be in -1 state. Whenever hydrogen exists in -1 oxidation state, it is called a hydride. Example. Sixth, not last, but one of the very famous rule. The algebraic sum of all the atoms, the algebraic sum of oxidation state of all the atoms is equal to the charge on the complete species. If the species is a molecule, charge is 0. If the species is an ion, charge is equal to that particular value which the charge is having. I am giving an example for this. First, let me give you an example. Okay, before giving an example, let us finish one more rule. Generally, halogens, I'm not talking of fluorine. Fluorine is always in -1 state. Generally, halogen, because they are also electronegative, they exist in -1 oxidation state. But what are the exceptions? When these halogens are present with oxygen, fluorine, which are more electronegative, they can exist in positive oxidation state. But generally, their oxidation state is negative. Now, that algebraic sum, this rule, the most important rule I'm explaining you with an example. Let us watch some examples for that. Now, if somebody is asking you what is the oxidation state of chlorine, apply the rules. Sir, potassium, alkali metal can always form compound in +1 oxidation state. Chlorine, I do not know its oxidation state, so let's say its oxidation state is X. Oxygen always exists as oxide, -2. How many oxygen? 3. 1 will have -2, so 3 will have -6. So what I'm doing is algebraic sum of the oxidation numbers is equal to charge on this species. This species is neutral, sir. So what is charge it is carrying? 0. Do the math. You will get X is equal to +5. So what is oxidation state of chlorine in this particular case? +5. Two rules combined together. Chlorine not in negative oxidation state because forming compound with oxygen, more electronegative. So chlorine is forced to give electron to oxygen. Now, similarly, iodine, I guess this is the same story. Hydrogen in +1, X -6 equal to 0. KBrO3, I guess same state, same mathematics. So all are in +5 oxidation state. Also explained you the algebraic sum rule. Moving ahead. Yes, now for many questions, you have to, this is an inorganic part of chemistry, but you have to remember names and charges and formula of some important cations and anions. Some important anions and some important cations. Their charge and their name I have written. I do not want you to mug all of them up. Just keep it with you. Maybe get a printout, maybe write it in a copy and put it in front of your desk. So whenever you come across with questions, at least the questions that you come across with, try and check and you will find it will automatically get into your system. But if you can, read them in the morning, 1, 2 times, you will get to know. But I suggest these ions you should remember. Moving ahead. Some examples for determining. Now, before determining oxidation state, what easily we can do? Sir, rules you have decided. But there are some cases when these rules fail. What are those cases, sir? And JEE has a habit of asking oxidation state of those species as well. This was the slide which I skipped initially. Now coming to it. Defined oxidation state. For example, if you are asked what is the oxidation state of oxygen, you can very well do the calculation. Calculation as in water is H2O, crisscross from 9th standard, hydrogen is in +1 state, oxygen is in -2 state. Remember, it's not the complete charge. So whenever I write oxidation state, I put a circle. That is that partial charge. Overall, the molecule is neutral. So whenever I write oxidation state, you also make this thing a point. Whenever you write oxidation state, encircle that oxidation state. Sir, we are easily calculating what is the oxidation state of oxygen? -2. But I am giving you one more method. Actually, that is the actual method. How oxygen is getting this -2 state. See, if I am forming a bond, single bond with any atom, who is more electronegative? Me or that one? If I am, then I'll attract those share of electron towards me. One electron is mine only. I have with compulsion attracted electron of that particular species, that particular atom, that particular combined atom, covalently bonded atom. So whenever one bond is there, to the electronegative atom, it will attain a partial charge of -1. To the relatively electropositive atom, they will attain a relatively partial positive charge. Let me tell you. See, over here, oxygen and hydrogen, they are forming one. So contribution will be 1-1. Why? Because one bond is shared. Oxygen will be taking -1 and hydrogen will be having +1 because its electron has been attracted by oxygen. Similarly, over here, contribution 1-1 because there is a single bond. Oxygen is -1, hydrogen is +1. Then sum up. So what is the overall oxidation state of this hydrogen? +1. This hydrogen +1. This oxygen -1 from here, -1 from here. So it will be -2. Very easy, but you should know this. Similarly, I'm just concentrating on oxygen right now. Contribution 1-1. This is -1. This is +1. Here also contribution -1, +1. But if two atoms are forming single bond and both are same, will anybody attract more or less? No, because both have same electronegativity. Then if not contributed, then what? Sir, partial charge attained is 0. So from here contribution will be 0-0. Sum up. So the net oxidation state on oxygen will be -1. Remember, whenever oxygen is in -1 oxidation state, peroxide. Bingo. Now, over here, can you tell me the oxidation state of sulfur? Sir, easy. Sir, if single bond is made, contribution is 1 and is double. If two bonds are made, contribution are 2 because 2 electrons are shared. So from this side, from the upper side, sulfur will have a +2 charge. From lower side, it will have a partial charge. From this oxygen +1 and from this oxygen +1. So what is the overall oxidation state of sulfur? It has an oxidation state of +6. I guess for calculating oxidation state by these methods, you at least should know how to make the formula, the structure of the formula. What structure? The Lewis structure. So chemical bonding and inorganic has to be right for such cases. Generally means do not ask such questions, but recently they have started asking, so I'm discussing. Moving ahead. This is perchlorate ion. Can you tell me oxidation state of chlorine? Easily, sir. From above oxygen, it will have +2 because oxygen will take -2. From here also +2. From here also +2. Over here, 1 electron is shared. So from here +1. So what is overall oxidation state of chlorine? 2, 2, 2 and 1. That is +7. You can also calculate this using algebraic sum. I'm explaining you how. ClO4 minus. So if you are asked what is the oxidation state of this chlorine, let's say it is X. Oxygen -2 state. How many oxygen? 4. 4 2 ja 8 equal to -1. +7. Sir, if algebraic sum method is applied, why you are telling us this? This is trouble. Why we should draw this? Because sometimes this algebraic sum will not give you perfect answer. Sir, when will we know? The answer that will be coming after algebraic sum is always the average. Sometimes with quotient also you will get a feeling. Like I'm giving you some examples. Nitrite ion, it is easy. +2 from here, +1 from here. So overall charge is +3. Now, see, for example, you have this in NCERT also, this topic is given as paradox of oxidation state. Asked in JEE. That's why discussing. I'm asking you what is oxidation state of carbon. Now you apply formula. So I do not know oxidation state of carbon. Let's say it is X. How many carbon? 3. So 3X. Oxygen -2 state. How many oxygen? 2. So -2 into 2 is -4 equal. Overall molecule is neutral, so 0. So 3X becomes 4. So X becomes 4/3. Sir, carbon has 4/3 charge. Sir, you said electron is the fundamental particle, only electron is always quantized. I can have a transaction of 1 electron, 2 electron, 3 electron. How can I have a transaction of 4 by 3 electron? No. From this value also you are getting it. It's an average. So in order to understand exactly what is the charge distribution, you have to draw the structure. This is the paradox of oxidation state. So make the structure. For carbon suboxide, I have made the structure for you. Sir, this structure we should remember. The structure with practice you should know. Now that thing will help you. Over here, carbon is making how many bonds? 2 bonds with oxygen, electronegative. So oxygen will get -2, carbon will get +2 from this side. From here, contribution will be 0 because atoms are similar. From here, it is also 0. Over here, it is getting +2. So this carbon is in 0 state, this is in +2 state, and this is also in +2 state. So carbon suboxide as a family has got 3 carbons. Like in a family, there are 3 sons or there are 3 men. Out of those 3 men, 1 man is earning 2 rupees. 1 man is earning 2 rupees and the third man is not earning anything. So what is the average men's are earning in the family? 2 plus 2, total 4 rupees. But that 4 rupees is earned by 3 members. So average earning per member is what? 4 by 3. So this algebraic sum always gives you a average oxidation state. In order to get the exact oxidation state, sometimes question asks, you should know. Now, I should ask you that you should make the structure of Caro's acid and tell me its oxidation state of sulfur. So similarly, for Caro's acid, if you apply the algebraic sum formula, hydrogen is +2, sulfur I do not know, X, oxygen are 5, so 5 2 are 10 equals 0. So X equals how much? +8. This is completely wrong, sir. No, why? Over there were 3, so average was coming, but over here only sulfur is there, so why can't we use algebraic sum formula? How many electrons sulfur has in its outermost shell? Oxygen family, 6. What is its oxidation state? 8. Can I give electrons more than present in my valence shell? No. In such cases also, I told you, when you apply those rules and calculate, the answer will tell you, no, there is some problem, there is some paradox, you have to draw the structure. In order to draw the structure, you should know the inorganic behind it, that is the chemical bonding structure of it. I have drawn that Caro's acid. Caro's acid is a very famous acid, also known as peroxo monosulfuric acid. Peroxo. Actually, what we did wrong is, with this -10, we assumed that all oxygen are in -2 oxidation state. No. Out of these 5 oxygen, as you can see, 3 oxygen are in -2 state, but 2 oxygen are peroxides. Sir, how will we know this? You do not have to know this. Draw their structure by chemical bonding basic. We will go into that chemical bonding when we will discuss that chemical bonding, but as of now, this is its structure, and if it is its structure, can you tell me its oxidation state? Yes, sir. From upside, sulfur you will get +2. From downside, it will get +2. From right side, +1. From left side, +1. So 2, 4, 1, 1, and so it will be 6, +6. And +6, sulfur can give. Sulfur can attain because in outermost shell it has 6 electrons. Now, next is tetrathionic acid or the tetrathionate ion. Acid is H2S4O6. If acid gives H+, what is the ion called? It is called tetrathionate ion. I'm giving you some good examples, right? So how many sulfur are there? 4. I'm not doing this algebraic sum because you know that will give you average. I want the exact oxidation number of all the 4 sulfurs in the family of tetrathionate ion. I guess now it is easy for you. From above +2, from here +2, from here +1. But this is sulfur, so contribution will be 0. So this sulfur will be in +5 state. It is 0, it is 0. And this sulfur is also in +5 state. So how many sulfur are there? 4. How many brothers are there? 4. Out of them, 2 brothers are earning +5 charge and 2 brothers are not earning anything. They are earning 0 charge. So what will be the average? +10 by 4, 10 by 4. For the algebraic sum, you will getting that. But sometimes you are asked what is their actual charge. Moving ahead. These are some more examples. This is peroxo disulfuric acid, also known as Marshall's acid. It also has got 1 peroxide linkage, but oxidation state of both the sulfur will be +6. You can very well see. Butterfly structure of CrO5, the famous structure, butterfly. These are the wings. These is the soon, the whatever bio people know. So what is oxidation state of this chromium? From these two double bonded oxygen, it is +2. From this +1. From here +1. From here +1. From here +1. Why? Single bonded, contribution 1, 1. More electronegative, -1. Double bonded, 2, 2. Triple bonded, 3, 3. More electronegative, -3. Less 1, +3. Easy. What is the overall oxidation state? +6, sir. Moving ahead. Hypersolution, very famous, also known as sodium thiosulfate, Na2S2O3, very famous structure. You tell me the oxidation state of sulfur, both the sulfur, this sulfur, contribution 1, 1, sodium is electropositive, so +1, this is -1. Over here, contribution is 0, 0. So this sulfur is fixed in -1 state. Net charge -1, 0 is -1. This sulfur from here 0, but from here +1, +2, +2, the overall +5. So how many sulfur are there? 2. 2 brothers. One brother is getting +5 charge, another brother is getting -1 charge. So what is the overall charge? 2 brothers are getting 4. +5, -1, 4. 4 by 2. So average will be coming 2. But nobody is taking 2 or giving 2 electrons. It is taking +5, it is taking -1. Understood. Moving ahead. Tribromo octoxide, this is its structure. If you try to find oxidation state, very well, you can easily do that. This bromine is +2, +2, +2, so +6, because this bromine 0, 0. This is also +6, so this is +6, this is +6, and this is +4, because these contributions are 0. Moving ahead. These rules we have already discussed. Going with some more examples. These are some, okay, you have to calculate oxidation state of carbon. This carbon. How can we calculate, sir? On intention, I have given you these questions. For these questions, remember I told you should learn the cations and anions and the charges. What is C2O4, you tell me? If you read that table, you'll know it is an oxalate ion. What is an oxalate ion? C2O4. What charge it has? 2-. So if it is C2O4 2-, then this definitely has to be Fe+2, because Fe can be +2 also, +3 also. That you have to determine, predict by knowing certain inorganic facts. So because I know this anion, so I'm writing it separately. C2O4 2-. So what is oxidation state of this carbon? I do not know. So X, how many carbon? 2, so 2X. -2 4 ja 8 equals -2. So 2X equals +6, so X equals +3. Bingo. Moving ahead. Oxidation state of nitrogen, ammonium nitrate. Okay. Ammonium nitrate is a salt containing nitrogen in cation also, nitrogen in anion also. What is ammonium ion? NH4+, hence written like this. What is nitrate ion? NO3-. Sir, why chemical bonding structure not written? You can write also, but algebraic sum also we know. So do the fractional oxidation thing. Nitrogen, from above it will attain -1, -1, -1, -1. So for 4 bonds it has attained -1, but it already has a charge of +1. So what is its net oxidation state? -4 +1, as in -3. Or else you can do simply also NH4+. I do not know oxidation state of nitrogen. Let's say it is X. Hydrogen is +1 in front of nitrogen. It's electropositive. So +4 equals +1. So X equals -3. I was just giving you an example to do both ways. Now, what is the oxidation state of nitrogen, sir? X, 2 3 ja 6 barabar -1. So X equals +5. I hope you're getting this. Hydrogen cyanide. You tell me oxidation state of everybody. Contribution 1, 1. This is +1, this is -1. Carbon is more electronegative than hydrogen. Contribution 3, 3. -3 +3. So hydrogen it is fixed +1. Nitrogen it is fixed -3. But for carbon you have to do +-. +3 -1 is how much? +2. Over here, contribution 1, 1. This is +1, this is -1, this is fixed because it has only one contribution. Nitrogen, 2 double bonds. So contribution 2, 2. A nitrogen electronegative -2, carbon +2. Sir, what about coordinate bond? There is a coordinate bond also. For coordinate bond also, there is a, how many electrons you are giving? 2. So coordinate bond also, there is a contribution of 2, 2. But when I want to give, when I'm electropositive. When I can donate you, when you are electronegative. Over here, who is donating? Electronegative. In such cases, do not, these are some rules, some hectic rules. You can leave this, but I'm still telling you. When the coordinate bond is formed by an electronegative atom, the contribution is not considered. The contribution is considered as 0, 0 because the partial charge does not actually come, because I do not wish to give. So what is the overall oxidation state of nitrogen? It is -3, and for carbon it is +2. Moving ahead. Yeah, very famous example, bleaching powder, CaOCl2. If you just do whatever I have told you, you do not have to go through many questions also. Just do the questions which I have given you, which will be there in the assignment. Those are more than sufficient. Now, what is bleaching powder? Bleaching powder is a mixed salt. What is a mixed salt? Sometimes, generally a salt contains a cation and an anion. Sometimes a salt contains one cation but two anion. One anion but different cations. So ratio is not 1:1. For example, bleaching powder is CaCl2. It has got one cation, calcium +2, but two anions, chloride and hypochlorite ion. What is chloride ion? Cl-. What is hypochlorite ion? I told you, ions you should learn. What is hypochlorite ion? OCl-. Tell me oxidation state of this oxygen. Sir, contribution 1, 1. Oxygen mole electronegative -1. This is +1. So overall -1 it has got from chlorine. Minus charge it already has. So overall oxidation state is -2 for this oxygen. For chlorine, it is +1. This chlorine, sir, -1 charge it has. Just it is only present. So oxidation state is -1. Whatever charge the ion has, it's their oxidation number. Now, again, NOCl, very famous example. Chemical bonding says nitrogen has 5 electrons in outer shell. How many bonds it will make? 3. Octet of chlorine is also complete. Oxygen is also complete. Although second period element octet has to be completed. This structure, because of presence of electronegative oxygen, this oxygen with nitrogen attains a positive charge. Because bond length, I'm sorry, not electronegativity, bond length. Here bond length dominates. Because bond length is larger, bond breaks. How the bond is breaking? NO plus and Cl minus. You tell me, if you know this inorganic logic, you tell me the oxidation state. Sir, oxidation state. Over here contribution is 2, 2. Oxygen is -2, this is +2. Nitrogen has already got +1 charge. So, nitrogen has already got +1 charge. So, +2 getting from oxygen and +1 it's already have. So, its state is +3, chlorine is -1. Very famous example. You should know this. Now, such questions, what is oxidation state of cobalt? I do not know what is its oxidation state. Let's say X. Cn- is called cyanide ion. Cn- is called cyanide ion. How many cyanide ions? 6. -6 equals -3. So, X equals +3. Moving ahead. Yeah. Now, some types of redox reaction. Redox, what is the redox reaction? Sir, we already know. What is it? When oxidation reduction takes place simultaneously. So, let us talk about types of. Yes, so basically the types of reaction that you have studied in your foundation classes, those type of reactions applies for redox reaction as well. Like for example, combination reaction, when two elements combine and form a new species. For example, magnesium combining with nitrogen, forming magnesium nitride. Do the oxidation number thing. Over here, oxidation state of magnesium is 0. Crisscross, magnesium is +2, nitrogen is -3 in form of nitride. So, magnesium from 0 to +2 getting oxidized. Remember the number line, from 0 to +2, oxidation number increases, oxidation. Nitrogen from 0 to -3, oxidation number decreasing, reduction. A redox reaction. What type of redox? A combination redox reaction. Now one thing, mains directly ask these questions. What? If I am getting oxidized, what am I doing on front of electron? I am losing electron. If I am losing electron, somebody is gaining that electron and getting reduced. So a person who oxidizes itself reduces the other person. So magnesium getting oxidized and reducing nitrogen, and hence magnesium solid over here is termed as a reducing agent or simply reductant. Conversely, if I am getting reduced, I'm making the other person oxidize. So the person getting oxidized, getting reduced, oxidizes others and termed as the oxidizing agent or oxidant. This identification only will make a question for you. Like over here, nitrogen gas is acting as an oxidant. Moving to other type of redox reaction, decomposition. Potassium chloride solid is getting decomposed. Let's look at the oxidation state. Here, oxidation state of chlorine is +5. We have dealt with calculation of oxidation state previously. So I've just written it directly. Oxidation state of chlorine is +5. This chlorine is getting into -1. +5, -1. Oxidation number is decreasing. Oxidation state is decreasing. Reduction. Oxygen from -2 state going into 0. From -2 to 0. Number line getting increased. Increase of oxidation state is oxidation. If I'll ask you, oxygen is getting oxidized, therefore here oxide acts as a reducing agent, whereas chlorine in +5 state acts as an oxidizing agent. Moving ahead. The other type of redox reaction is the basic displacement reaction. We very well know this from class 10th also. We will be discussing more about this in electrochemistry also. So that part of redox I have left for electrochemistry. What part? The electrode potential comparison part. As of now, pause for it, wait for electrochemistry. First type of displacement is metal displacement. For example, in a solution of copper sulfate, a blue color solution of copper sulfate, zinc is added. So this zinc solid displaces this metal. So metal displacing metal, but a type of redox reaction. How? Zinc in 0 state, when goes into solution and forms zinc sulfate aqueous, a white vitriol of this white vitriol, in this white vitriol oxidation state of zinc is +2. So 0 to +2, it is getting oxidized, copper is getting reduced. A metal displacement. Similarly, non-metal displacement can also be seen. We very well know active metals reacts with water and forms what? Hydroxide and produces hydrogen gas. Remember, inorganic basic, hydrogen is gas is highly inflammable, and hence these active metals should not be kept near water. In fact, they even react with moisture. The reaction that is taking place is again a redox reaction. Here, potassium, which is in 0 state, when forms KOH, is in +1 state, getting oxidized. Who is getting reduced? Hydrogen. From +1 state, when hydrogen is forming H2 gas, it's 0. Oxidation state is getting decreased. Therefore, it's a reduction. It's a basic thing. But I'm not leaving anything aside. The last and the most important type of redox reaction is disproportionation reaction. What is disproportionation? If a same element gets oxidized also and gets reduced also. Sir, how can one element can furnish both the jobs? If you take even a drop of a compound, now after this mole concept, don't you know a drop of a compound can contain millions of molecules? So some of those molecules may oxidize, some of those molecules may get reduced. But in those molecules, the same element has to oxidize and the same element has to get reduced. Then such a reaction is known as a redox reaction, disproportionation redox reaction. For example, the famous example, hydrogen peroxide, highly unstable liquid. This hydrogen peroxide, here oxygen is in -1 oxidation state. When forms water, oxygen becomes -2. So -1 becomes -2, oxidation state decreasing, so it is getting reduced to form water. It is also getting oxidized to form oxygen. Why? -1, 0, oxidation state increases, hence oxidation. So whenever a same element gets oxidized also, reduced also, such a reaction is known as a disproportionation redox reaction. Now, sir, when you were discussing about normality, you said something. You said normality is just defined for the case of simplicity for our calculations. Remember? Because normality had number of gram equivalent of solute or of any substance in its numerator. Sir, what does number of gram, how does number of gram equivalent help us? The law of equivalence. Before understanding the law of equivalence, let us again revise what are number of moles and the stoichiometry that we have studied. If you have a balanced reaction, for writing a balanced reaction, you should know what are the reactants and products. Inorganic or organic, behind the reaction, you should know the chemistry behind it. And then only you can balance the reaction and obtain these stoichiometric coefficients ABC, ABCD. How can you stoichiometrically equate moles of reactants and product produced? This is called moles of a reaction. Moles of a reaction can be written as, for a balanced reaction, remember, moles of reactant A upon stoichiometric coefficient of A will be equal to moles of reactant B getting reacted upon stoichiometric coefficient of B. This will be equal to moles of product C produced upon stoichiometric coefficient of that particular product, small c. This will also be equal to moles of product produced, capital D, upon stoichiometric coefficient, small d. So moles can only be equated using these moles of reaction equation, which you have already done through stoichiometry, the unity method thing. But if I even do not know a reaction, doesn't matter if you have balanced it or not. For many cases, even if you do not know what are the various products produced, for example, A and B and so many other reactant may react and form C and D and so many other products, I do not wish to know the reaction. I do not even wish to balance the reaction. Why? Because law of equivalence gives you an edge. What is that edge? It says if some A is getting reacted with some B, whatever moles they may react as per the balanced reaction, you don't even write that balanced reaction. Law of equivalence says number of gram equivalent, not number of moles, number of gram equivalent of A reacted will always be equal to number of gram equivalent of B reacted. This will always be equal to number of gram equivalent of whatever product C produced or number of gram equivalent of D produced. Sir, we understood this theoretically, but how come it is helping us? Let me give you a basic example. This is a basic example to understand this. Very basic, 10 standard example. Suppose I have told you H2SO4 as an acid is reacting with NaOH. You know nothing inorganic behind it, you know nothing. Let's say you do not know that 1 mole of H2SO4 reacts with 2 mole of NaOH and produces 1 mole of sodium sulfate and 2 moles of water. You know this reaction and therefore we have balanced it. Suppose I do not know this reaction, but still I am saying H2SO4 is reacting with NaOH. I have not written the product. Can you tell me if 10 moles of H2SO4 is getting reacted, how much moles of NaOH will be required? Yes, by law of equivalence. This is reacting with this. So number of gram equivalent of H2SO4, number of gram equivalent of H2SO4, I'm sorry, number of gram equivalent of H2SO4 will be equal to number of gram equivalent of NaOH. Simply, this is the victory, this is the main importance, usage, advantage of law of equivalence. That number of gram equivalent are always equal. And you know what is number of gram equivalent? Sir, during normality we have seen it is equal to number of moles into valency factor for that particular substance. What is this substance? This is an acid. What's the valency factor for an acid? Number of replaceable H plus ions. So how many moles of H2SO4 are getting reacted? Number of moles into valency factor of H2SO4 is 2, because number of gram equivalent is number of moles into valency factor. Again, you have to calculate number of moles of NaOH reacted. Let's say it is A. What is valency factor of a base? Sir, number of OH minus ion given 1. So what is A? 20 moles. Bingo. Sir, can we do it with the stoichiometry? We have done so many questions for stoichiometry. Please tell us how to do using stoichiometry. Again, you can either do by stoichiometry, which we already did, or you just calculate the recent thing that I've told you, moles of reaction. So Moles of H2SO4 reacted upon stoichiometric coefficient 1 will be equal to moles of NaOH reacted upon its stoichiometric coefficient 2. Now put it. So this is 10 upon 1 is equal to moles of NaOH upon 2. Again, you are getting the same answer, but for this, you have to know the reaction, write the reaction, balance the reaction. Therefore, whenever you know how to calculate valency factor for any substance, you do not need to write the complete reaction. This is the main advantage of normality term and number of gram equivalent term. What is always equal? Number of gram equivalent. So finally, I'm telling you what are the methods to calculate number of gram equivalent. We already know. Number of gram equivalent, the basic formula, weight upon equivalent weight, EW. It can also be written as number of moles into valency factor, or we did in the previous slide. Number of gram equivalent can also be equated as normality into volume. Remember, normality is equal to number of gram equivalent of solute upon volume of solution in liter, cross multiply. So number of gram equivalent can also be calculated as normality into volume. Normality, we know it is molarity into valency factor. So instead of N, I can write molarity into valency factor into volume in liters. So whenever you are supplied with two reactants, you can always equate the number of gram equivalent. And this question is very famous in JEE. What the question making person do is number of gram equivalent you have to equate. Sometimes you use this formula, sometimes you use this formula. Use this formula for A, use this formula for B. They hide one of the variable and ask you the question. So number of gram equivalent has how many formulas? 4. Number of moles into valency factor, weight upon equivalent weight, normality into volume, molarity into valency factor into volume. But that volume has to be in liters. Moving ahead. Now, sir, because you have given us the law of equivalence, now let us again practice some of the calculation of valency factor. Or if you know valency factor, you can always calculate the equivalent weight of that particular substance. How? Because equivalent weight is equal to molecular weight of that substance upon valency factor. So let us practice some valency factor or maybe equivalent weight calculation, because if you calculate valency factor, what will be the equivalent weight? Molecular weight upon valency factor. There are some important questions which JEE loves. So I've listed everything. Do not worry. Just practice is in your hand. Just revise this a few times and JEE will be yours. Now, so for some redox participating species, like for first species, which is potassium permanganate, actually it is coupled with some basic inorganic knowledge. That's why I've used them. We all know KMnO4 potassium permanganate is an oxidizing agent. What does an oxidizing agent? Remember, oxidizing agent oxidizes others, it will reduce itself. In KMnO4, who is the active ion which participate in electron transaction in redox? Permanganate ion. What is permanganate ion? MnO4 minus. K plus is just a spectator, does not involve in the redox part of the reaction. So that's a spectator ion. So when we are dealing with electronic transition, we only concentrate on that particular ion which is actively participating in electron transaction, that is in redox. So in KMnO4, who is the active species? MnO4 minus, which is permanganate ion. Permanganate ion will oxidize others and reduce itself, but it reduces itself in different forms. It is NCERT D block elements, basic, always used in physical chemistry as well. In acidic medium, it reduces itself to Mn+2. In neutral or weakly basic medium, it reduces itself to MnO2, in which state of manganese will be +4. Do the oxidation thing, X minus 4 equal to 0, the algebraic sum. In basic medium, it reduces itself to manganate ion, MnO4 2 minus, in which the oxidation state of manganese will be +6, X minus 8 is equal to -2. So this oxidation state is +6. I have written these oxidation states because oxidation state calculation I have done previously. Now, how you have written these valency factors, sir? Number line. How many Mn are there in one species, one ion of MnO4 minus 1? What is its state? +7. Where it is going in acidic medium, from +7 it is going to +2. So how many electrons it has gained? Sir, 5. From +7 I am coming to +2. So how many steps you have to step up? Sir, 5 steps. From plus 7, 6, 5, 4, 3, 2, 2. So 5 steps. Plus 7 to plus 2, 5. Valency factor 5. So in this particular case, what will be the equivalent weight of KMnO4? Sir, molecular weight of KMnO4 upon 5. If it is getting reduced to MnO2, from plus 7 it is coming to plus 4, plus 7 to plus 4. How many steps? 3 steps. Valency factor 3. From plus 7 to plus 6, how many steps? 1 step. So in highly basic medium, what is equivalent weight of KMnO4? Molecular weight of KMnO4 upon valency factor will be 1. This dichromate ion I have left initially, remember, during normality, again discussing because now you know oxidation state. Chromium has an oxidation state of plus 6. How? Algebraic sum, 2x minus 14 is equal to minus 2. Solve for x becomes plus 6. Here, iron, whatever charge it has, that will be its oxidation state. So from plus 6, chromium is getting into plus 3. So how many electrons it has gained? 3. Sir, but you have said valency factor is number of electrons transacted per unit of the ion, active ion. If this is one family, my friends, dichromate ion is a family. So one dichromate ion, which is Cr2O7 2-, in that family, how many chromium you have in plus 6 state? There are 2 chromium, 2 brothers. Both the brothers are in plus 6 state. Both the brothers will get into plus 3 state. So one brother will gain 3 electrons and the other brother will also gain 3 electrons. So here, this 3 has to be multiplied by 2. So it will be 6. So for 1 unit of the ion, how many electrons are getting transacted? 6. So valency factor is 6. So what will be the equivalent weight of K2Cr2O7? Molecular weight of K2Cr2O7 upon 6. Moving ahead. Now, ferrous oxalate. Yes, ferrous oxalate is also a very, very, very famous compound. Now, know the inorganic behind it. Whenever ferrous oxalate undergoes redox, what does it do? It changes itself to ferric ion and the oxalate part changes itself to CO2 gas. Let us see what it is doing with itself. We very well know ferrous ion has Fe in plus 2 states. So this Fe is in plus 3 states. Sir, it is getting oxidized. Okay. Here carbon C2O4. What is the oxidation state of carbon? Can you tell me? Do the algebraic something. Sir, 2x minus 8 equals minus 2. So what will be x? 6 by 2 as in plus 3. So from plus 3, it is going into what state? Sir, plus 4. So from plus 3, if I am going to plus 4 state, I am increasing. Sir, it is also getting oxidized. That means this whole molecule itself is getting oxidized. Therefore, it will be a reducing agent. But what will be its valency factor? Sir, this 1 unit, both the ions are getting oxidized. This 1 unit, how many electrons it is getting? It is releasing 1. Why? 2 to 3, 1. How many electrons this C2O4 2-, the carbon, from plus 3 going to plus 4, 1. But this 1 unit contains how many carbon? 2. So both the carbon from plus 3 will go to plus 4. So both the carbon will give 1 electrons. So this will be 1 into 2. So how many electrons it has given? 1. How many electrons it has given in total? 2. So what are the electrons given in total? 3. 1 plus 2. So what will be the valency factor of ferrous oxalate? 3. Remember? Keep this thing in mind. Do not do it all the time. Some data you have to remember. These are very famous data. Now, hyposolution. Again, a sodium thiosulfate, Na2S2O3. We have drawn a structure also. What is thiosulfate ion? S2O3. Thionate ion is S2O3 2-. Oxidation state of sulfur is plus 2. Do the algebraic sum. In acidic medium, again an inorganic knowledge, in acidic medium, it dimerizes itself, S4O6 2-. The oxidation state of sulfur becomes 2.5. From plus 2 to 2.5, what is the oxidation state? What is happening to the oxidation state? Getting increased. So it is oxidizing itself. This also is a reducing agent. In acidic medium, what is its valency factor? From 2 to 2.5, half. But how many sulfur are there? 2. So 0.5 into 2 is 1. So its valency factor will be 1. Simple. S2O3 2 minus in basic medium changes to sulfate ion. Do the oxidation state thing from +2 going to +6. So from +2, if I'm going to +6, how many electrons I have transacted? 4. But sir, one sulfur will transact 4. One species, one ion has how many sulfur? 2. So 2 into 4 is 8. So valency factor will be 8. So in basic medium, what will be its equivalent weight? Its molecular weight upon 8. I hope you got this point. Moving ahead. There are some intramolecular redox reaction. What is intramolecular? Redox within the molecule. Let us see an example. For example, ammonia. Again, an NCRT reaction which is used for production of nitrogen gas. Ammonium nitrite, when thermally decomposed, forms nitrogen gas and water. You tell me first what type of reaction it is. And again, it is a decomposition reaction. But whether it is redox or not, we'll check the oxidation state. Ammonium ion already done. You can again do the algebraic sum. Nitrogen state will be -3. Nitrite ion nitrogen state will be +3. So from -3, I'm going to 0. What is getting over here? Sir, oxidation. From +3, I'm reducing my oxidation state to 0. So this becomes reduction. Sir, oxidation and reduction taking place in the same molecule. Intramolecular redox reaction. You tell me what will be the equivalent weight of ammonium nitrite. Some people do what? Some people say, sir, -3 to 0, so 3. +3 to 0, so 3. So sir, its valency factor will be 3 + 3, 6. No. Sir, why no? Previously you did this. Beta, both the species were doing the same thing. If one molecule of ferrous oxalate is taken, both are getting oxidized, both are giving. So in total, how much they are giving? 3. But in total, this is giving 3 because getting oxidized, and this is accepting 3. Transaction is only of 3. So valency factor over here only is also 3. So this is an intramolecular redox reaction. Some people say, sir, why it is not a disproportionation reaction? Beta, in disproportionation reaction, the same element gets oxidized and sir, they are the same element. Nitrogen from a similar species. Like if the nitrogen of ammonium ion, this must not be here. If this only get oxidized also and they get reduced also. Like in case of hydrogen peroxide, remember? I'll just repeat that example for you. In case of hydrogen peroxide, if you remember, this oxygen was only getting oxidized also and this oxygen only was getting reduced. So it is a disproportionation reaction, whereas that was an intramolecular redox reaction, not a disproportionation. Sir, if we have a disproportionation reaction, how can we calculate the equivalent weight? Now I'm telling you. So for a disproportionating species, how will you calculate its valency factor? Now there's a statistical method. It is not a derived formula. Let me give you that. Bromine in basic medium Br2, 0 oxidation state, changes to bromide. This Br2 only also changes to bromate ion BrO3 minus. Oxidation state -1 + 5. From 0 to -1, it is getting reduced. From 0 to +5, it is getting oxidized. So similar species getting oxidized also, reduced also, a disproportionation reaction. Sir, how will you calculate the valency factor? Now there is a statistical approach for this. You have to know it. It is not a derived form. For such cases, it is said that if you have to calculate the valency factor or maybe the equivalent weight, so the equivalent weight of such species will be equal to the molecular weight of species upon N1 plus the molecular weight of species upon N2. What are these N1 and N2? These N1 and N2 are the transacted electrons in both the halves. Like in the oxidation half, what is the transaction from 0 to +5? So this is 5. But for one species, how many bromine are there? 2. So one bromine will go to 0 to 5 by giving 5 electrons. But one molecule has how many bromine? 2. So 5 into 2. So the value of N1 will be 10. What is the reduction thing going? From 0 to -1, so I am accepting 1 electron. But how many bromine are accepting this? 2. So into 2. So N2 value will be 2. So what will be the equivalent weight of Br2? Doing this disproportionation reaction, molar mass of Br2 upon 10 plus molar mass of Br2 upon 2. Take the LCM, whatever you will get will be the equivalent weight and will definitely, the LCM will be your valency factor. I hope I'm clear. Moving ahead. Now, this equivalent weight calculation can also help you to solve some type of question. The type of question which I'm intending to tell you is this. If you have to calculate equivalent weight of any compound, let's say any metal oxide. Remember, when you deal with equivalent weight, you do not have to worry about their valencies, their balancing, anything else. So, I do not know the formula of metal oxide. Metal oxide, I just know oxide is 2, so crisscross 2 will come over here. I do not know the charge on metal. It's a metal, so it's a positive charge. This plus X, therefore this X is a variable. So I do not know the molecular formula of the compound, but I can still say this. What? Remember, while balancing moles, we have to know the reactants and then balance, but while balancing, equating the number of gram equivalent of equivalence says number of gram equivalent is always equal. Similarly, if you need to calculate its equivalent weight, it is simply equivalent weight of metal plus equivalent weight of oxygen. I am indifferent with the fact that whether this is 2 or this is X, because this will be accounted by the valency vector. You do not have to take tension of it. So equivalent weight of metal oxide will be equal to equivalent weight of first half, which is metal, plus equivalent weight of oxygen. Sir, how it is helping us? That's why I've given a question mark for equivalent weight of oxygen. Moving to other slide. Let me rectify that confusion of yours. This one. Suppose you are in the question I asked in such a way. Let's say you are given X gram of metal, reacts with Y gram of oxygen, and you're forming metal oxide. What the questionnaire will do, it will hide one of the variable and will ask you the question. How will you solve the question? The questionnaire can ask you anything. You just have to do that law of equivalence. If metal and oxygen are reacting to form metal oxide, I do not know what is the balanced reaction. I can always say number of gram equivalent of metal will be equal to number of gram equivalent of oxygen. And because weight of both these species are given, so what form of number of gram equivalent you will use? Weight upon equivalent weight. So weight of metal is X, equivalent of metal is E. Maybe questionnaire will ask you equivalent weight, so you can find E. X will be given. What will be equivalent weight of number of gram equivalent of oxygen? Sir, equivalent weight of oxygen upon equivalent weight of oxygen is Y. Sir, equivalent weight of oxygen you have written. How? My dear students, oxygen from O2 is changing to oxide as in O2 minus. Do the math. What is the math? How many oxygens do you have? O2 is in zero oxidation state. So one molecule of O2 going from 0 to -2 oxidation state. What is the number of electrons transacted? Sir, 2. How much? 2. But sir, one oxygen will do this. This one molecule has 2 oxygen atoms. So what will be the overall valency factor? 2 into 2, 4. So can you tell me what is the equivalent weight of oxygen? Yes, sir. Equivalent weight is what? Molecular weight, which is 16 into 2. Molecular weight of oxygen is 32. Upon what is the valency factor? 4. Solve it. It is 8. Use the same thing here also. Sometime the question can ask you, there's a metal chloride. Number of gram equivalent of metal will be equal to number of gram equivalent of chlorine. Again, weight upon equivalent weight. Weight upon equivalent for chlorine. Again, you know the equivalent weight. How? The same analogy. Chlorine from Cl2, that is zero oxidation state, is turning into chloride, that is chlorine in -1 oxidation. Chloride is chlorine in -1 oxidation state. What is the number of electrons transacted from 0 to -1? It is 1. 1 chlorine, 1 Cl2 has how many atoms? 2. So it is valency factor is 2. What is the equivalent weight of chlorine? Equivalent weight of chlorine would be 35.5 into 2, because Cl2 into 2 upon valency factor is 2. So what is its equivalent weight? 35.5. Keep these things in mind. Don't do them through basics while doing paper. It will save your time and give you a tremendous edge. Again, also do for nitride, although not these two are very famous. This is not, but again, I'm telling you, metal plus nitrogen forms metal nitride. Equivalent weight of number of gram equal of metal will be equal to number of gram equal of nitrogen. Weight of metal upon equivalent weight of metal, weight of nitrogen upon. What will be the equivalent weight of nitrogen? Let me do it. Nitrogen from 0, nitride. Nitride is nitrogen in -3 state. So -3 oxidation state. From 0 to -3. Number of electron transacted is 3. How many atoms are there in N2? 2. So total valency factor will be 6. Equivalent weight of nitrogen will be N2. 14 into 2 is 28 upon 6. Bingo. Moving. You will get so many questions regarding it. I am just covering everything because these are basics. I've already discussed so many questions of stoichiometry. So moving ahead. Now, sometimes there's a doubt in our mind. What is that? I'm giving you a question. Equivalent weight of acids are always equal to the number of H plus they gives. True or false? False. Sir, you said it was true. Any substance, their equivalent weight is decided by what type of reaction they are doing. Generally, acid releases all the H plus. Like for example, potassium dichromate is reacting with HCl and I am giving you the complete reaction. You have to tell me what is the equivalent weight of HCl. Sir, equivalent weight of HCl is molecular weight upon valency factor. For HCl, valency factor is always 1. No. You have to open your eyes and always check what HCl is doing right now. Here, HCl is undergoing redox also. How can you say? You see chlorine in the reactant, so chlorine is only present over here. What is the oxidation state of chlorine over here? -1. Sir, here chlorine is again in -1 state. Here it is also in -1 state. Here, oh, it is doing redox, sir. Generally, an acid, when you take its valency factor to be number of H plus it is releasing, when the H plus is in form of H plus, it is not participating in redox reaction. Here, some of the HCl is used for the redox, and some of the HCl you have to use in order to balance, to be the spectator. Like 1 K2Cr2O7 is requiring 14 HCl. With all the HCl, it is not fighting for exchange of electron. So out of those 14 HCl, with some HCl, K2Cr2O7 is fighting, doing redox, and with some HCl, they are circling around. Darshak, spectators. So I need HCl as spectator also, and I need for redox also. In such cases, you have to again go by basic. You do not know their equivalent weight. Their equivalent weight is dependent upon the condition. Sir, how can we now calculate equivalent weight? Let me help you. Basic never fails you. What I have told you to how to equate moles of a reaction. Let's say A moles of K2Cr2O7 are reacting with B moles of HCl. Let's say, question will be giving you something. So, according to moles of reaction, remember equating the moles thing. So, number of moles of K2Cr2 reacted is A upon stoichiometric coefficient is 1 will be equal to number of moles of HCl reacted is B upon its stoichiometric coefficient is 14. This is equation 1. Sir, you said not to write moles of reaction. If balanced reaction is given, write moles of reaction. Write number of gram equivalent also. By law of equivalence, what you know? By law of equivalence, what you know? Number of gram equivalent I never write. I have written it so many times. So number of gram equivalent, I always do this. Number of gram equivalent of K2Cr2O7 will definitely be equal to number of gram equivalent of HCl because moles can be equal or not. But what is always equal? Number of gram equivalent of A will always be equal to number of gram equivalent of B. Number of gram equivalent can be formulated as number, because moles are given, number of moles into valency factor. So what are the moles of K2Cr2O7 getting reacted? A. What is its valency factor for K2Cr2O7? I know. It is doing a redox only. No chromium is left. Potassium is a spectator ion only. Dichromate is the reacting species. From +6, it is going to +3. So from +6 to +3, remember, from +6 to +3, 3 electrons are transacted, but this one molecule has 2 chromium. So what is the valency factor for K2Cr2O7? 6 is equal to number of moles of HCl reacted is B. What is its valency factor? That we do not know, sir. This we have to calculate. Take it as VF. I have equation 2. What you have to find? Sir, valency factor. Equate them. How to equate them? Very easy. Equation 1 is what? A is equal to B by 14. Equation 2 is what? This. Let us replace B. B is equal to 14A. So this is LHS is 6A in equation 2. Replace B. So B can be replaced by 14A into, sir, valency factor we needed. You have given us valency factor. A getting cancelled. So valency factor will be equal to 6 by 14 as in 3 by 7. So if I'm asking you equivalent weight of HCl, it will be molar mass of HCl as in 35.5 plus 1, that is 36.5 upon is the thing which I'm interested in, 3 by 7. It is not 1. It is not 1. It is 3 by 7. A very good type of question indeed. Moving ahead. Now, moving ahead with the balancing of redox reaction, and these balancing questions also asked in mains, also asked in advanced also. So, how you balance a redox reaction? So basically NCERT offers 2 methods for balancing of redox reactions. First is the oxidation number method, and the second one is the ion electron method. Oxidation number method, I would vouch for whatever valency factor calculations we have done, that is more than sufficient for you to do oxidation number method. You do not have to balance reaction as per oxidation number method. Why? Because there are some problems you would be failed to use that method. So why go into that method at this point of time when time is actually money? So ion electron method will give you redox reaction balancing also, not for mains question, for advanced questions as well. Now, if you want to balance a redox reaction using ion electron method, you have to balance in acidic medium or in basic medium. I have properly written those rules for you. Let me sum them up for you. First, you have to identify the 2 half reactions and write them separately. You will only write those ions which are actively participating in that redox half reaction. After writing the half reaction, first thing you have to do is leave oxygen and hydrogen and balance the other elements. After balancing, now you balance oxygen by adding water. Now, in order to balance hydrogen, you have to add H plus ions. If medium is acidic, you have to repeat the same step in basic medium also. But if the medium is basic, after adding those H plus ion, add OH minus ions also. How many OH minus ions? Exactly same as H plus ions, but on both sides, because mathematically there will be no difference. Because if X is equal to Y, X plus 2 will be equal to Y plus 2. Now add electrons and then quantify the electron transfer so that whatever electrons are consumed should be given out. After quantifying, add the 2 reactions and bingo, you have your balanced reaction. Sir, these rules you have written, show us how you do that. Start with an example. So here KMnO4 is reacting in acidic medium with potassium oxalate to form manganese sulfate, CO2 and potassium sulfate. Now, with those oxidation number method, you can write that oxidation numbers, but I wish you just, while practicing, you will definitely get to know that what are the 2 half reactions. Like, potassium ion is not undergoing any transformation because it is +1. Here also it is +1. So, who is the active ion who is getting the redox change, sir, per manganate ion, which is MnO4 minus. MnO4 minus is changing to what, sir? It is changing to Mn plus 2 because sulfur oxidation state is still the same. So sulfate is a spectator ion. So in ion electron method, I do not wish to know what spectators are doing. I only wish to get the active ions. I have written the half reaction. What is the other half? Sir, other half is oxalate ion is changing into CO2. Write it. Oxalate ion is C2O4 2 minus. It is changing into CO2. After writing these two half reactions, individually work on both halves. Apart in the first half, apart from oxygen and hydrogen, what is present? Manganese, balanced. In order to balance oxygen, you have to do what? Add water. How much water you will add? Sir, there are four oxygen atoms. So I'll add 4 water molecules because one water has one oxygen. How many hydrogens you have, sir? 8. So how many H plus you need? 8. So I'm adding 8 H plus ions. Now balance charge. Plus 8 minus 1 is plus 7. RHS is plus 2. How much electrons you need? 5 electrons. Balanced. This, apart from oxygen and hydrogen, I have carbon, 2 carbon over here. So 2 will come over here. Oxygen, already balanced. Do not have to add water. Do not have to add H plus. Balance charge 0 minus 2. So 2 electrons. Now, I was saying quantify here one per manganate is taking 5 electrons, but one oxalate is giving 2 electrons. How will you balance this transfer? Multiply this equation by 2. Why? 2 is its coefficient and 2 into 5 is 10. So it will gain 10 electrons and multiply that 5 over here because 5 into 2 will give you 10 electrons. So 10 given, 10 taken. Big deal. Transaction done. Bingo. Now add these two reactions. I'm adding these two reactions for you in this side. 2. First add right LHS. 2 into MnO4 minus. So twice of MnO4 minus. Then 8 into 2 is 16 H plus. LHS of first half is done. Sir, why not written electrons? Beta, 10 electrons in LHS, 10 electrons in RHS will get cancelled. Why bother? What is LHS of the second half? 5 of this. So 5 times of C2O4 2 minus, which is the oxalate ion, giving you what? 2 times of Mn plus 2. 8 times of water. 5 into 2, so 10 times of CO2. Electrons cancelled. Sir, I have got the balanced reaction. Sir, but in the question, molecular equation is asked. You have only balanced the ionic form of the equation. No worries. Call the molecule furnishing these ions. Call those many molecules who will be furnishing this many ions. How many per manganate MnO4 minus you need? 2. Who is furnishing MnO4 minus? Sir, KMnO4. So what will be the coefficient of KMnO4? 2. Why? Because 1 will furnish 1, so 2 will furnish 2. But this spectator I have not balanced. Circle it, because if everything has been done correctly, spectator will automatically be balanced. They are just spectator. They'll clap, and if you are doing right, the clapping will be for good. Now, who is furnishing H plus ion? Sir, H2SO4. How many H plus you need? Sir, I need, okay, beta, twice of MnO4 minus 8 into 2 is 16. By mistake, I have written 6. 8 into 2 is 16 H plus ions. So how many H plus ions you need? 16. So how many water H2SO4 molecule will take? 8, because one H2SO4 gives 2. So 8 will give you 16. But sir, sulfate is the spectator, circle it. How many oxalate ions you need? 5. So how many K2C2O4 you use? 5, because 1 furnishes 1, so 5 will furnish 5. What is the spectator over here? Potassium, circle it. Right side, how many Mn plus 2 you need? 2. So what will be the coefficient over here? 2. Sulfate is the spectator and circle it. How many CO2 you need? 10. CO2 is a molecule only, so 10, no spectator. This is a spectator molecule, definitely used to balance those spectators. Now, let us work on potassium also only. How many potassium you have in LHS? Sir, 2. And 5 into 2 is 10, so 12. Potassium is only here, so if I need 10 plus 2, 12. So I will write a 6 over here, because 6 into 2 is 12. Potassium is balanced. So I'm ticking this. I'm correcting this because this problem is solved. If everything is right, sulfate would also be balanced. Calculate sulfate on LHS. Sir, 8. Only 8. So I have 8 sulfate on LHS. Sir, 2 and 6. Problem solved, balanced. This is how you balance a reaction, a redox reaction in what medium? This is how you balance a reaction in acidic medium. So now moving to basic medium. This CrO4 2 minus reacts with I minus, forming Cr plus 3 and iodate ion, IO3 minus, and this I have to balance in basic medium. So first thing is, write the the first half is this one. First, let us work on this half. Apart from oxygen and hydrogen, balance chromium, already balanced. In order to balance oxygen, add water. In order to balance hydrogen, add H plus. But sir, medium is basic, so add that many OH minus ions equal to H plus ions, but on both sides. And we very well know water is not an electrolyte, so this will give you 8H2O. Now, this is 8H2O, this is 4H2O, 4H2O and 8 will get cancelled. You will get only 4H2O on left hand side. After that, balance charge. LHS, what charge you have? -2. RHS, what charge you have? -8 and +3. That is -5. So -5 on right hand side and -2 on left hand side. How many electrons you need? Sir, 3 electrons. So this is how you have balanced the first half. Now moving to the second half, changing color. What is the second half, sir? I minus changing to IO3 minus. Apart from oxygen and hydrogen, I have iodine already balanced. In order to balance oxygen, I have to add 3 water. In order to add hydrogen, I have to add H plus, add equal number of OH minus ions on both sides. H plus and OH minus, because water is not an electrolyte, will associate to form water molecules. 6 water, 3 water. 3 got cancelled, 3 remaining over here. Now, in this half, balance charge. LHS, how much charge? -7. RHS, -1. So how many electrons I need on the right hand side? 6 electrons. Bingo, done. Now what you have to do? Add the 2 half reactions by equating the electron transfer. It is giving you 6 electron. It is asking for 3. Multiply the above equation by 2. Why? 2 into 3 will give you 6 electrons. Multiply the bottom equation by 1, because 6 into 1 is 6 electron. Electron transfer is getting satisfied. Right. After multiplying these equations, add them up. Write LHS on left hand side, RHS on right hand side with these coefficients. So for the above one, 2 into. So twice of CrO4 2 minus, then 2 into 4, that is 8 times of water. LHS of first is done. What is LHS of second? 1 into I minus and 6 OH minus ion. So I minus plus 6 times of OH minus ion will give you what? LHS done. Twice of Cr plus 3, I'm sorry. Then 8 into 2 is 16 times of OH minus ion. Then of the bottom plus IO3 minus into 1 and 3 water. I guess something is still getting cancelled. So simplify. 3 water, 8 water, 5 remainder. 6 OH minus, 16 OH minus, 10 remainder. Balanced. Acha, this water in the previous one, this 8 water molecule also will be there in RHS because it was not given in the question, but this water has come. So this is plus 8 H2O. This is the complete balanced reaction. So this is how you balance a reaction in acidic medium and now in basic medium. Again, practicing some more question. One for disproportionation. Disproportionation is Cl2 changing to Cl minus first half, Cl2 only changing to ClO3 minus second half. Write the two half reactions separately. For a disproportionating species, this will get oxidized also, this will get reduced also. I do not know what is oxidation reduction. I'm not writing oxidation number. If doing everything right, it will automatically be correct. Apart from oxygen hydrogen, I have chlorine, no oxygen hydrogen, so it is simply balanced. First half is simply balanced. Second half, apart from oxygen hydrogen, I have chlorine, so chlorine balanced. Oxygen, 6 oxygens. How much water I have to use? 6 water molecules. Done. In order to balance hydrogen, I need to have, okay, 6 into 2 is 12. So there will be 12 H plus ion, but medium, my friends, basic. Add the same amount of OH minus ion, but on both the sides. H plus OH will form 12 water molecules. Water is getting cancelled. 6 water, 12 water, 6 is remainder. Balance charge. How, sir? Minus 12, minus 2. What to do? Minus 12, minus 2. Sir, add 10 electrons. Done. Equate the transaction. Taking 2 electrons. 5 of you come, 5 into 2 will be 10, giving 10 electrons, only you will come, so into 1, add the two reactions, 5 into Cl2, LHS of first is done, 1 into Cl2, so 5 Cl2, 1 Cl2 will make it 6 Cl2, then plus 12 times of OH minus ions. I guess LHS is done. Just check. Yes, it is done. Then 5 into 2 is 10 Cl minus, bingo. Then twice of ClO3 minus, twice of ClO3 minus, bingo. Then 6 times of water, 6 times of water. Completed. Is it getting simplified? Yes. It is getting divided by 2. So simplify it. This 2 gone, this 10 becomes 5, this 6 becomes 3, this becomes 3, this becomes 6. Balanced reaction. Told you. Exactly the same question was asked by advance. Try it. Let me sip some water. So this question is asking you to balance this reaction, but you have to identify what is the medium. Sir, H2SO4 given, acidic medium. Beta, HSO4 minus also given. Now tell me, sir, H plus and OH minus can also be thought of as, if H plus is given by H2SO4, if H plus would have been existing, H plus would be given in the reaction. But because HSO4 minus is only mentioned, H plus is not mentioned, sir, then just like OH minus, this medium is HSO4 minus. Let me try and solve it, keeping that reference in mind. What is the first half? Sir, I minus changing to I2, very easy. This 2 and this 2 electron, first half is balanced. Now, second half, ClO3 minus, giving you Cl minus. Apart from oxygen, hydrogen, chlorine is balanced. In order to balance oxygen, I'll add water. In order to balance hydrogen, I'll add 6H plus 3 into 2. But medium, this is not giving me H plus, this is giving me HSO4 minus. So add HSO4 minus, because H plus and HSO4 minus will form H2SO4. The similar logic which we use for OH minus. That's why I told you, use ion electron method. Advanced question means, so you will do. Advanced question also is a gift for you. So take that gift. So add equal number of OH minus ion, not OH, this case HSO4 minus ion, but on both sides. H plus and OH minus will be giving you the similar number of H2SO4 molecule, which is only mentioned. After balancing this, balance charge. So charge in LHS is -1. Charge in RHS is, this -1 is, so extra 6 electrons has to be added. So these are 6 electrons. Equate charge. It is taking 6 electrons, it is giving 2. So 3 of you come and join our party. Add the reactions. LHS, 3 times of 2 is 6 times of I minus. LHS done. This is 1 only. So ClO3 minus plus 6H2SO4 giving you thrice of I2 plus Cl minus plus thrice of water plus 6 times of HSO4 minus. Anything is getting cancelled? No, bingo. And you know what? It was a multiple correct question in JEE Advance. Moving on to the next slide. Titration. Actually, this is done in ionic equilibrium, but nothing to worry, because the common sense it uses is law of equivalence. Now, what is titration? Sometimes a solution is provided to you and you are asked to calculate its concentration. How to calculate its concentration? Law of equivalence. But experimentally what you do, you take another solution in burette. This apparatus is called burette, and the solution you have taken over here is filled till the brim. And its concentration you know. You put an indicator over here because these two are reacting. You switch on this tap. By drop, this reagent will try and react with this reagent. If complete this reagent is reacted with the above reagent, you have to close the tap. Sir, will the reagent in the downside dance and tell, I'm done, I'm finished? No. That's why we add an indicator which changes the color and it tells us that it's time to close the tap. So close the tap, some volume will be getting to the downside. This volume is labeled as 0 ml. Whatever volume has been consumed, let's say this is 12 ml. So how much ml has been used? Sir, 12 ml. So volume of this, you know. And by using this volume, you calculate the concentration of this unknown substance. Substance, you know, its concentration is unknown. This process is called titration, and therefore, because we are using volume to calculate its concentration, therefore this is also termed as volumetric analysis. So titration or volumetric analysis is done to determine concentration of an unknown solution. Unknown solution generally kept in beaker. That solution is also called in English titrand or titrate the solution whose concentration you know is a standard solution, not sophisticated, standard as in you know its concentration, and also known as titrant. The titration you do, the simple type of titration JEE asks is acid-base titration and redox titration. What is it? Piece of cake. Acid-base titration, what they give? One reagent in downside, one reagent on upside. Like for example, H2SO4 here, NaOH over. Generally, this concentration is unknown experimentally. But the questionnaire designs a question in such a way that it can ask you anything. Sir, what I have to do? I have to write the reaction. Remember why we have formulated this number of gram equivalent? Because I do not have to write the reaction. Whenever this titration process is done, I can always say for acid base, I can always say number of gram equivalent of acid will be equal to number of gram equivalent of base. What is the acid you are using? H2SO4. So out of those 4 formulas of number of gram equivalent, what formula you will use? Sir, normality is given, so I'll use normality formula. So for acid, normality of acid into volume of acid in liters. It is equal to, for base what is given? Molarity. So what formula you will use? The molarity one. Molarity into volume into valency factor. Put the value. Normality is given as 1/10. How much volume? 100 ml. 100 upon 1000 will be in liters. Although because this volume is also ml, this volume, this 1000 will get cancelled. So you can also equate number of milligram equivalent. But still, I'm doing this with simple basic. So molarity, this molarity you have to calculate M. Valency factor for NaOH is 1. And volume used is 150 ml divided by this 1000. I told you this 1000 will get cancelled. Solve for M. Such a piece of cake is asked many times in mains. Sir, what is redox titration? They are doing neutralization. Take 2 reagents who are doing redox with each other. So, number of gram equivalent of. Acha, by the way, this is a JEE question. Exactly JEE question. What I've done is, what we have done in stoichiometry. The word problem I've curated as a photo. So, what you will do? Sir, law of equivalence. What is law of equivalence? Number of gram equivalent of U. Who are you? K2Cr27. Okay. Equals number of gram equivalent of U. Who are you? Acha, ferrous oxalate. FeC2O4. What formula I'll use for K2Cr27? Sir, molarity given. So use molarity formula. So molarity I'm directly using. Na? Molarity into volume that I have to calculate, but it is in ml. So upon 1000 into valency factor. Remember K2Cr27 an acidic medium forms Cr plus 3. Valency factor, go to the previous slide, 6. These things you should remember. Answer comes like in Ziffy. Now, ferrous oxalate, remember, valency factor 3. But what formula you will use for number of gram equivalents? Sir, weight given. Weight upon equivalent weight. What is the weight that is reacting? 0.288 gram upon equivalent weight of ferrous oxalate. Molar mass given. Very good. Molar mass is 144 upon valency factor is, we have just calculated. Go to the above slides. 3. Do the math. Answer a JEE question. Now, moving ahead. Again, a JEE question. Just write this. Redox titration. That one I formulated as a picture. This is a word problem. Read the question. 2 ml of KMnO4. Unknown molarity. Okay, this have to find. Molarity has to be found. Required to reach end point of titration. End point is when indicator changes color. 20 ml. Okay, volume given. Oxalic acid molarity given. Sir, number of gram equivalent of KMnO4 equals number of gram equivalent of oxalic acid H2C2O4. Done. KMnO4. Acha, KMnO4 an acidic medium. This you have to remember. The KMnO4 has 3 criteria. Acidic, basic, neutral. In acidic, changes to Mn plus 2. Valency factor was 5. So, molarity, sir, that I have to find. Volume, sir, 2 ml. And valency factor 5 of H2. Acha, This is not ferrous oxalate. This is H2C24. So Fe plus 2 was changing to Fe plus 3, therefore contributing 1. C2O4 2 minus will give CO2. So its valency factor will be 2 only. Molarity given? Yes, 2. H2, this 2. Volume 20. Valency factor 2. Do the math. Sir, here volume you have taken. You can also equate number of milligram equivalent. Na? That 1000 will definitely get cancelled. So just say milligram equivalent. Moving ahead. Now, very few questions are asked, but you should know what is volume strength also. We know H2O2 is a unstable. If you do not know inorganically, you should know H2O2 is an unstable solution. Decomposes to form water and oxygen. These days, pollution, Diwali, Delhi, heard it. These days, ozonizers are using H2O2 to create oxygen. So this H2O2 bottle, which produces oxygen, is sold industrially in the market. And what is its concentration term by which it is known? Sir, volume strength. What is the volume strength? Volume strength is defined as, if you take 1 liter of this bottle, what volume of oxygen gas it releases at STP. That volume in liters is called the volume strength of this H2O2 solution. Okay, sir, that means you are focusing on 1 liter. Okay, so let us suppose its molarity is capital M, and I have capital M molarity of H2O2 solution whose volume is 1 liter. So we very well know, my friends, molarity is equal to number of moles upon volume of solution in liter. If I have taken 1 liter of solution, remember, one variable gone. So number of moles is nothing but molarity. This M. Okay. Sir, do stoichiometry. If 1 mole will decompose, how many moles of oxygen will be produced? Half. So if 1 produces half, so M moles will produce M by 2 moles of oxygen gas. Simple. And sir, we know 3 formula for number of moles. Use that one for volume. Number of moles is equal to volume of gas released at STP. Arey sir, that volume is also known as volume strength if that gas is oxygen given by H2O2. So this volume of oxygen gas released at STP is nothing but volume strength, the numerator, upon 22.4 the molar volume. So what is your relation? Relationship is volume strength is equal to 11.2 times of molarity. Sir, how can you relate normality with volume strength? Normality is equal to molarity into valency factor. What is valency factor for this half? Oxygen from -1 is going to 0 state. So what is the transfer? 1. Sir, per 1 molecule has 2 oxygen atoms. So into 2. So valency factor for this transfer is 2. So normality is equal to molarity into 2. Replace molarity by N by 2. So you can relate volume strength and normality as well. Moving ahead. Technically speaking, redox is done. Very few questions of some other titrations, although they are advanced topics, but means, you know, na? They incorporate advanced questions. 2 types of titrations are also asked: double titration and back titration. So what is double titration? Double titration, as in I told you, na, we use indicator to check that I have to close my tap. There are 2 indicators, phenolphthalein and methyl orange, loved by JEE. What are they? Methyl orange pH range, we'll discuss more in ionic equilibrium, but this is just basic, you should know this. Its pH range is 3 to 4.5. As in, it changes color when pH changes from 3 to 4.5. Beyond 3, it has some different color. Beyond 4.5, it has some different color. I tell you, beyond 4.5, methyl orange is red in color. Beyond 4.5, methyl orange is in acidic, in basic solution, it is yellow in color. And when it gets acidic, it becomes red. So in basic medium, beyond 4.5, it is yellow in color. and below 3 it is red in color. So if I use methyl orange as an indicator to my titration process, suppose I am using two bases, NaOH and sodium carbonate, and HCl is I am supplying through burette. Opening the tap. So if methyl orange is mixed with this base, both are bases. So if base is mixed with methyl orange, a pH of more than 7 will be there. So color will definitely be yellow. Okay. So this yellow color base, I have opened the tap, HCl will go and hit to those bases, bham, 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 and neutralize the solution. How will it, if it is NaOH, HCl forms NaCl in water. Once NaCl formed, it is neutral solution, pH will reach 7. 1 or 2 drop, we will mathematically see this in ionic equilibrium. Whenever end point, as in titration, one acid has completely finished another, after just 1 drop, pH drastically changes. So you say, sir, here neutral pH is 7, 1 drop will fall, 1 extra drop, pH will be drastically below 7. So it will definitely reach below 3 and color changes. When color changes, you close the tap. So methyl orange can clearly give you neutralization of NaOH. When complete NaOH is destroyed by HCl, then only color will change. Similarly, sodium carbonate, when reacts with HCl, forms NaCl and H2CO3. Although H2CO3 is also an acid, but an unstable acid, forms H2 and CO2, although an acid. So when this is formed, pH will not be 7. It will be slightly less than 7. Slightly less. It will change color after below 3. So few drops of HCl will be dropped more and then color will change. So we say methyl orange shows complete neutralization of NaOH also, sodium carbonate also. One thing. This is the reaction you should keep in mind. But there is an indicator called phenolphthalein. Phenolphthalein has a pH range of 8 to 10. In basic medium, its color is pink. So if I have a base, let's say if I have NaOH or Na2CO3 over here, its color will be pink. Acid is supplied from upside. Acid comes, reacts with base, getting reacted. Once the last base is finished, 1 drop will change color. So NaOH it is a neutral medium. So it will change its color. It will change its color. So phenolphthalein gives you complete neutralization of NaOH. Complete HCl will neutralize NaOH and form neutral solution. Color will change. You will know the exact volume and color has changed. But sodium carbonate, my friends. Sodium carbonate, when reacts with HCl, forms NaCl and sodium bicarbonate. Sodium bicarbonate is an acidic salt. Sodium bicarbonate still contains H. So this salt, when formed, reaches a pH range below 8 because it's an acid. If acid, pH is already somewhere around 7 and its range is 10. So color changes. So it cannot show complete neutralization. How many moles of HCl was needed by Na2CO3 to completely neutralize? 2. Because complete neutralization will form NaCl, H2 and CO2. But over here, H2CO3 is not formed. So Na2CO3 forms reacts with only 1 mole of HCl and forms this and color changes. And because color changes, you will close the tap. If you will close the tap, more HCl will not be provided. So complete reaction will not be done. So actually with phenolphthalein, half neutralization of sodium carbonate is done. Because sodium carbonate, 1 mole is needing 2 moles. But I am closing the tap in 1 mole. So this thing, keeping in mind, was asked in JEE, and this question, I have given you the question also and I have curated a summary also for you. Just try it. Yes. So over here, you must have attempted and seen that you have 4 0.4 gram mixture of NaOH and sodium carbonate. There are some impurities also, but it can be approximated that it is negligible. Why? Because the answer is formulated in such a way that it will be neglected. So basically you have 0.4 gram mixture of these two. I do not know how much weight is this and how much weight is this. And you are asked what is the percentage of Na2CO3 in that mixture. So let's say A moles of NaOH is present and B moles of sodium carbonate is present. We are doing that titration. What titration? That double titration, which I have spoken to you about. So 0.4 gram of NaOH when titrated using phenolphthalein, and what was it getting reacted with? HCl. And normality of HCl is given out to be n by 10, that is normality is 1 by 10. So I know the acid for HCl valency factor is 1, so its normality is equal to molarity. So let's say its molarity is given to be 1 by 10. Now we are doing this using phenolphthalein. Remember, with phenolphthalein NaOH completely reacts, but sodium carbonate reacts to form sodium bicarbonate. So I've just written that reaction because this is with phenolphthalein. The question is saying how much HCl is used for this neutralization. 17.5 must have been used and you have switched off the tap. So 17.5 ml of HCl was totally used and these two were consumed. Stoichiometry. 1 mole of this will form 1 mole of this. So A mole will form A mole of this. B mole of this will form definitely B moles of this. So number of moles of sodium bicarbonate produced is B moles. That many number of moles, which was the actual mole for sodium carbonate. This you have to remember. B is number of moles of sodium carbonate. This you have to remember. And because 1 creates 1, so B will form B. Why I am telling you this is because the question says when I further use methyl orange, I know what methyl orange will do. Methyl orange will not leave sodium bicarbonate also because it completely neutralizes sodium carbonate. So sodium bicarbonate will further react with HCl. Why HCl? More HCl will be given because with methyl orange color will not change. You will again open the tap. So more HCl will be dropped. The question is telling you how much more HCl is dropped. Sir, 1.5 ml. So this extra sodium bicarbonate is using how much volume of HCl? 1.5 ml. Do you know, can you write the reaction? Sir, already you have written the reaction for us, curated that chemistry behind this word problem. So this 1 mole will be requiring 1 mole. How much moles of sodium bicarbonate you have? Sir, B. So how much moles of HCl would have been required for this extra titration? Sir, B. So B can be calculated. Why? Because its normality, molarity is known, its volume is known. Molarity is equal to number of moles upon volume. So B can easily be calculated. Let us calculate B. So I can definitely say, what is this B? Number of molarity is equal to number of moles upon volume. What volume was required? 1.5 ml. So this is 1.5 ml. So into 1000 because volume has to be in liters. This molarity is given out to be 1 by 10. So what is the value of B, my friends? 1.5 into this 10 raised to the power 3 and 10 raised to the power 4. So it will become 10 raised to the power minus 4 moles. Done. Now, what are you asked? You are asked weight percent of Na2CO3. First, you have to calculate weight of Na2CO3. I guess this is moles of Na2CO3 also. So, you know moles of Na2CO3. How you will calculate its weight, sir? So, number of moles is equal to weight of sodium carbonate upon its molar mass. What is its molar mass? Its molar mass is 106. Weight of sodium carbonate is obtained. Let me help you. This into divide will be slightly difficult. So this JEE does. You calculate. I am, because we have consumed already so much of time. So 106 into 1.5 is how much? It is 159 into 10 raised to the power minus 4 gram. This is the weight for sodium carbonate. Now what I have to calculate? Sir, I have to calculate percentage. What will be its percentage? Weight of this compound, which is this much, upon total weight. What was the total weight? 0.4 gram. So upon 0.4 gram into 100 will give you answer. Solve it, the closest integer. Acha, I guess answer has to be reported. Now, you just have to calculate it and report to the nearest integer. So you will get your answer. Moving to the last question. Back titration. Sir, very rarely asked, but what is back titration? I told you, na, number of gram equivalent is a beautiful thing. Like, for example, sometimes you have to estimate what amount of oxidizing agent is present. Volumetric analysis. Like, I have an oxidizing agent of copper plus 2 over here. So there are some practical constraints sometimes. What are those practical constraints? We very well know, inorganically, if you do not know, you should know, that Cu plus 2 acts as an oxidizing agent and easily oxidizes I minus to form I2. So sir, do the titration. Actually, it has got some experimental, practical difficulties. Like inorganic facts, like I2 is a solid, so it does not dissolve. So you have to add excess of Ki, because with excess of Ki, it forms Ki3 minus and get dissolved. Indicators are not properly available in the nature, which can easily do this titration. So option 1 is cancelled because of practicality. As in, we cannot do this simple titration by using an indicator and closing the tap, or else I would have definitely estimated this copper plus 2, which is an oxidizing agent. So when you are using to volumetric analyze an oxidizing agent, this is also called iodometry. People fear it, but it has nothing in it. This practical method is not applicable. So what we instead do is, we know copper plus 2 reacts with I minus. So what we do is, we pour excess of Ki. That, hey, whatever amount of copper plus 2 you get destroyed, I've added excess of Ki. That excess of Ki will react with, actually I minus will react with copper plus 2 like this and will form this. But I do not know how much of this is formed. If all the copper plus 2 has reacted with I minus, I2 will be formed. Now we have an experimental fact that I2 can easily be estimated. By what? You take that I2 produced, although that excess of Ki will also be present, but that produced I2 will also be present. So I2 has a property of reacting with hypo solution. That's why hypo is very famous. What is hypo? Na2S2O3. What is its active ion? S2O3 2 minus. I have given in the oxidation state also. This hypo, when reacts with I2, when I2 is completely destroyed, we have a very beautiful blue color starch indicator. Starch indicator which changes color, and we close the tap. So this is called back titration. Why back? Because how much U are created, I am estimating through the I2 produced and back titrating that I2 with a standard solution. What is a standard solution? Hypo. Standard solution as in its concentration is known. Sir, why you are telling us all this? This is actually ionic equilibrium basic, but obviously because you have studied law of equivalence. Sir, do I have to balance this reaction? Remember, no. I can always say number of gram equivalent of Cu plus 2 present is equal to number of gram equivalent of I2 produced, and how much I2 will be produced will be here also, and number of gram equivalent of I2 produced will here react with number of gram equivalent of hypo. So this will be equal to number of gram equivalent of hypo. So do I have to write the balance reaction? No, I'm just equating. This is not these elements, these are their number of gram equivalents. So I'm just writing it for you so that you may not forget. These are their number of gram equivalents. So equate them. Whatever is supplied, use them and use formula for number of gram equivalent. So for hypo solution, data is there, and for copper, data is there. Leave I2 because the number of gram equivalents are equal. So okay sir, let us leave it. So you tell me, for copper, what formula for number of gram equivalent you will use? Sir, for copper, what is given? 10 ml volume is given and molarity is asked, so use molarity formula. Let's say molarity of copper is M into its volume is 10 into valency factor for copper. Where is the redox taking place? Copper from +2 is changing to +1. It has only one copper. So copper from +2 is changing to +1. How much electron are getting transacted? 1. So what is the valency factor? 1. Use that for hypo also. For hypo also, molarity and volume is in ml. So ml will get cancelled. So I have equated number of milligram equivalents. So for hypo, I am doing this for hypo now. What is its volume? 20. What is its molarity? 0.02. What is valency factor for hypo? Remember, reaction is also given. This is 2 and this is 2.5. But for half for 1, it has 2. So valency factor is also 1. We have already done that. Solve. You will get your answer. You have to report the answer in 10 raised to power -2. So solution is, I'm leaving it to you. So thank you very much. This is the first chapter that we have done, and by this chapter you must have got that feeling that yes, we can very well do it, because we have covered 2 chapters in which YouTube is flooded with like 20 hours of excessive. This data, if you find, you will be wasting a lot of time. So we have well curated these lectures for you so that you may feel that you are going in the right path. Thank you, and we'll meet in the next lesson. Don't worry about these lecture notes. These will be provided to you in the PW app, whose link is given in the description below. Thank you. Meet you in the next series.